While I do not think carefully defining gracious professionalism is essential, talking about it is very important. I think one of the main strengths of gracious professionalism is its dual modality. Gracious is mostly about feelings, both yours and those of others. Professionalism is mostly about knowledge and its application for good. Combining the two is important, so learn everything you can. I do not think and experience helping others as often as you can. Is essential. Being an effective contributor is very important. A huge part of feeling good about yourself. Rational self-esteem is a big deal. One of the main strengths it is a likely outcome is its from practicing modality. Gracious professionalism gracious is mostly while about busting feelings, your chops in first. Both yours and those of others. Good stuff. Professionalism is mostly about knowledge and its application for good. Combining the two is important, so learn everything you can. I do not think and experience helping others as often as you can. Is essential. Being an effective contributor is very important. A huge part of feeling good about yourself. Rational self-esteem is a big deal.
Hello everyone and welcome to the 24 Hours of STEM. My name is Ella from Team 3132 and I will be your host on the mass stream for the next 6 hours. Over the next 24 hours, people from around the world will present on interesting and thought-provoking topics associated with STEM and all FIRST Robotics programs. We want to be able to continue and share our appreciation for STEM, even in times of international hardships, so thank you for joining us today. Now, it is time to get into the presentations that will be featured across the two streams, Mass and Energy, for the next 24 hours. So just sit back, relax, and get ready to learn about STEM. It is my pleasure to introduce our first speaker, who will be talking to us about AI and machine learning in the FIRST Tech Challenge. So please join me in welcoming Tom Eng from FIRST. Hi.
Hey everybody,
Hi, Tom,
can you hear me okay?
Yep.
Okay, great. Sort of dark in my room, but that's okay. My name is Thomas, and we're going to be talking about artificial intelligence and machine learning in the FIRST Tech Challenge. And my background is a mechanical engineer, and I am the senior engineering manager at FIRST. And here's an agenda. Can you see my screen okay?
Yep, screen sharing is doing all good.
Okay, great. So today we're going to talk about artificial intelligence and machine learning. We'll just do a little general overview. Then we'll talk in specific about AI and ML within the first tech challenge. Then I'd like to talk a little bit about training and inference model. And when I mentioned the phrase inference model, that's the model that's used by a machine learning system to recognize patterns and make decisions and make guesses based on the patterns that it detects. We'll talk a little bit about the tools that we use in the first tech challenge to create these inference models. And then we'll end up with some fun activities that you can try on your own, which will give you some insight and some exposure to these machine learning and artificial intelligence technologies. So I'm not sure if, oh, and by the way, if you have questions, feel free to pose them through the, the question and answer mechanism for Zoom. And I might defer some of the questions till later, but I'll be happy to answer them. And the moderator can just, interject and raise the questions as they arise. But many of you probably have heard in the news, if you've been following it over the past few years, stories about artificial intelligence and machine learning. They're becoming more popular. And you might ask yourself, why is there such an interest in both of these topics? Well, even though these technologies are somewhat in an infancy, artificial intelligence and machine learning has matured, and people are doing or solving or trying to solve interesting problems using these technologies. And if you could put it in the context of today's days, with the COVID pandemic, you might have heard or read about some scientists who are using machine learning technologies to try and look for patterns to determine what kinds of policy decisions can be effective to reduce the spread of the COVID virus. And also they're looking at, for instance, drug candidates and methods to actually treat the virus, and using machine learning to try and see which would be potential candidates and more effective candidates to treat someone who's been exposed with COVID. And when we talk about AI and machine learning, when we talk about AI specifically, the term artificial intelligence is used to describe a machine or a device that mimics cognitive functions that are normally associated with a human or a human, or an advanced creature like, an animal, a dog or a cat or something like that. And so something like computer vision, we think of vision as in the past something that was distinctly, a higher order function of something like a intelligent creature, a human, animal, and so forth. But there are machines that can use cameras and can process images and recognize patterns and make decisions based on those images. And that, in essence, is an artificial intelligence type of this machine or device. Similarly with speech recognition, the ability to listen to sounds and distinguish specific words, spoken words, is something that formerly we would associate with a human function, but that can be done by a machine. And then more abstractly, problem solving and learning. These are things that can be done by machines, which are human-like, and therefore we consider them part of the artificial intelligence set of devices. When we talk about machine learning, it's similar, but it's a little different. In this sense, machine learning refers to the science of developing machines and algorithms that can perform tasks without explicit instructions. And instead, these machines can use patterns or pattern recognition and inference or guesses to perform these tasks. So if you think about it, if you were doing an artificial intelligence versus machine learning example, well, you can, for instance, build a robot that would navigate a maze very precisely. And you could tell it saying, hey, for this specific maze, I want you to drive this many centimeters. I want you to turn at this time or after these many centimeters have elapsed. And I want you to turn this many degrees in the clockwise direction and so forth. And using these prescriptive instructions, you can have that robot navigate very accurately through a specific maze. If you were going to develop a machine learning system that does the same task, instead of being prescriptive and having these explicit instructions for it to be successful, you might teach that robot how to recognize obstacles. And then you might teach that robot how to make informed decisions based on what it senses and what patterns it detects, so that it can navigate that maze or another maze independently. And so when we talk about machine learning tasks, these machine learning systems can complete certain tasks, even though they're not explicitly programmed to do so. And they do that, again, through pattern recognition and by making guesses, making informed guesses based on the patterns they observe. Okay, and machine learning is a subset of artificial intelligence, but not all examples of AI are also examples of machine learning. Okay. Any questions, or are we good so far?
No questions so far.
Okay, great. So let's talk about specifically an example related to technologies that are used within the First Tech Challenge. The First Tech Challenge uses, for example, something called Vuforia. And Vuforia is an artificial intelligence type of package, and it's actually a computer vision related package. And Vuforia can be used by First Tech Challenge teams to look for and track specific image targets. So on the left-hand side here, I have BB-8 in an image from a Star Wars movie. And this was one of the image targets that was used in this past First Tech Challenge season. And teams could use this, and if their robots saw this picture, they would precisely know, well, first of all, they'd recognize the picture using this Vuforia software, and they'd precisely know where they are with respect to that image. And that's, kind of cool. It's like the robot can do something that we formerly would associate with a human. It can, look for and detect and recognize, and then localize off of this image that it's known to it. Well, if you look at a machine learning example, it's similar, but a little different. Teams can use a technology called TensorFlow from Google, and TensorFlow has the ability to recognize that there are dogs in all of these images. Unlike Vuforia, where the system is looking specifically for this image target, something that's been trained with an inference model can look at an image it's never seen before, such as these pictures of the dogs, and then based on the pattern that it detects, say, hey, I think there's a dog in each one of these 4 pictures. And I think, by the way, the dog is located here, or here, or here, or here. And that's what machine learning has the ability to do. It can solve these problems and complete these tasks without being programmed explicitly to do so. It doesn't have to look for a certain image. It can look for patterns and make guesses or inferences based on what it observes and say, hey, I'm 90% sure that there's a dog sitting right over here in this picture. Okay. So let's talk specifically about these technologies and the First Tech Challenge. The First Tech Challenge is sort of unique in the fact that we use an Android controller for our robot control system. And that gives us advantages because it is an Android controller. There are technologies such as Vuforia, such as TensorFlow, that can be run on an Android system. And in 2016, the First Tech Challenge introduced support for PTC's Vuforia augmented reality software. And we use that technology to allow our teams to look for these 2D image targets. And based on the position of the targets, when a robot sees and recognizes those targets, it can very accurately navigate autonomously on the field because of this Vuforia technology. And each season, when we release a new game, we also release 2-dimensional navigation targets that are strategically placed along the perimeters of the field so that robots can use these targets to navigate autonomously. In 2018, First Tech Challenge introduced support for Google's TensorFlow machine learning software. And it's similar, but a little different. In machine learning technology, or the machine learning technology that we implement, we provide teams with the ability to use this TensorFlow technology to detect and track game elements in the field. So rather than saying looking for a specific image, they're taught, or the system is taught to recognize something like a ball or a cube or something unique that's a game element in the system, and then teams can then use TensorFlow to detect and track these objects during a match. Every season, First Tech Challenge, since we've introduced TensorFlow, creates a pre-trained inference model, and that model is designed to be able to detect certain elements of the current season's game. And so to date, that's how we've introduced teams to these technologies. And in some sense, we've kind of insulated them from the complexity of all of this technology and made it sort of like a sensor. You can use a pre-made function to check, is there any of these objects visible in my field of view? And if so, where are they visible within my field of view? And you don't have to know too much about machine learning or TensorFlow or Vuforia, and you can use it as you would a sensor But if you're interested, there's more there underneath the covers, and as well as to support it with documentation if you wanted to learn more about how these machine learning or artificial intelligence technologies work. And moving forward in the First Tech Challenge, first would like to continue to explore fun and meaningful ways to incorporate AI and machine learning tasks into future challenges. So we want to make it fun. We don't want to put in this technology, for technology's sake, but we're looking at ways, for instance, of maybe creating a challenge where teams have to, instead of using a pre-trained model, create their own inference model so that they can detect some kind of custom game element to score extra points. And again, our goal is to really expose kids to the 21st century tools, which will be relevant as they, continue studying on in the future, and also start working in the, the real world. And hopefully they'll have exposure and experience with these technologies and be able to do some interesting things in the future with these technologies. Specifics, PTC Vuforia, again, every season we put these image targets around the game field, and this is a representation of the image targets that were placed in this past season's game. And using these image targets and the Vuforia technology, a robot can very accurately determine its location on the field. Now, I know that there are other technologies such as odometry that are very popular and very quick to be used on the First Tech Challenge field to navigate autonomously and with high reliability and accuracy. But the vision system is still also a very good option. For instance, if you use odometry and your wheels slip, you might get an inaccurate measurement and might not accurately maneuver. If you use, for instance, Vuforia to check your position, you can, find one of these image targets and verify your location on the field within a few centimeters accuracy, and have an alternate way to place yourself on the field using this computer vision technology. So that's pretty cool. And here's a demonstration of Vuforia, and what we have is a robot. And I don't know if you could see this video, but this robot is trained to detect this Vuforia image and then always maneuver so that it's about 9 inches away from the image and directly in front of it. And you can see that it's very responsive, the robot, and the whole point is that this Vuforia is really powerful stuff, but it does this at a very high frame rate. So it can detect and track these images with high degree of accuracy and do it like in 20 to 30 frames per second. Okay, so now I'm going to move on. Let's move on to our next slide. And let's talk about TensorFlow. So TensorFlow is, again, a complementary technology, and we talked about how each season first provides an inference model, and that inference model can be used to look for game elements on the field. On the left-hand side, we see an image from a robot during the Rover Ruckus season. And what it's doing here is it's looking for TensorFlow, or using TensorFlow for objects that it recognizes. And when it finds it, it's going to draw a bounding box around it and label it and tell the user, hey, I'm 96% certain that there's a gold cube here. And then it'll tell it where it thinks it is. I'm 66% certain that there's a white wiffle ball or a silver mineral here. And then it'll tell you where it thinks it is. And then it says, I'm 90% confident that there's an element here. And similarly for the next season, we did that for this past Skystone season, where we had an inference model that can detect these game elements. So it detects these yellow stones, which do not have the sticker in the front. And it says, I'm 89.8% certain that there's a stone sitting right here. And then it also detects the sky stones. And you can see the labels down here. And it says, I'm 89.8% confident that there is a sky stone in this box. And so it's kind of cool because, again, even though it hasn't seen maybe this target in this environment, it hasn't seen this target in this orientation, maybe it's slightly twisted, it's this way, it's that way. It will look at the pattern and say, I'm going to make a guess, but I think that is a stone, or I'm going to make a guess and I think that is a sky stone. And that's something unique and powerful about this machine learning technology. So how do we get an inference model? Well, when we talk about training a machine learning system, there are different approaches to train a system. There's one approach, and that's the approach that we used in the First Tech Challenge, and it's called supervised training. In supervised training, a human provides example data. So in the case of the First Tech Challenge, I'm going to provide TensorFlow with pictures of the game element. Let's say I wanted it to detect this phone. I would devise pictures of this phone, and I would say, in this photograph, there is exactly 2 of these phones in different locations, and here are the locations of the phone, and this is, the name of it. It's called a phone. And I provide that example data, and then the machine is going to take that and it's going to make guesses and then compare its guesses to the results provided by the humans, and then says, this guess wasn't so accurate. Let me try changing some parameters and trying to refine my guess. And it'll keep doing that until the guesses that the machine makes for the data sets are consistent with the human provided guesses or human provided results. And that's called supervised training. The humans know what they want the machine to look for, and then they provide data sets to reinforce and train the system to recognize that. And that's very useful, for example, with the first tech challenge. We know we want it to be able to detect this type of game element. We know we want it to be able to detect this type of game element. So we're going to feed it, images or data so that it will learn what we think are these elements, and then it'll be able to make a guess of any image and say, I think in this image you have these elements based on the patterns that I'm seeing. Let's talk about unsupervised training. Unsupervised training is different. In this case, we don't know what we're looking for. So in this case, we are going to use algorithms that will allow our machine learning systems to look for patterns in data. So unlike the supervised training where we have a clear idea of what we want the system to learn how to recognize, in an unsupervised approach, you might be, for instance, trying to predict the stock market. You want to see what happens. Is there some financial data that I can look at to predict how the markets will behave tomorrow so I can make a lot of money? And in that case, you're using algorithms to look for patterns that you as a human might not be obvious. They might not be, spatial patterns. They might be, across multiple dimensions. And the idea is that you do unsupervised training on data to look for patterns and find relevance and find connections that you might not have seen before. And that's when you're training a machine and using unsupervised machine learning. And if you look at COVID, I was reading an article recently how they are doing that with the human genome. They're looking at people who have been sick and severely impacted by COVID, and then people who have not been sick and severely and not impacted by COVID. And they're trying to look at the human genome and see what genetic traits, are associated with, or patterns or associated with people who get sick versus people who don't get sick. And can we make some predictions on how the disease operates in people so that we can better treat it? Okay, and the last type of approach will be the training or reinforcement method. In reinforcement method, this is similar how you might teach yourself how to do something, or teach a pet, for instance, how to teach a dog to do tricks. You can use some type of reward system, and you develop an algorithm where the machine tries to optimize some kind of parameter or some kind of reward. And as it goes through, and makes a move or contemplates making a move, it'll calculate, well, how much of a reward will I get? And by trying to optimize or maximize or minimize some value, it can, maximize its reward. And that's a way for it to learn, how to accomplish the tasks. So all of these all of these approaches have different benefits. And depending on the type of application you're trying to solve, or a problem you're trying to solve, you'd pick an appropriate training approach to create your machine learning. And so for the first tech challenge, we use this supervised training, and our goal was to create a TensorFlow inference model, inference meaning educated guess, to detect the game elements in our season's game. And then once we have this model, we will then want to convert it to a form that can be run on a mobile device like an Android phone, so that our teams can then use their Android devices to look for and detect objects in the game field. And in the past season, we were looking for either these yellow blocks, which are called stones, or these yellow blocks with these little special stickers on them, which were called sky stones. And to do that, we did supervised training. We used a convolutional neural network algorithm, and we created an inference model. And we started with a pre-trained model, and this is important. If you're gonna do model training, it's better, and I've been told this, and I'm not a machine learning expert, but I've been told by Google folks, and also from what I've read in the literature, it takes a lot of time to teach a machine to recognize objects from scratch. So it's always recommended, if possible, use a pre-trained model where it knows several objects and several shapes, and it's been already trained to detect these things, and then use that and provide additional data so that you can create your own custom model that's based on this pre-trained model. And for the First Tech Challenge, we use an open source model available from Google called MobileNet. And we specifically picked MobileNet because it provided us with accuracy, but it also was able to make these inferences quickly. If you look at this graph on the right-hand side, you can see on the vertical axis, we have accuracy. As you move up on this axis, the accuracy improves. So your ability to guess becomes better. But as you move along this horizontal axis, the amount of processing power that you need to make that inference or that guess goes up. So if you look over here, all the way in the upper right-hand corner, there's a model that's very accurate, but it takes a lot of processing power or a lot of computations to make that inference. And that's not necessarily good for a robot because you want to make these decisions quickly. So what we used was a MobileNet model, which gives us reasonable accuracy, but it's able to make these decisions at a quicker rate. And so we have a lower latency, and so that we're able to track more effectively these game elements using this inference model. And in order to do that, we had to create these training data sets, again, drawing the pictures, taking the training pictures and drawing boundary boxes around the objects we want to detect. And then we use those to generate a model using a supervised training process. It's an iterative process. The machine's going to guess and then compare its guesses to these training data sets that we provided, and then it'll iterate. It'll refine its guess and then check the answers again and do so until the error approaches zero. And we had to use a special system to do that because it took so much computational power to generate it. We actually had to run it on some special purpose Google hardware. Training data, we actually use for this past season 3,500 labeled images. And by labeled images, if you look over here, each image we had might have some objects. And in this case, we have 2 stones, which are the yellow blocks, and 2 sky stones. And we put them inside the image. They were inside the image and they were labeled. So if you see, there's a boundary box and a little letter S. And that means that this is a stone. And this boundary box is the location of the stone. Similarly, there's a boundary box here and a letter S indicating that this is a stone and it's located here. And then we had sky stones, which are represented by the T's over here. And what we did was we created these images so that the computer can use these to guess and check. It'll guess saying, hey, I think there's 2 stones here and 2 sky stones. And then it'll compare its boundary boxes with the ones that the human provided. And it's able to refine its guesses until its guesses are consistent with the human provided results. And we used a Google provided tool to make these annotated labeled images. And then we fed them into a supercomputer and we were able to generate our inference model. And because this was, pretty heavy duty math involved, we had to use something called a TensorFlow processor unit. And similar to a GPU on your computer that is optimized for graphical calculations, the TPUs are optimized for doing mathematical operations that are associated with TensorFlow. And we used 3,500 training images, and we took 12,000 training steps. And this process would have taken weeks or months on a desktop computer if it would even run at all, because the computer would run out of memory. But when we did it on this tensor processor unit cluster, it only took about an hour. And that's pretty cool. And by the way, this is available to the general public, and there are documents which I'll talk to later on about how you can do this and create your own custom model. So as we created our model, one thing that we were doing, how do you know your model's accurate? Well, we're measuring something called loss. And the idea of loss is when the computer makes a guess, it draws a boundary box around what it thinks is a stone, and then it compares it to what the human says was a stone. And ideally, they should overlap and there should be very little error. And as that as that guess becomes more accurate, your loss value approaches zero. And what we did as we were training our model, we were monitoring this loss. And as the monitor value goes to zero, we can say, okay, as it's getting closer to zero, we understand that our model is becoming more accurate. And that's how we were able to tell that our model was getting better, because as the loss approached zero, we knew that it was making more accurate guesses for a variety of scenarios or a variety of test cases. Okay. Here's a quick video of the Skystone model. And what we see here is the output from a robot controller, and it's actually using this TensorFlow technology so that it can actually see these individual game elements. So on the left here, we have a Skystone, and on the right here, we have a stone. And again, this is using TensorFlow and the technology. And even if you were to twist this stone around and it's never seen it in that orientation before, the inference model will allow TensorFlow to say, hey, you know what? I think there's actually a stone, and it's right here in your field of view. And that's one of the powers of machine learning. It can make these guesses and find these objects, even though it's never seen that object in that particular environment before. Okay. So let's go down to the next slide. Okay, machine learning tools. I just wanted to cover quickly. This is pretty heavy duty stuff, and this is advanced stuff, but I just wanted to cover quickly what tools that we use specifically in case anybody out there is interested. And again, this is really heavy duty stuff. You really need to know a lot of Linux commands, and you need to know a little bit about software and a little bit about how to install these software packages to be able to do this. But if you're interested, you can use something called TensorFlow Object Detection API, and you can create your custom inference model, which is what we did. And that's how each season we're able to teach TensorFlow to recognize new things. And you could take the same technology, for instance, and teach it to recognize your dog, not anybody else's dog. You can teach it to recognize your dog. And when your dog is taught, and when your system's taught how to recognize your dog and nobody else's, you can, for example, write a program that whenever it sees the dog and it recognizes that that is your dog, it maybe turns a servo to feed your dog a treat. And that's what you can do with this TensorFlow Object Detection API. Now, it's heavy duty stuff, but if you're interested, there are online tutorials, and I like to use these ones from medium.com because these are written by Google engineers or people who work for TensorFlow or work very closely with TensorFlow. And they'll teach you how to use the Object Detection API and how to install it. And then there's a specific tutorial that we use to teach us how to use this TensorFlow cluster or TPU cluster to do a custom model in a short amount of time. Okay. And so again, these I'm not going to go into too much detail because these are heavy duty, and you really do need to have some high-powered experience using Linux and some software packages. But if you want, it is an option, and you can learn how to create your own custom model using these tools. And in order to generate those annotated image, we actually use something from Google, a Google-provided tool. And if you were to go to this GitHub repository, you can actually download the tool and look at the instructions yourself. But this tool, and I'm going to share my screen if it's working, and I apologize because this is Linux. I'm running Linux over here. But you can use this tool. Let's see if it works here. I'm sorry, I shouldn't do a demo here. Okay, let's try this now. Okay, this tool provided by Google allows you to create these annotated images. So the way we did our images to train the TensorFlow system to recognize these game elements for the Rover Ruckus season was we took videos. So we took our cameras or smartphones and we took videos of these objects. Then we used this tool to allow us to draw boundary boxes around these objects and label them. And you can see that I have this gold box labeled with a G, and this other gold block labeled with a G, and then this silver ball labeled with an S. And once I've done that and I've labeled it, then I could use this tool to actually automatically start tracking these guys. And what it's doing is it's looking at my video and stepping through frame by frame, and it's drawing boxes around them and keeping track of these objects. And what it's doing is, and I'm going to pause it, it's generating all of those training frames that we're going to use to teach the robot how to identify these individual objects. And if I need to adjust it, like if the box is getting a little bit too small, or if it's getting a little bit too big, I can pause it and then, adjust these boxes. And then once I've adjusted the boxes to make sure I'm accurately, tracking these things, I can resume the tracking. And that's how FIRST was able to take a whole bunch of videos and then teach our robot or generate an inference model that would be able to detect these gold cubes and these silver balls. And the idea is that we use video and this tool, and we create a set of training frames or pictures that have this information on where these items are located. And then we can then feed this into the TensorFlow Object Detection API, and it's going to use that information to create an inference model. Let's go back here. And this is the workflow for doing that. We took the videos with the cameras of the objects that we wanted to detect. We used that Google provided tool to generate the labeled data to say, hey, these are the objects you want to track. These are the names of the objects, and then you go do that. And then we converted the data set into a format that TensorFlow could read. We uploaded these records into a Google Cloud server. Then we used the Google Object Detection API to train the model from a pre-trained model using those super powerful Google TPU machines. And once we were done, we converted it into a format that our Android phone could read. And then we installed it on our app and tested it. And again, that's pretty heavy duty stuff. And this is an example of the data set or the annotated data set. But it took a lot of work because it needed specialized knowledge on how to install and run these Linux packages. We're currently working with Google, however, to create a more user-friendly, what we're calling a machine learning toolchain. And the idea is that you can use your web browser. You can use your web browser to upload videos that you took of the objects that you want to teach your computer to recognize. And then you can use a web browser to create all of those annotated video frames. And then you can then use your web browser to kick off a supercomputer training run and generate your model that you can then use to detect your objects. And we're doing that with Google so that you won't need any advanced Linux or software skills to be able to do that. You'll just have to understand the process and have a web browser and an internet connection. And here's an example of the actual screenshots from this tool chain. What I did was I uploaded a video of these old blocks, which were prototypes from the Skystones season. And I used the Google tool with my web browser to draw these boxes around each of these objects. And each of these boxes have coordinates, which are listed over here in this table. And then I can add a label for each one of those objects. And after I've done that, I could push this button, and this Google tool will then, host it on the internet, start tracking and labeling all of the frames within this video. And when I'm done, I have a data set that I can then use to create a TensorFlow model that would be able to detect those little blocks in this field of view. And again, the whole purpose of this Google provided tool is to do all of that training, but not have to require any specific Linux knowledge or not have to understand how to install packages to troubleshoot them. It's if you have a web browser, you have some video footage, you can upload it to your cloud account, and then you can run this process through your web browser and create an inference model. And that's pretty cool. And that's something that we're working with Google on. We hope to pilot that technology in a very limited run next season, and then hopefully make it more generally available in a future season. Once you create your inference model, then you can use the First Tech Challenge software development kit and incorporate those models into your robot op mode. So you can use these models to detect objects and then write programs so that your robots can respond to things that it sees in its field of view. So again, going back to the dog example, if you train it to recognize your dog, you can have it feed your dog, treats whenever it sees your dog's face. Okay, and that would be something that you could do with a custom inference model. Okay, I wanted to end up with fun activities to try and then just open it up for any questions and answers. But here's a fun one. It's called Google's Teachable Machine. This is not, anything real difficult. It really is just, let me see if I have Teachable Machine queued up here. Okay, so I do have that. Okay, Google's Teachable Machine is a really user-friendly way for you to explore using machine learning. And it's a cloud-based system, and it lets you teach or create an inference model or teach the machine to recognize either images, sounds, or poses. So you can teach it to recognize sounds and words, like you could teach it to recognize hello and goodbye. And then once you have taught it and created this inference model, you can export that inference model and then use it perhaps in a Python program or in an Android app to do kind of cool things. And you can see, like in one case, it looks at a marshmallow and it looks at a not marshmallow. And if it's a marshmallow, it'll sort it to the right. And if it's not a marshmallow, it'll sort it to the left. And those are the kinds of things that you can do. And you don't have to go through this whole convoluted process, no pun intended, of using all these advanced tools or all these Linux kinds of things. You can just do that. Where is my presentation? You can just do that using the Google Teachable Machine. So again, Google Teachable Machine, friendly cloud-based application that lets you from your web browser teach a model to recognize an image, sounds, or poses. And if you see over here, that's me with my hands up. I taught it how to recognize 3 different poses. And once I have it taught to recognize the poses, I can then export these models and then use it in a Python script or use it in a Android app to do kind of cool things. So here's an example, a pose recognition example. I'll actually show you the demo, but what I did is I taught it to recognize 3 different states. The first state was up, and I used my web camera to take lots of pictures of me doing this with my hands up in the air. Okay, and that was my data set for the up position. Then I took a lot of pictures of me in the neutral position, just sitting here like that. Okay, and I did lots and lots of pictures of that, and then I used that as my data set or my supervised training set for the neutral position. And then I did the last step was the shoulders. And then I did that and I trained the model, and then the model can recognize my pose. Let's see if it works here. And if you look over here on the right-hand side, that's my face. And if you look over here on the bottom, this is what it thinks the output is, okay? And if I sit like this, it says, oh, he's probably in the neutral position. If he puts his hands on the shoulders like that, it says, oh, he's probably got his hands on his shoulders. If he puts his hands up like that, he says he's probably got his hands in the up pose. Okay, so this is just kind of a fun thing, right? And if I do this, I can then export this model by pushing this button. And now I have that model which I generated, which I taught it how to recognize these different poses. And then I could write an Android app. And maybe I write an Android app to play a sound when I do this. Maybe I write an Android app to turn on a motor when I do this. And maybe I write an Android app to turn off the motor when I do this. Okay? And that's the power of Teachable Machine. And it's something you can do with your web browser. You don't need anything fancy. And it's free. Okay? Let's move on. And we only have a few more minutes. The other thing I wanted to show you is there is an example on how to use TensorFlow Lite and a pre-trained model and use that to create an app that can recognize things. And what that does is this app is an Android project that you can download from this Google repository. And it has the MobileNet SD model, and it'll automatically download it and import it for you. And you can create an app and see how it works so that it can detect a variety of common objects. And if you look in the screenshots here, I have on the left-hand side the TensorFlow sample app, and it's looking at a cell phone. It may never seen that cell phone or that type of cell phone before, but it looks at it and says, based on the pattern, I think that's a phone. And I'm 80.08% positive that that's a mobile phone or a cell phone. Similarly, it can look at something like a laptop, or it can look at a clock, or it can look at a cup, and it says, I'm 80% certain that that's a laptop, or I'm 90% certain that's a cup. And that's kind of a fun application that you can do. And you could use a pre-trained model automatically. And if you get more sophisticated, you can actually create your own custom inference model and have it detect your own things, maybe your dog's face, maybe something that wasn't detected by the previous model. And that's cool. And that's also available, again, from Google on this repository. And the last thing is, if you're interested, you can take a look at the online documentation for the First Tech Challenge control system, and you can learn how to use TensorFlow to detect objects using the First Tech Challenge software. Now, again, each season, the inference model provided with our software is different. This is showing the inference model for the Rover Ruckus season, where it was trained to detect those gold and silver elements. And this past season, it was the Skystone season. So the actual inference model was trained to detect those stones and sky stones from this past game. But again, these are all fun things that are available on the web. And if you're interested in getting a sample of machine learning, that is a good place to start. And with that, I'll open it up to questions. And I have a question for the host. Will these presentations be available online because they have the links embedded in them?
Yeah, I'm pretty sure these videos will be put up.
Okay, great. So you'll be able to find these, kind of free tools available through these presentations online.
Okay, so we have some questions from the chat. So the first question is, what do you see as the future for AI and machine learning for FTC going forward?
As far as the future, I think there really is interest in trying to get kids to actually, for instance, generate their own machine learning models. So an idea is like in past First Tech Challenge games, we've had a team scoring element. The teams had to create a custom element. Some 3D printed it, some just built it out of wood, some built it out of paper. Whatever they make as the game element, I think there's a desire to be able to make a user-friendly tool that would allow teams to teach the computer to recognize that game element. And that way, during the autonomous portion, a robot could identify its custom game element and then manipulate it to score extra points. I think that would be an example of a fun way to incorporate the machine learning and artificial intelligence technology while still providing a fun competitive experience for the actual challenge. So.
Yeah, thank you. We also have another question from the chat. Do you have any tips on how to integrate machine learning into mentoring students on classical control system approaches?
That's a good question. I guess, yeah, I mean, the way I would approach that would be to, in essence, you can use machine learning sort of as a sensor. So in the case of the TensorFlow object detection API, you can, or TensorFlow object detection, the way it's set up for the First Tech Challenge control system, you can get, for instance, information about the objects that are detected and their relative location inside your field of view. And then you could teach a student how, for example, using sort of classic closed loop control, how you would navigate so that you get that object to be a relative position that you want it to be. So like if in Rover Ruckus, I think you had to move the gold cube out of the way. And we taught teams how to look for the gold cube, and then they would use sort of proportional control to line up the cube so it was in the center of its field of view. Then we had them learn how to scale it so that they can use proportional control so that they can move so that they're precise distance away from the element, and so they can manipulate it. So I think if you approach machine learning in that manner, you can combine it with the classical sort of control problems that you encounter in robotics. I hope that was the question that they were asking. So.
Yeah, that sounds like it would be really useful for mentors to use, so thank you.
Yeah, and the key thing is machine learning can be complicated, but in this way, the way it's presented through the First Tech Challenge, you can use it as a sensor. So if the kids understand conceptually how it works, but they don't have to know the details on how the model is generated or how the model is working, that would be a good way to incorporate it into such a lesson.
We have a few more questions from the chat as well.
Sure.
Which tool do you recommend for rookie or newbies teams to try and use for FTC Vision?
So I would look at, it depends. What I would look at for if you're an FTC team, I would first play with Teachable Machine just because it's fun. That is the Google Teachable Machine, over here. This is just kind of a fun thing, and that doesn't necessarily apply to a First Tech Challenge, but it's a fun way for them to learn about sort of machine learning and artificial intelligence. And as far as which kind of computer vision things, there are pretty good tutorials, for instance, like on this Vuforia technology. We talked about this Vuforia, and we have this demo where this robot is following stuff around. This is actually the proportional control. It's really just looking for this image, and then it's knowing where it is with respect to this image, and it's just trying to keep its position relative to that target, fixed. It's always trying to stay directly in front, about 9 inches. I would look at the tutorials on the First Tech Challenge website, maybe that talk about how to use TensorFlow and how to use Vuforia. So I think there's something here called using computer vision in FTC on this online forum. I'm sorry, on this online documentation as part of the First Tech Challenge GitHub repository. And if you look at computer vision overview, it talks about the different types of technologies and their advantages and where you might use one versus the other. And then it also actually has tutorials, and it tells you how to use Vuforia. Like if you wanted to use Vuforia to navigate on the fields, it has pretty explicit examples. And then it also talks about how you might use blocks. Use TensorFlow, and how you might use that, for instance, with this past season's game. So I hope that helps. That if you're new to the image processing, that's something that you could do in the First Tech Challenge.
We also have another question. Someone was asking if they can use TF-Lite, if they can use a TF-Lite file from Teachable Machines with the current robot controller.
I'm not sure, because I think the robot controller is an object detection. It's expecting an object detection inference model, and the Teachable Machine is going to provide you with a either the image one. I don't know if the image is actually a classification. It might be a different model. It might be a classification model as opposed to how do I do this? Wait, what am I doing? It might be a classification model as opposed to a object detection model. So I don't know if you could move that right into a First Tech Challenge op mode. What I would do is, if you wanted to do this, you can generate these inference models using Teachable Machine, and then you can either use a Python script and maybe something like a Jupyter Notebook to do image, sound, or pose recognition, or you can look online. There's probably some example Android apps that are not from First, but perhaps from Google, which show you how to use these inference models. Yeah, but I think because these are different from the type of inference model that's used by the First Tech Challenge software, which is specifically an object detection model, I don't know if you can necessarily, go from one to the other.
Okay, cool, thank you. Another question. Another team was wondering if they can use more than one video camera to help the machine or the robot to learn.
Yeah, so if you're doing Teachable Machine, I think the user interface only lets you use one camera at a time. But if you're doing inference learning, you can, you're basically just taking videos and creating them. The Teachable Machine, though, only allows you to use one camera at a time, even though I think it detects all of the cameras that you have. Like if you look at my example, it was only using my laptop camera. So if I look over here, it's only using my laptop camera over here. But yeah, you can select the webcam. And for some reason on my Windows machine, it doesn't use this other camera. It just always defaults to the laptop camera. But yeah, I mean, in theory, you can use different cameras, and it does work on a Apple Macintosh system. As far as once you have your model generated in the First Tech Challenge control system, you can actually have more than one camera connected to your robot controller. And you can, I believe, switch between one camera versus the other and use one or the other to do your detections. So I don't recommend doing that because it is kind of resource intensive, but I think you can actually do that. Our software lets you do that.
Cool. And this might be the final question.
Okay.
Do you know of any FRC machine learning technologies? Like, can these same ones be implemented
Yeah,
for FRC?
that's a great. And actually, so we demonstrated this to some folks within FRC and WPI, and they actually had some points, had a project to try and get machine learning available for FRC teams and trying to provide FRC teams with the ability to create custom inference models using AWS servers. But that was only a short trial for this past season. What I believe is possible is that you can use an Android controller with something called Coral, which is a TensorFlow accelerator, hardware accelerator. And I think the FRC rules allow you to use an Android device, and maybe it's not even Android. I think it could be a Raspberry Pi with this Google Coral device, and you can do machine learning on there. You can create an inference model using these tools that we talked about, and then you can load that inference model onto a Raspberry Pi. And if the Raspberry Pi is using Coral, I believe it can have an accelerated effect so that it can do the object detection at a pretty fast rate. And there were some tests done with WPI, Brad Miller over there at WPI, to try and implement some machine learning capabilities for FRC. And I think that would involve using a supplemental controller in addition to your RoboRio. And I think it's an Android-based or a Linux-based controller. I think it's actually Linux-based, and it uses a Google hardware product called Coral, which is, let's see, Google Coral. There's a USB accelerator which you can plug on, and it would allow you to do these TensorFlow calculations with hardware acceleration. So, yeah. And I think if you're interested, you could reach out through the group here and get in touch with me, and then I'll get you in touch with the people in FRC who have been doing this. And I think it's primarily Brad Miller of WPI. I hope he doesn't mind me mentioning his name, but he's in charge of also the WPI lib, which is the SDK for or the the programming API for the FRC control system.
Thank you very much for your presentation. It was very interesting. I definitely learned a lot, and I hope that the viewers did as well. So thank you for joining us tonight.
Thank you, everybody. Enjoy the rest of the 24 hours of STEM. Bye-bye.
Bye.
January, the challenge comes out every year. Under strict rules and limited time and resources, you have to design, build, program, and test a robot.
There's no blueprint. We get a few rules and guidelines to follow, and then it's up to those students to find something that works.
There's nothing better than just seeing your robot on the field playing for the first time. They're all there like, is it gonna work? Is it gonna work? And then when it works, it's the best feeling ever.
You have mentors that are actually in the field that can tell you, oh, this is why this works, and this is the science behind it. And you're like, oh, wow, that makes so much sense.
They do a great job, not just about STEM, but about life, how to go through college, how to go through, a tough, physics class.
At face value, First Robotics Competition is a robot competition, but at the end of the day, it's so much more than that.
People ask me like, oh, you build robots? I says, no, we're really running a business and all the things that go along with that.
We deal with a lot of marketing, social media.
I've learned business sides of things, problem solving, working in groups.
I'm learning how to communicate with people, how to reach out to local businesses.
So we kind of have robotics as the starting point, but we branch out to different areas and expand.
So the ultimate goal every year is always to get to the first championship.
The first championship is basically like the Olympic for robots.
There's hundreds of teams from all over the world there, and you get to see some of the best teams that exist.
It's very competitive, but you're friends with the people that you're going against. It's like a sport, but in its own way, it's better than a sport.
Being part of FIRST, it's really changed my life and how I think about myself, how I think about others.
Participating in FIRST actually taught me that I'm capable of doing anything that I set my mind to.
FIRST has really inspired me to give back in my old elementary school. I'm trying to help their robotics program that just started this year. I want those kids to have the opportunity to learn about STEM.
As a participant in the FIRST program in high school, you get access to $80 million worth of scholarships.
There are scholarships for colleges, universities, as well as technical programs.
It also looks really good on the actual application to be on FIRST.
FIRST does a really great job trying to open programs to make sure that you could actually accomplish anything in STEM, no matter where you're from, your background, your language, or anything like that.
I really do consider myself part of the STEM community, and I couldn't be more prouder to say that.
FIRST Robotics Competition is one of 4 engaging FIRST programs that shows students unique challenges and helps them learn new engineering skills and real-world skills that'll help them in the future.
FIRST is the future.
FIRST is accomplishment.
FIRST is passion.
FIRST is inspiring.
FIRST is changing my story.
Okay, it is my pleasure to introduce our next speaker, who will be talking about how to take your team to the next level. So please join me in welcoming Steve Harvey from FRC Team 1678, the Citrus Circuits.
Hey guys.
Hello, Steve.
That was a great presentation by Tom. Really enjoyed it.
It was, yeah.
And I'm not even an artificial intelligence kind of guy, but I enjoyed it.
It was very interesting. It was very useful to learn about.
Mm-hmm.
Are you ready to start your presentation?
I am ready, yeah. Let me share my screen here with you guys. Okay, so this is obviously an FRC presentation. You'll notice there's a little story behind this title because it still says St. Louis Workshop Series. We attended the LA Regional this year, and then a couple of weeks later, we were getting ready for St. Louis. We actually sent our team all the way out to St. Louis on the plane. I drove the team trailer 2,000 miles from Davis over to St. Louis. We got to St. Louis, we unloaded, we unpacked. I got my presentation all set up. Next morning we show up, I'm getting ready to give my presentation. Our robot gets through inspection, and about 8:45, an announcement comes over the speaker that they've canceled the regional. So we pack up, we go back in the trailer, and we drive 2,000 miles all the way back to Davis. So it's kind of an experience. It was a fun trip across the country, but we did not get to compete in St. Louis. We were very lucky to be honored with the Chairman's Award win there, so we're excited about that. But this was the presentation I was going to give at St. Louis, so I'll give it to you guys here. We adult canceled the regional. So we pack up, we go back in the trailer, and we drive 2,000. So just to quickly mention who I am, I'm the lead mentor of Team 1678. I was a civil engineer prior to becoming a teacher in 2001. Started the team back in 2004, and I've been with the team ever since. I'm married with 2 kids, and I love to windsurf. As you can see, this is me at the Delta in Sacramento. And I also love to mountain bike. So why am I here talking to you guys? Well, first of all, as a teacher, I can tell you, I think FIRST Robotics is one of the greatest educational programs that we have. And when I talk to other people that have seen FIRST, they tend to agree with me, and they're just super excited about how much hands-on learning takes place, how inspiring it is, how it lets people pursue their own individual challenges. And I want to say that I really understand those challenges, because when we started, we were a fledgling team. This is actually a picture of our robot in 2005. And I don't know if you can tell, but this is actually a step ladder that we got from Home Depot, because we couldn't figure out how to build the superstructure of our robot. So we just put a step ladder on it and then put this arm, and we were super excited to be able to even compete that year. And the other main reason that I want to talk to you guys is that I think the success that we've come to know through all the experiences we've had has not been because of luck. It's because of specific things that we've done along the way, and the inspiring teams that we've learned from. So there are keys to success, and I'm hoping I can illustrate some of those keys tonight. First is about setting goals, in my opinion. So obviously people like to win, and we enjoy winning competitions too. But if your only goal is to win, then a lot of you are going to be disappointed, because not everyone can win. So I think setting goals like, let's try to get to the finals of this regional, or let's try to just get a robot that can actually, score at least 3 or 4 balls in the upper goal in this recent competition. That would be a goal that is achievable and that you can feel like you have success in doing. So I think that defining goals that are realistic is an important part of FIRST. So this is basically the structure of my presentation. I'm going to be talking about all of these aspects that I think teams can focus on to try to help them improve. And when I say get to the next level, I guess I should back up and say this is not a title that I came up with. We were talking to the organizers of the St. Louis Regional, and they wanted us to give some presentations there. So we asked them what they would like to hear about. And they said, we would like to hear a presentation on how you take your team to the next level. So I think that honestly can apply to every team. I mean, every team can aspire to do better than they're doing currently. So these things apply to everybody at every level. So these are the 6 areas I'm going to go through. Hopefully I can get through all of them. And we'll just jump into the first one right away here. So how you organize your team is really up to you, but this is actually a chart I think I got from 1114's website, very respectable FRC team. Basically just having some kind of structure to your team, and I think drawing it out in some kind of a chart so people can see what that structure is and visualize it is important to setting the direction of control, because I think you don't want everybody on your team trying to do what's going on up here. And you don't want everyone on the engineering team trying to do what's going on here. You want everybody to be designated their tasks, but have someone that's above them that can help direct them and guide them. And obviously you're going to have the most experienced people at the top of this tree. In our case, 1678, this overall authority is the team captain, the team vice captain, myself, and Mike Corsetto. I'm sure any of you that know 1678 know Mike. He's our lead technical mentor and drive coach. So that's our kind of core leadership, we call it. And then we actually have sub teams under that I'll talk about in a minute. So how you lay out your sub teams on your team is really up to you. This is sort of the way we lay out our sub teams. I think it's important that you do this, and it's also important that the teams that you develop do communicate together. So I'll talk about communication in a little bit, but just bear that in mind that those are the sub teams that our team has, but you could have whatever sub teams seem to suit your particular organization. And then you have students on your team, obviously, but I think it's very important to think about how you want to include mentors and coaches on your team. This is a question that comes up a lot, is how involved should a mentor be? And I've seen everything from teams where the mentors are in the pit rebuilding the robot during competition, all the way to teams that come to competition with virtually no mentor support or maybe no mentor support at all. And the students on the team make all the decisions logistically and technically. So I'm not going to say which method is best. What I will say is that if you look at the most successful teams in FIRST, and I don't just mean successful in terms of on the field, I mean successful in terms of everything they do to inspire other teams, including their outreach. I think what you'll find is those teams have developed a very successful student-mentor partnership. So basically working hand in hand with your mentors, involving your mentors, asking your mentors for help when you need it, and even sometimes relying on mentors when you've come to a point where you can't actually fix the problem. So communication, I mentioned this when I was talking about sub-teams. Communication, I think, is the foundation of your entire team. How you communicate, how you connect with both your team members, your mentors, your parents, and your community, how you involve everybody is super important. So on a team level, we use email, Google Drive, and Slack. But as a logistical thing, we hold regular leadership team meetings. And I would encourage any team that has not developed this protocol yet, I would suggest that you have a sub-team lead for each of your sub-teams. And it's up to you how you do that. Some people vote. We actually do an interview appointment process. And then you regularly meet with those members of the sub-teams, those leadership people. And we call that a leadership meeting. We have our leadership meetings once a week. We meet for about an hour and we discuss the higher level stuff, but we're very transparent about sharing that with the rest of our team. And then obviously you want to have regular meetings with your team. But most of all, I think you want to try to involve all of the people on your team, including mentors and parents. This is actually a parent meeting, and I'll talk about that a little bit later when we talk about fundraising. And here we are with fundraising. So obviously, any successful team is going to need to be able to raise money. And obviously, the more money you can raise, the more things you can do. For us, that isn't just being able to build 3 robots every year, which is currently what we try to do, and attending 3 regional competitions every year. And fortunately, we've been able to go to champs every year for the last 10 years. It's not just that, it's also being able to do all of the outreach and support things in your community to help build your team's credibility. So there are various sources of funds. I think one of the most overlooked are FIRST grants. It amazes me how every year I find out that teams haven't even looked into this, but FIRST offers all kinds of grants, and I would encourage you to find out if your team qualifies for any of them. There are educational, when I say FIRST grants, it's not just from FIRST directly, but FIRST gives you opportunities to get grants from places like NASA, from Boeing, Lockheed Martin, and other companies like that. And we've been very successful in securing several of those grants recently. So I would encourage you all to apply for those. There are educational grants that you can apply for. But I think for most of us, when we're trying to raise money, we're probably looking at local companies. And if you're fortunate enough to have a university on your doorstep like we are, working with your university or college to try to see if they'll support you in some way. And the last support that we lean on very heavily is our parents. And I know that this is obviously dependent on socioeconomics, but I've even talked to some fledgling teams in some very underrepresented areas. And when they can get their parents involved and the parents see what they're doing, parents can be very generous. So I would encourage you to try all of these different resources for funding. So talking about parent support, I would assume that if you're a team of 20 people, let's say, which might be an average team size, say 15 to 20 people, then I would assume you probably have a pool of perhaps between 20 and 30, maybe 40 parents. So that's a lot of support that you can get from people if they're willing to just volunteer their time. So we go very directly to our parents early on in the season, and we ask for support in terms of the logistical support, like driving, like preparing food for the kids. Sorry about my dog barking. Preparing food. They may work for companies that will match their donations. But the biggest ask that we have for our parents is actually a pledge. So we very directly go to our parents, and this is a picture of our parent information night. And we organize this parent information night where the students put on the whole show. They prepare a barbecue. They prepare presentations for the parents on each of the sub-teams. They show the parents what we do. They get the parents excited about everything that we're doing in our team. And then at the end of the presentation, we basically hand out a pledge form and we say, okay, so this is the money that we need to operate this year. This is how much we're going to get from our sponsors. So here's the gap, and we need you to try and fill up this gap. And we've been very successful in filling that gap every year. So I would encourage you to really be direct with your parents and ask them directly for their financial support, because they know the value of this program. It's also important when you get sponsors to keep them. So make sure that you acknowledge your sponsors on a yearly basis. Send out newsletters to them on a regular basis so that they know what the team is doing. Send out press releases to newspapers and put your sponsors on those press releases and thank them. Make sure your sponsors are well displayed on your robot. I know most of you guys do that already, but just be really as clear as you can to acknowledge them, and your t-shirts and everything else. And then one more thing that you could try if you haven't done this. We started about 3 years ago having a sponsor open house. So basically we do the same kind of thing as the parent information night, except we do it specifically for sponsors. And we've moved to a model recently actually where we just do it over a week-long period. And we invite sponsors into our shop and we guide them through everything that we're doing. We thank them, we give them some food. We just basically interact with them and tell them how valuable they are. And when they see what we're doing, that's really the most that they want. That they're not so excited about us giving them big praise and thank yous and gifts and things. They're more excited to see that the money that they're spending is going to a really good cause. And they'll see that in your sponsor open house. So now we're coming to perhaps the nuts and bolts of how to improve your team, particularly in terms of your technical ability at competition. If your team isn't currently doing anything outside of competition season, then I would strongly encourage you to look at the mantra here that winners are made in the off season, because a lot of FRC teams subscribe to that mantra. And so that starts with training. And we've developed a model for training that I think has been very successful. It does take some time to implement, as the last bullet says here. But basically what we do is as we go through each season, our seniors are the ones that are training the junior members of the team, because they have spent 4 years on our team. So they've essentially become experts. In many cases, much more expert than any of our mentors. So this does a lot of things. It builds camaraderie in your team. I think when students are teaching students, it also makes your model much more sustainable, because if you're relying on a mentor to do all your instruction and teaching, if that mentor decides to leave or he retires or something, which I'm getting very close to personally myself, so our team knows about this, then you may lose a great resource for your teaching. Whereas if your students have become the main instructors of your learning model, then this is a program that can sustain into the future. And believe me, when this model starts working, it just improves year by year because the students are very inspired by their peers. And so the next year they want to do just as good, if not better job than their peers did the year before. So the basic training from your peer-to-peer model is good, but I think because I talked about how FIRST is such a hands-on experience, I think a lot of learning really takes place when you actually do FIRST, when you actually do FIRST robotics, when you're actually building robots. So in the off season, we have a lot of projects that we try to do hands-on stuff with. We do a mock kickoff. And so a mock kickoff is you just choose a previous year's game. I would suggest you choose a game that your team is not familiar with. So pick an older game and you play the game animation and you show them the game manual and you have them read the manual and understand the rules. And then from there, you can take it into the stages of developing your robot design, which I'm going to talk about a little bit later. And you can take that as far as you want. You could even take it into the prototyping stage and actually try to have them design basic prototypes for that challenge. I also think it's a really good idea to build an off-season robot if you can. So take some time, get your design team working on it. We tend to let the students completely run on their own with the off-season with very little mentor guidance. I think they learn a lot from that experience. This is actually the off-season robot we built in 2016. So it was a catapult designed on a turret on a very, very small drive base. And well, I'm not going to say any more than that for now because I think I have another picture coming up. So we basically run prototyping challenges as well, where we basically just take old game pieces and over a 2-day period, we just tell the students your goal is to pick up 6 of these cubes and put them on this ledge or to shoot as many of these balls as you can through this hole. And so they're given some plywood and some 2x4s and a bunch of screws and everyone gets a drill and they have access to our machines and they have to come up with a prototype to meet the challenge. And then we have a big competition at the end. So I think prototyping challenges have been one of our most successful ways to develop our students' ability in both design and fabrication of robots. You can always rewire last season's robot. You can get your electrical team working on that. Just literally tear all the wiring off it completely down to the bare frame and motors and say, go ahead and rewire it. And then you can just have mini robot competitions. So what I mean by that is if you happen to have any small Lego robots or Vex robots or whatever, you could hold little mini robot competitions where you're maybe giving the programmers some challenges. Oh, I don't have the other picture. There's a picture of this robot upside down, which is, I was going to show you that because this was actually one of those off-season robots that did not do too well. It was such a high center of mass considering the small wheelbase that it just kept tipping over. So then obviously, I think a lot of teams are doing this anyway, but I just wanted to mention that you should definitely do some specific in-house training where you're spending some time teaching your kids how to use all the tools. And those tools could be the mechanical tools for the fabrication team. They could be the tools that the electrical team needs to use. They could be the tools that the business and media team need, like Adobe Photoshop or any of the Adobe suite tools that are necessary for the business and media team to do their job. And we even do sometimes we do some more sort of, I guess, I can't think of the word for it, but non-technical type training, I guess, where we sometimes invite parents or mentors that have experience in leadership. And we'll talk about leadership ability and how you improve leadership, because obviously leadership is very important for FRC. And then there's tons of online resources available for you to use. So I would just mention a few. Obviously, Chief Delphi is something you can be on 24 hours a day. I am not. I'm not a big Chief Delphi fan because it just sucks too much time out of me. But I know some students that spend time on Chief Delphi, and I think that can be useful. The Blue Alliance has statistical stuff that you can look at. You can look at teams' performances. You can look at videos. The Blue Alliance posts videos of most of the latest competitions. And you can go look at key either qualification or elimination matches and see how teams are doing to develop your strategies. We use those videos all the time to train our strategy team, which I think I'm going to talk a little bit about later. There are a ton of teams that do fall workshops. So I just mentioned our workshops. We run fall workshops at our Capital City Classic competition in October every year, and we stream those live, and we've also recorded them. So if you go to our website, you can access those workshops and get information from that. And then the last resource that I would just point you to is the Compass Alliance, which is a fairly recently formed alliance between some of the FRC teams in first, including 3132 and our team, and several other teams that have basically put together a whole resource center that you can use to get information at every level of FRC, whether you're a rookie team, a mid-level team, or even experienced teams can get all kinds of information from this resource. So I'm sure if you need more information about that, you can get that from 3132, or you can just go to our website and there's a link to it on our website too. So I want to talk about off-season competitions because I think there's a huge opportunity if you haven't attended off-season competitions. And it works in your favor in so many ways. I would say number one, as a recruitment tool, and you can recruit, it's not just, I'm not just talking about recruiting team members, I'm talking about recruiting mentors, sponsors, as well as new team members. Because when you talk to people about FRC, they go, yeah, that sounds pretty cool. Yeah, I could see how that'd be interesting. When you take people to an FRC competition, their jaws drop. And this has happened every single time that we have brought, like, for example, one of our school board members or our high school principal. If you haven't had these people attend any kind of a competition, then you definitely should get them to do that, because you'll see the results are amazing and things start spiraling from there, and your team will get so much more support. So obviously, if you could get them to an FRC regular season competition, that'd be fine. But off-season competitions are usually a little bit lower entry bar. You know, it's just the time of year and it's lower key, and so it's easy to get people to come to them, I think. It's an opportunity to use your off-season robot. If you did build a practice spot, you can bring that. A lot of these off-season competitions allow you to bring as many robots as you want. So we have typically brought up to 3 different robots to off-season competitions and competed with them all. And that gives a lot of members of your team an opportunity to drive the robot and be the drive coach and things like that. So you learn a lot from other teams, obviously, and you can train your scouts. And then most importantly in FRC, if you're not having fun, then you should be, because it's supposed to be fun, right? So doing things to provoke, to increase morale is very important for your team. So we hold regular team events and parties. Obviously during COVID, this is harder right now. We work on outreach projects, and then we have regular, what we call WETPANs. WETPAN stands for work all day, play all night. So we use these as an opportunity to work on doing basic things like cleaning up the shop and getting things ready for competition, et cetera. And then the play at night things, or play all night, we host little games and competitions that the students can get involved in and have fun. Okay, so we get to build season. How do we start? So this is going to be a real quick run through. There are lots of details in every one of these steps, and I'll try to just highlight what I think is important. It's very important to read the rules and make sure everyone understands them. So we actually have a rules test to make sure people understand them. It's also very important to develop a game strategy and decide what your robot is going to do before, this is super important, before you decide how your robot's going to do it. There's a great tendency among a lot of students and maybe even some mentors to see the game video and go, oh yeah, we need to build an elevator with a rolly grabber intake with a wrist and, you know, whatever, climbing system, whatever, right? So, and you're already designing a robot when you haven't even figured out how you're going to play the game. You don't even know the rules of the game yet. So this is super important to make sure that you develop this kind of game strategy, how you're going to play the game, which determines what your robot is going to do. So our robot is going to be able to pick up from the ground. Our robot's going to be able to pick up from the human loading station. Our robot's going to be able to shoot this many balls, those kind of things. So come up with a list of attributes you want your robot to have. Then you go into design. We take about 1 to 3 days to complete this process. And at the end of that, we come up with a short list of the mechanisms we want to have on our robot. Then we jump into prototyping. We actually break out into teams for each of the different mechanism designs that we want to try to work on. We have a separate prototyping team, 2 to 4 students. We have at least one experienced student on each team. And we try to even get a mentor on each team. You want to use the simplest materials that you can build the prototype the quickest. And then it's very important that you test and test and test your prototype. Some people, when they build a prototype, they'll, like, for example, in this case, just shoot the ball and it goes in the goal and they go, great, our prototype works perfectly. But what you haven't done is done things like maybe pushed another robot up in front of it, maybe put the ball in a very difficult position to grab, force the ball into positions where it's going to be hard for the driver to actually get to, and see how the prototype works under those stress conditions. So that's what I mean by test, test, test. Make sure you document everything you're doing. And then, and then remember that your prototyping process never, ever stops. We are prototyping all the way through championships. Even while we're competing in the championship matches, we're thinking about ways we can improve our robot. So you're always, always prototyping. The last thing here is FFSS. If you're not sure what that stands for, it's fail faster to succeed sooner. So during the prototyping process, you want to actually be as efficient as you possibly can to get to the failure points as fast as possible so that you have time to change them and improve them. And then you'll have success. So you're always, always prototyping. The last thing here is, my bad. So make sure you have a schedule. Make sure that you build driver practice into your schedule. I would recommend all FRC teams dedicate at least 2 weeks of driver practice into their schedule, which means you really have to build your robot in 4 weeks. It's probably a little unfair for me to say students always underestimate time, because the truth is mentors underestimate time too. So build a schedule allowing for that driver practice and make sure you try to stick to it. Our team tries to get the drive base completely designed and under fabrication within the first week, because we want it actually completed by the end of the second week. And there's a couple of reasons why we do that. The first reason is because we want to be able to start building our superstructure onto it and get a fully built robot. But the second, maybe even more important reason is we want to give a drive base to our programmers so they can start developing the drive paths for our autonomous routines. Because having well-developed autonomous routines has shown to be one of the key ingredients to being successful, particularly at your first regional. you want to decide at some point to design, to freeze your actual design. You don't want to keep iterating your design when you're going through build season, because if you keep changing things up until the last minute, you're not going to actually be ready and tested before your first competition. And that allows you time to actually finish off your autonomous routines and test them with the full mechanism. So come up with a hard deadline for when your design is going to be frozen, and then stick to it. This makes sure that you have time for driver practice. So we get to competition season. This is kind of an old photo, but I kept it in there just to remind us that we don't have this anymore. Obviously now build season is as long as you want to make it into your competition season. There is no hard break anymore. But the main message I'm trying to give here is that use your competition season. So once you start your first competition, use that to improve. And this is really dependent on you signing up for at least 2 or more competitions, and then maybe having the luck of qualifying for championships in some way. Because you learn so much in your first competition about the way to play the game and how your robot works, that you can build on that and be so much more successful in future competitions. So that leads into the idea of building at least 2 robots. Some people think now with no bag day that it isn't really that big of a deal to build 2 robots. We actually build 3. The advantage of having more than one robot is that you can develop different robots at different paces and move your latest and greatest iterations of your mechanisms onto the final robot. And you can also allow different sub-teams to work on the different robots. So we have one that's being developed as the competition robot. And then we have 2 other robots, one that is primarily used by the programming team, and then the other that's used by the mechanical team to test all the mechanisms. So it's important to analyze the game, obviously. So what we do is hold a webcast party, and we start looking at the new game as soon as it comes out in week 0. If we're not in a week 1 competition, obviously we're going to watch all the week 1 competitions, and we're going to look at how other teams are playing the game, because that will help us develop our key strategies. And it also gives you a big opportunity to train your scouts. Obviously, you need to get ready for competition. So make sure you're organized, that you define your roles. Obviously, you should have established how you're going to scout. And then create a schedule that actually says who's going to be where and when. And make sure everyone knows this schedule and has access to it. So we basically create a schedule on the Google Drive, and it's very detailed. It's down to every half hour. This is which team is supposed to be where at what time and what they're doing. Having an organized pit is super important. Our team knows this well because we've been through many years of having very disorganized pits. And case in point was 2015. If you went into our pit at Champs in 2015, it would have looked like we were some kind of rookie disaster team. It was just a complete mess. And ironically, that was the year we won the World Championship. But since then, we've improved a lot with our pit organization. This is one of the better teams in the world in terms of organization spectrum. You need to have management of your scouts. So make sure we have a scout leader that's organizing the scouting team, that's making sure everyone's on their tablets at the correct time. Make sure you know your match schedule. That seems like an obvious one, but it's amazing how many teams don't. You should have a checklist for your robot, having all of the important items. Like, I mean, it may seem silly, but make sure the battery's been replaced, something our team has been guilty of in the past, not having a fully charged battery on board, which will kill you. And then obviously having a good battery management system. So you should have a system where you're checking in your batteries that need charging, and you should have a way of marking when they're fully charged, and have a good rotation system going so that you always have that on board when you're competing. There's some other things that go along with the technical stuff, like having a great team image. I think that always helps to work on your team image. And we tell our team to go out and make as many friends as they possibly can, because it doesn't just help them, it helps you as well. Helps you learn more about FRC when you talk to other teams. ask for and give for as much help as you can. Other teams appreciate it. If you're an experienced team, try to share your resources with them. It always makes you feel good, and the payback's going to be enormous later on. If you have awards to present, make sure you're prepared for those. And there are various awards that are given that are not specific submittals, like some of the engineering technical awards. And so it's a good idea to have people in the pit that are ready to talk to judges about those things. And then, of course, again, make sure that everyone's having fun. Now, I can't emphasize how important it is, particularly when you get to your first competition, that you are the first team through inspection. You want to be first in line, you want to get inspected and get on the practice field. And the reason for that is that you may have noticed that when the first teams get on the practice field, there's only like 1 or 2 teams there. And then what you see is the same teams rotating through the line multiple times before finally at about 2 or 3 in the afternoon, there's a massive line and now you got to wait. So it's a big advantage to get on the real field and play the real game, to tune up your robot before competition. We always do it. Oh, there's the picture I was talking about earlier. It's always good to debrief. It's always good to ask, why did 8678 roll over in all those matches? So I'm going to speed up a little bit because I've got a few more things to talk about. But basically, I just want to emphasize the importance of debriefing every competition. We're going to talk quickly about scouting and strategy. There's objective scouting that you're doing from the stands. If you want more information about how we actually do objective scouting, we have released our scouting white paper. So you can look on Chief Delphi for access to that, or you can just email our team or look on our website. And then the subjective scouting, which is something we started several years ago, which is most important for when you're trying to make a pick list and trying to decide on your second pick, because many times your second pick is not going to be an offensive robot. So the data that you've collected doesn't always tell you enough about who are going to be the best second picks. You want things like good drivability and a good maneuverability, the ability to play good defense. And so we have a Super Scout system. I'm not going to go into that. Again, our white paper details this. And then you need to come up with some kind of ranking system for that data, that subjective data. I'm a big believer in pit scouting. We have a team called SEALs, which stands for Strategic Evaluation of Alliance Limitations. And what we do is we don't go into people's pits and say, can you do this or can you do that, or how many can you score or what can you do? We actually build mechanisms that we can use to test robots. So this is an example in 2016 where robots had to drive up to the batter. This is the wooden thing you see there as a batter. And you all had to be on the batter at the end of the match to capture the castle, which gave you an extra ranking point. And since extra ranking points are so important, one of the ways we try to rank high is to make sure that our alliance partners are well tested in the maneuvers that are necessary for those. I could give you countless other examples of things we've done to test things like crossing the auto line in 2018, in being able to get up on our climber in 2018 so that we can do the buddy climb. We actually build mechanisms to test robots rather than just relying on them saying they can do it. You also get other information from doing pit scouting. When you walk into a pit, you can see how organized their team is. And you can sort of check out their robot for its build quality. So there's a lot of things you can do without actually asking questions. Obviously you want to ask them if it's okay, but I would avoid asking too many questions that you can get the answers to by just looking. Match strategy is super important, particularly during competition. So we've got to the mode of where we actually appoint a strategist. The strategist is actually separate from our drive coach, Mike Corsetto. And the strategist's job is to just communicate with the drive coach, but also to use the scouting data to inform the matches that they're discussing the strategy for. So this is a way of exploiting other teams or your team's strengths and the opposing team's weaknesses. if you are in a position to be picking, you obviously want to develop a pick list, and you want to have the objective, I mentioned this before, you want to have the objective scouting data informing your first pick list, and then the subjective data usually informing your second pick list. Make sure that you actually have a final list. We actually write out our pick list and we hand it to the captain. It's a piece of paper, or whoever's actually representing our team as the person out on the field. And you want to make sure that that person knows to just cross off teams as they're picked, so that you end up picking the best person on the list that's left. So some final thoughts. I just sort of try to summarize some of the things I think are key. Obviously, working hard is so key to first. Stay focused on your goals, whatever they were. Keep thinking back to the design goals that you've come up with and keep focusing on the important ones. Don't try to invent things when other people have done it before you. 1678 every year pretty much copies someone else's mechanism in some way. So we constantly steal from the best. And you've heard it before, so I'll say it again, keep it simple, because the more complicated things you try to do, the harder it is to achieve your goals. And then once again, have fun. So thank you for your time to listen to my presentation. And I think there's a couple of emails here you can jot down. I guess, is there a way that we can make this presentation available to everybody?
Yeah, the videos will be uploaded to YouTube afterwards, so people will be able to access them from there.
Awesome. So you'll have this, and then there's my personal email and the FRC 1678 Gmail that you can contact us.
We have a few questions from the live chat that I would like to ask you.
Okay.
So the first one is, in your personal opinion, what do you think the optimal team size is?
That's a really great question. I mean, and I'm not sure what it is. I think it's dependent on your team. I will tell you we're at about 100 people right now, and I'll be honest, I think that's a little too big. It's getting tough to manage that size of team. We actually discussed this a couple of years ago, and there was a proposal to say, could we limit our team to about 50 team members? And maybe that's a number that I could throw out as being an optimal team size. I think there are very, very successful teams, 330 being a good example, who have a very small team size. I think 330's team at the last championships that they were at, which was 2019, I believe, right? Is that when 330 was? I think that's their last year. I think their team size was probably about 12 or 15 or something like that. So they did very well. But if you want a full scouting team and you want to have all the logistical support that I've been talking about, I think you need between 40 and 50 team members. We take 44 to competition. So I hope that answers your question.
Yeah, thank you. Another question. What would you recommend that teams do when meeting up online, since they can't meet in person? How would they go about meeting online?
That's a great question too, and obviously we're trying to do more and more of that now because of the COVID situation. I think one of the great benefits of meeting up online with other teams is you just get to connect with people and get to know them personally. So I think that's super important. Have a prepared list of questions that you want to ask the team. If your focus is outreach, have specific questions you would like to ask them about outreach. If your focus is technical stuff, have those questions prepared. But I think going in with very specific prepared questions that you're going to ask is important. Otherwise, the conversation just can tend to just go around in circles, and you have a good time, but you don't learn a whole bunch.
Yeah, I agree. Thank you. Another question. What is your opinion on building a drive base before the game is actually announced?
I'm not sure that's technically even legal, but Perhaps with the no bag day rules now, it is technically legal. I would have to defer to someone who's read the rules in more detail than I have. But assuming you could technically build your entire drive base ahead of time, I think you're taking a risk. Obviously, the risk would be that you'd have to just toss it aside and start from scratch and build another one. So maybe a team with a lot of resources wouldn't consider that a great risk. But there have been years where 1678 has deviated, I wouldn't say significantly from their basic West Coast six-wheel drivetrain, but for example, in 2016, we went to an 8-wheel and we had pneumatic wheels and it was higher off the ground. And if we had just built our standard drive base, it would have been a complete failure in 2016. So if you're super efficient, like I say, you should be able to get your drive base built in a couple of weeks. And I don't think that's a severe detriment to your team because you're going to be doing a lot of prototyping in the first 2 weeks anyway. So you're not really ready to do anything more than just your drive base. And so I would sort of say, wait and really understand the rules of the game before you start building your drive base. But once you do know the rules, jump on it and build it as quickly as you can. Hopefully that answers your question.
Another question. Do you have any tips on establishing a good scouting culture for your team?
Yeah, that's another really great question. Scouting culture is something that we've struggled with ourselves because just to give you an example, at competition, we send our scouting team over to the doors of the arena early to stand in line to get in, to get a good place in the stands. And then about an hour later, our drive team comes because our drive team is going to go into the pits, and it's pretty easy to get into the pits fairly quickly, whether you're in the front of the line or not. So there was some resentment between some of the team members that why is it the scouting team that has to stand in line for an hour? And so we're trying to deal with that. And part of the reason, part of the problem, I think, is that the scouting team sometimes feels undervalued because they don't see their role as important perhaps as the drive team's role. So we've made it super clear to our scouting team that number one, we can't compete effectively in qualification matches without the scouting data. Their data is absolutely critical to our team's performance in qualification matches. And then the second thing is that 1678 is really proud of the picks that we've made when we've been an alliance captain and being able to pick our second and third robot. And I think we've developed a very successful scouting system that gives us very good choices. And we've let our scouting team know that that is the case. So we feed that back to them, we celebrate them, we tell them how important they are. And I think all of that goes towards building a good culture.
Yeah, scouting is very important and your approach is very good.
It's just as important as the robot.
Yeah, it is. Yeah, we have another question. Are there any examples that you can give of your team stealing from the best and inventing the rest?
Well, if you look at our intake in 2018, you will see, sorry, 2019. If you look at our intake in 2019, you will see that it looks remarkably like 1323's intake. So there's one example. In 2013, which is the first year we got to Einstein, we had a robot that was barely able to shoot Frisbees at the Central Valley Regional that we ended up winning because we got helped by a great cross-court shooter. But at that competition, we saw 973's shooter, and we literally just copied their shooter and put it on our robot, and it improved our robot dramatically. In 2011, we literally put an image of Team 100's Rolly Grabber up on a screen, and we drew on a whiteboard around the edge of it, made a template, and we built our Rolly Grabber on that. We've copied 254's ramp designs. We've copied 118's can grabbers. We've copied 3310, kind of a combination of 3310 and 118's can grabbers in 2015, which set us on a path to winning the World Championship. So is that enough examples? I mean, I could go on. I'm sure I could come up with another 20.
Those are really good examples, though. Thank you. Another question. How do you teach CAD and designing for FRC in the summer?
So we've moved to Onshape right now. And I'm a teacher, so I teach an intermediate robotics class where we actually do some Onshape too. So I'm pretty familiar with the tutorials. Onshape has a great educational platform. It's free for educators. And it has a whole bunch of learning pathways. So under the guidance of our senior CAD designers, we have our CAD designers go through the Onshape learning pathways and tutorials. And then we start giving them specific design projects on the robot. So the junior CAD design members are designing smaller mechanisms or smaller parts of our overall robot and allowing our main designers to incorporate those into the full robot design.
And one final question. How do you feel about systems where members need to apply and get accepted before joining a team?
Sorry, can you repeat that?
Yep, sorry. How do you feel about a system where members need to apply and get accepted before joining a team?
Someone obviously knows that's what we do on our team. I think we've gone to that system partly because our team has grown so big that we're in a position, like, for example, this year, if we had accepted every applicant, we would be growing to about 150 students. And we literally don't even have a building big enough to support that. So for us, it's almost out of necessity, but I really like the process. I like the process because it gives you an opportunity to talk to people about why are they motivated to join your team. And I don't know about your teams, but on 1678, we don't want people that are super smart. I mean, we love people that are super smart. I'm not saying we don't want them. I'm just saying that that's not our key thing. We're not looking for people that are super smart. We're not looking for people that already have a bunch of expertise. We're looking for people that want to work hard and dedicate themselves to our team. And it's the easiest way to find out whether they're going to do that is to actually have them working on your team. But prior to them joining your team, the only way you're going to know that is by at least talking to them and asking them a few questions. So I think you get a pretty good idea of that level of dedication. When someone is late to their interview, or someone shows up with kind of a sleepy attitude or doesn't seem very interested, and when you ask the question, what inspired you, they say, oh, I don't know, my mom said I should do it. You learn a ton about whether that's the kind of person you want to have on your team. So I think it's a good process. I like it.
Sorry, I thought that was the final question. We actually have one more question.
Okay.
When you're analyzing a new game, what are some things you look for or keep in mind when determining how to play it?
Man, you guys are asking super good questions, super hard questions. That's obviously something we have to go through every year. It's so hard to answer in one or two lines because there's so many different angles we approach it from. We have students that are very interested in statistics, so they're looking at the scoring system and how maximum points could be achieved. We start to look at counter strategies like that could be played against an offensive team, as well as looking at offensive strategies. Obviously, we're looking at how you maximize your points. But I will tell you that I think some of the keys that we probably focus on a lot are what kind of an autonomous mode can you do that is going to give you an advantage coming out of autonomous? That's one of the first things we're looking at. So you'll notice that 1678 always posts a censored video of our autonomous mode that we've developed that can score 2 balls in 2016 when no one else thought that was possible. So we look at ways that we can maximize our autonomous, and I've lost my train of thought, but definitely with autonomous, we're looking at ways to do that. Yeah.
That's all we have time for today. So thank you very much for your presentation. It was very insightful. I'm sure that it will be very helpful to new teams or people looking to improve how they view the game.
You're welcome.
Thank you very much.
I really enjoyed being here. Thanks very much.
Have a good night.
Take care, guys.
Is that a conclusion? Oh, I guess that was the end of their question.
Take care.
Hello. You're muted.
Sorry, hi. So it is my pleasure to introduce our next speaker who will be talking to us about core values, how, what, and why. This is Yoji Shimizu from
That's okay. How are you?
FRC Team 1816, The Great Machine.
Thank you. How are things going? And presentations have been great so far.
Yeah, they're going all right, thank you.
Good.
It's been really interesting to see them.
Yes, absolutely. Well, I want to thank the organizers of 24 Hours of STEM for giving me the opportunity to present this evening. And greetings from the state of Minnesota here in the United States, and hope you're doing well wherever you are. I'm going to share my screen now and kind of get this started for you. So let me introduce myself first. I'm Yoji Shimizu. My pronouns are he and him and his. And I've been involved with FIRST Robotics since 2005. And actually my first exposure to FIRST Robotics was as a parent chaperone for my son, who was a member of Team 1816, The Green Machine, in its initial rookie year. So that was FIRST Championships in Atlanta. And then I started volunteering for the program around 2009. And initially started as a game announcer, and then more recently have been serving as a master of ceremonies for regional events here in the Upper Midwest, as well as at FIRST Championships in St. Louis, Houston, and Detroit. And I've also been working as a mentor with Team 1816, The Green Machine. And really what I'd like to do today with our presentation is really to talk to you about core values. And really what we're going to do is we're going to talk about kind of defining what core values are, why we think they're important for an FRC team, and then take you through a process that we used to help the Green Machine 1816, as well as other teams here in the Upper Midwest in the US, to develop and identify core values for their team. And then we'll end up with some discussion about the potential positive impact of having done that kind of exercise. So, so really, this is work that was really started initially with Team 1816, The Green Machine, here in Edina, Minnesota. All right, so let me take you through this process and talk to you initially about what we're talking about when we're thinking about core values. And really, what core values are principles or standards of behavior for a person or an organization. And we're really talking here about essential and sort of bedrock or constant principles. So these are principles that really help a person or an organization, or in this case, an FRC team, to really guide and dictate their behavior and to clarify who you are and what you stand for, and to guide you in making decisions. Now, a lot of decisions, maybe many decisions on an FRC team may be fairly easy, but there will be times when a team will have to make some really difficult decisions. And it's during those difficult decisions in particular when you really need to lean on your core values and really use them to sort of figure out essentially which pathway you want to take. It's really designed to kind of help you determine if you and your team are kind of pursuing the right path. So, so that's kind of what we're talking about here when we're talking about core values. Now, in FIRST Robotics, you know, all of us have actually one common foundational core value, and that is, of course, gracious professionalism, right? So this is really, as Woody Flowers has defined, part of the ethos of FIRST. It is a way of doing things that encourages high quality work, emphasizes the value of others, and respects individuals and the community. And this is a very important and vital part of FIRST Robotics. But I think it's really important to remember that gracious professionalism is necessary, but probably not sufficient for every FRC team. So when we think about this, we're really thinking about gracious professionalism as being kind of the foundation for a team. And built on top of that foundation of gracious professionalism will be a set of core values that are really kind of unique and specific to the team and what it's trying to do. And so that combination of the core values as well as the gracious professionalism is what allows a team to kind of fulfill its mission and its vision. So you probably have heard this before, that in many, FRC teams are really kind of like businesses, and all businesses have mission, vision, and values. And this is the same process by which FRC teams operate. So, the mission is really kind of what you want to accomplish as a team. What is the overall vision that you have in terms of what you're reaching for as an FRC team? And the core values really define kind of how you're going to accomplish that mission. So how are you actually going to go about doing your work and defining how you're going to move forward. Okay, so when we initially began this process of trying to help a team to kind of develop its core values, we had a number of kind of what I'd call kind of key principles that we were trying to use as we were kind of developing this process. And these were the ones that were really most important for us. So one of them was that we really kind of insist that the entire team should participate in this process, because as you'll see in a minute, the way in which this process works is that individual team members contribute their own kind of set of personal values into this discussion. So this is a way to kind of create team buy-in into the overall process. And so when team members aren't there during this process, then of course we don't get the value and the benefit of that team member's own values and kind of their perspective. And so it becomes more difficult later on as we go through this process to get the entire team to kind of buy into the overall final sets of core values that are identified and defined by the team. Second principle is really that we want to create a very safe space for discussion, because this is a process that involves a lot of vigorous discussion, what some friends of mine will call intense fellowship. There can be some disagreements about which way you want to go, which value is the most important. So you need to create an environment that allows for those kinds of sometimes difficult, intense conversations to happen. So in many cases, we kind of begin the process with some team building or other kinds of approaches in which a team can really feel comfortable kind of talking about these kinds of questions. A third principle is that we want this to be entirely student-driven, and this is really just based on the fact that Team 1816, the Green Machine, is really a very student-driven team, and this is really comes back to the history of the team and the way it was started, which is really the team was founded by an 11th grade student at our high school, and so that's sort of the culture that's been established within the team that we really want the students to drive the process. But at the same time, we value the advice and guidance of our mentors. And in this case, actually, we decided to have the mentors kind of work in parallel with our students, so that they kind of went through this process at the same time, but sort of independently of the students. And then we took what the mentors came up with, and we took what the students came up with, and we allowed the students to decide, are there things that they would like to take from what the mentors developed and incorporated it ultimately into their team core values process. Now, we've worked with other teams in which the mentors don't work in parallel, basically work together with the students. And that works just as well too. It really kind of depends on your team culture and kind of where the team would like to invest, I guess, in the work that the mentors put into the team as well. So that's a team decision, a team specific decision that needs to be made before the team kind of engages in this kind of process. And then the fifth and final principle was we really wanted a third party facilitator. So we wanted someone who was not a regular kind of day-to-day mentor, but someone who could who knew the team, but could also kind of facilitate and be independent of this entire discussion between students and mentors. And at the time that Team 1816 kind of went through this process, I was in that kind of position where I was able to serve as the third-party facilitator, in the sense that I had done mentoring with the team, but it wasn't in all aspects of team function. It was only in specific small aspects of team function, and so I was familiar with the team, but in a position where I was not maybe perceived as being embedded within the team as one of the really strong regular mentors on the team. So I think that was helpful as well in terms of making this process work well and making both the students and the mentors feel that their voices were being heard through this process. All right, so what I'm going to do now is kind of, for the next few minutes, kind of take you through this overall process. So this is actually the way in which we go from a large number of values down to a final set of team core values here on the right side of the screen. So really the way you should think about this is maybe like a funnel. So you put a bunch of marbles in the funnel, and then ultimately at the end you winnow this out till you get a small number of marbles that come out of the funnel. That's really what this process is kind of all about. So you begin with a large number, kind of a survey of different kinds of values that you might want to consider, and then an iterative process by which you narrow that list down to a smaller number of values to the final point where you get a final set of team core values. All right, so let's go through how this works, or how we're currently actually doing this process for teams. So we'll start here with this process here, which is basically kind of identifying the values. So this is basically the process of kind of generating a large list, a master list of all values that the team might want to consider as part of their core values. And the way that we do this now actually is with a survey. And so we use a Google Form survey, which we actually send out to a team before we actually get together in a workshop. So this is an example of one of these core values surveys, and basically it just indicates that you'll be participating in a workshop to identify the team's core values, essential principles or standards of behavior for this particular team. So this is a pre-workshop survey that's designed to kind of generate that this larger list that's shown here in this slide. Right. And so to set this up, we provide a couple of additional pieces of information. So one is we ask everybody who's completing the survey to actually watch a TED Talk. And this is a TED Talk that's called Why Values Matter. So it's very short, 9-minute TED Talk that basically goes through this process of defining what is a core value, or what are values, why are they important, why do they matter, why should you spend time actually figuring out what your core values are. So that kind of helps frame the discussion and allows students and mentors to think about what kinds of values they would want to put down. And then this is the actual instructions for the survey, right? So the survey basically is sort of, again, defining what these values are. These are the things that you believe are important in the way that you live and work. And again, these values serve as guidance in determining how you do things. And in the TED Talk, these are kind of defined as situation-independent decision helpers, which I think is a really interesting and good way to think about why you would even want to think about having identified values. And then we give a couple of questions or prompts. So how do you identify values that are important to you? You know, there are ways you can do this where you can think of people you admire or love? What values do they embody? Think about organizations that you admire. What values do they embody? Maybe identify the times when you were happiest. What were you doing? Identify the times when you were most proud. Why were you proud? Or identify the times when you were most fulfilled and satisfied. How and why did that experience give your life meaning? So those again these are kind of prompts to get the person filling out the survey to really think carefully about the values. And then for some people, they actually just want a large list. And so we also provide actually a link to a document, a PDF that basically has a list of a large number of core values. So if someone who's completing a survey just wants to kind of look through that list and identify the ones that they resonate with the most, that's another way to do that as well. And it's really, really important at this point, I think, we really want everybody who's completing the survey to think about their own kind of personal values, like what's really important to them personally. So again, in this case, there are really, through this entire exercise, there are really no kind of right or wrong answers because the values are really unique to who you are. And when the team develops the values, they'll be completely unique to who the team is. So we really want this personal investment and sort of we want everybody completing the survey to really indicate kind of what personally is really, really important to them, because that sort of helps define the team culture as you move through this exercise. So in this particular case, we asked everybody to enter or identify four values, their top 4 values. Now, the total number of values that we kind of asked for in the survey kind of depends a little bit on the size of the team. So we've worked with teams as small as 5 or 6 students and 1 or 2 mentors to teams as large as 75 or 80 students and 20 mentors. And again, we're looking for a large number of values here, but not so many that they're unmanageable. So again, for a smaller team, we might ask for 5 values. Maybe for a larger team, it might be 3. And you can imagine that multiple people will identify the same value, right? Which is fine. But ultimately, you're going to end up with a pretty large list of values once you compile all the results from this survey. So once this survey is completed, we end up with a large list. And so this is, for example, and this is when we bring the team together for the core values workshop. So here's a set of sheets, and they've got a bunch of core values here. There are values that are listed here. This is probably 35 or 40 different ones that are listed. And this is what was generated from this kind of survey, right? So, so we're taking every single value that was identified in the survey, putting them down on big sheets of paper so that the entire team can take a look at them as they go to the next step in this process. So the next step in this process is actually trying to pick out a smaller number of these as being the most important. And so when we're talking about the number here, we're really probably talking about anywhere between 12 or 13 values to maybe 20 at the most is what we want to kind of come up with. And the way that we do this is actually we do kind of this affinity or dot exercise. So we give each person participating in the workshop a set of 5 sticky dots. And we ask them to go up to the sheets and put a dot next to their 5 most important values. And again, the rule here is that a person has to put a dot next to 5 different values. So they can't put 5 dots on one value. So we want them to identify 5 different ones. So you can see here in both of these, there are lots of dots that have been placed against some of the values and few, if any, dots placed on others, right? And that's how we end up with this kind of smaller list of values. This is shown over here as well with this particular team. You can see some of these values, they've got dots going all the way across the page, which really shows you that those are the ones that the team members have really identified as being particularly important. So we've gone from this larger list, and now we're down to sort of this smaller list of kind of 12 to 20 different values. To make this a little easier for you to kind of understand how this process works, here's a list actually of values from one of the teams that we've worked with. And in parentheses are basically shown the number of dots that were placed next to each of these different values. So you can see this ranged from anywhere from some values where just one person identified them as important to those where there were 4 or more people that I identified these as being particularly important. And for this particular team, they decided that they wanted to work now with the ones in red. So the ones in red, the values in red were the ones they wanted to consider moving forward in terms of their kind of key core values. And again, this is all up to the team and the way the team would like to proceed. You know, there's nothing magical about 4. It's really just kind of dependent on taking a careful look at these different values and trying to decide which ones are the ones they want to consider moving forward. So, so in this case, you know, it was 2, 4, 6, 8, 10. It was 12 different values that they were kind of working with as they move forward. All right. So that's that next step. And so, so now really having 12 different values is really generally probably too many for a team to really, for that to be useful. So we really want to get this down even further to really somewhere between probably 4 to 7 different core values ultimately. And so the next step of this process is actually to take that list, for example, in that previous slide of 12 core values and group them together. And so if there are ones that the team members feel are similar to each other, we ask them to kind of put them into smaller groups so that those 12 core values, you know, decide to put them into 3 or 4 different clusters, if you will. And within each of those clusters, identify the value that's the most important to that cluster. And when we do this really with small groups. And so we break the team up into smaller groups of 4 or 5 different people, and with students within each group, or sets of students and mentors. And the way this kind of works pretty well in person is to give them, for example, small index cards and ask them to write each of the 12 different values on a different index card so they can kind of move them around on a table and figure out which groupings they want to put them into. And that's, for example, what this particular set of students is doing here. Is they've got all these different values listed on these different cards, and they're basically kind of discussing and moving them sort of to see how that overall process, what those different clusters kind of looks like. And then we bring the entire team back together, and we basically compare. We share and compare how each of the small groups kind of did this to see if there are any kind of common themes. Can we identify any common groupings of values that multiple groups, multiple subgroups have been able to identify? And so we often do this just on a computer screen with a PowerPoint or Excel sheet, as shown in this particular slide. And there's lots of discussion here. This is probably where the bulk of the time is spent, actually, in discussing what makes the most sense. Do you agree with this particular set, putting this value together with this one? And there's lots of really interesting discussion that takes place when you get to this point of the process, in terms of seeing what the different groups kind of come up with, and ultimately coming to some consensus about what is really important and how this is done. So again, let's turn back to this previous slide, and let me show you kind of, they took these 12 values in red, and this is actually the result of the 5 different subgroups that did this exercise. And we tried to color code them based on the ones that were pretty similar. So you can see, for example, here, this value of commitment or committed and dedicated was often put together by multiple groups. Not every single group did that, but you could see that at least here 4 of the 5, actually all 5 of them here in this process did that. And there were others that were sort of put together as well. Supportive, encouraging, and positive, for example, were often lumped together by multiple groups, which allowed them to come to some agreement about what they wanted to do. So after this kind of group team discussion, they ultimately ended up with this set. And so this was the final set, and they identified sort of 4 core values: integrity, passionate, determined, and supportive. And then they have these other values kind of underneath those, the header, if you will, or the most important one. What's interesting about this particular team was actually these 4 values in red were actually never in this initial discussion. So this team spent a lot of time talking about all of these different ones, and ultimately decided to go back, take a few steps back, and think about this some more, because they thought they were missing something. And so ultimately what they ended up with was actually integrity as a really key core value, even though that didn't come out of this initial process. So, so they put in 4 additional core values in this process, which was interesting, and again, kind of illustrates kind of the flexibility of this approach in terms of you can always go back, rethink it. As you discuss more and more, you begin to see whether in fact these really kind of represent the core values that you want. But this is basically the process that they used to ultimately come up with these 4 groupings of values as they move forward, right? So that's that process, and that's basically kind of where the overall kind of workshop for us kind of ends, where the entire team is together. So you end up with these, 4 to 7 kinds of values. You have some other values that are kind of put together with them. And the challenge at this point is really to kind of finalize those, to get the team to really think carefully about whether in fact those are the really final set. And in many cases, teams will actually draft what we call value statements. So these are sentences or paragraphs or additional words that basically provide some context to what that value actually means to the team. And so this can be done in a variety of different ways. Generally, it isn't facilitated. It's done either with the entire team independently, or perhaps with a small subcommittee of the team that's really interested and committed to kind of drafting those statements. So let me show you a couple of examples of what these statements look like. 2 are from FRC teams, and 2 are actually not from FRC teams, but are good illustrations, I think, of what these ultimate final core value statements look like. So this is an example from Team 1816, in which this 1816 actually identified a subset of team members. I think it was 4 or 5 team members who worked with a couple of mentors to basically come up with these value statements. And so one of their key core values was trust, and underneath that, they grouped together dependable, reliable, respectful, and accountable. And they had one team member basically draft a statement. And so that first draft of that statement was basically, we believe that our team collaborates most effectively with a foundation built on trust. We follow through on commitments, encourage open and honest communication, are credible and reliable, and act with candor and accountability. So that statement was brought back to this larger values committee, and then the committee basically spent some time basically editing and changing this to a point where everybody on the committee felt happy about it. And so the final statement that was developed was basically trust for this team means our team works at its best with relationships built on trust. We live up to our responsibilities by being credible, reliable, and accountable. And we create a safe environment that enables open and honest communication. So you can see there are some of these other kind of sub-values that are embedded in these statements, like reliable and accountable, and the safe environment that enables open and honest communication kind of encompasses the respectful part of that set of values. So this is the statement that was brought back to the entire team. The entire team was presented with the entire set of statements, and the team basically voted to adopt them as the team's core values. So this is what that looks like. So this was the process for Team 1816, the Green Machine. This was developed actually at, the workshop was actually held at a team retreat, and then that was in the fall of 2017. And over the course of the next 2 to 2.5 months, the team, that values committee basically came up with these value statements for the 5 team core values, which were respect, trust, inclusivity, commitment, and joy of life. Right. So that was the process that resulted from this first kind of core values workshop that we did with Team 1816. And let me show you another one. This is from another team here in Minnesota called the Robettes. This is an all-girls team from just outside of the Twin Cities, and we were honored to work with this team to help them with core values, which they wanted to do in the fall of 2018. After they had won the Chairman's Award, or their first Chairman's Award, they wanted to kind of really crystallize what their core values were. And so they came up with confidence, integrity, compassion, perseverance, and curiosity. And again, instead of having statements in this case, they had sort of bullet points. So confidence is having faith in one's own abilities and standing up for them, not worrying about what others think when we put ourselves out on a limb, trying new things. So I know that this team spent a lot of time on this set of core values and lots of meetings where they really thought carefully about each and every word in these statements with the core values. This was a really important exercise for this team in terms of identifying exactly what they mean by confidence, integrity, compassion, and so forth. So that's how they work this. Now, let me show you two other examples of core value statements. So this is not from FRC. This is actually from Tony Bennett. And if you're a college basketball fan here in the United States, Tony Bennett is the head basketball coach at the University of Virginia. And the University of Virginia won the NCAA championship in 2019, I believe. And this is essentially a tweet from the coach describing Tony Bennett's program pillars: humility, passion, unity, servanthood, and thankfulness. And these are essentially the core values for his basketball program. And again, here, instead of large, long statements, he's just got a couple of additional words, you know, humility, know who you are, passion, love what you do, unity, stick together. So one advantage of kind of this smaller set of words is basically it's fairly easy to remember what they are. So in that sense, there's some value in terms of they're kind of sticky. It's easy to kind of remember. And so I think that's one potential benefit of kind of being a little more concise and succinct, but I think either approach kind of works. And then I don't remember exactly when, but FIRST actually also recently kind of identified its core values. And so this is their statement of, we express the FIRST philosophies of gracious professionalism and cooperation through our core values, which are discovery, innovation, impact, inclusion, teamwork, and fun. And again, they've got very, very short sentences that define what those core values mean to FIRST as an organization, right? So those are 4 different examples of core values and the value statements that go with those. All right, so this is again the entire process in terms of the time commitment that's involved with this. You know, when we initially started these workshops, we actually got together the entire team and actually went through this process of identifying the values together as a team. The disadvantage was it made the workshop longer, and I think the other disadvantage to that approach was it didn't really give team members and mentors time to really think carefully about what are the values that really matter to them as an individual. So that's why we turned to this kind of pre-workshop survey in a Google form, because this again will give team members and mentors time to think about this question a little bit more carefully before the actual kind of in-person workshop or team workshop takes place. So once that's done, the rest of this here, these 2 steps generally take about 1.5 hours to 2 hours to do this. And again, that's really not dependent too much on the team size. It's a small team or a large team in general, it takes about 1.5 hours to 2 hours to work through this process and ultimately come up with those kind of clusters of values. And then this part, the finalizing the values and drafting the value statements, this can be done in a variety of different ways. It can be facilitated. It doesn't have to be facilitated. In most cases, it's not. It's generally done by students and mentors on the team. And it can be anywhere from a couple of days. Some teams have told us that basically it was very quick for them to kind of figure this out and draft their value statements. There are other teams where it takes months to do this. It can take 2 or 3 months in order to kind of identify this and come to an agreement about what the final values are and what the value statements are. So in many cases, teams that we've worked with start this process probably in the fall and try and get this entire thing done before kickoff, so that, you know, this is really not an exercise that can be done effectively during build season. It's really something that is kind of a pre-season, pre-kickoff kind of activity. And the value of doing that is that once the intensity of build season kind of comes around, these values are hopefully embedded in the team and the way the team works, and will make everything that the team does work more efficiently and more effectively. That's really the hope and the purpose of doing this kind of work before everything kicks off with kickoff and build and competition season. All right, so we have worked now with 24, 25 different teams All of these teams are in the upper Midwest of the US, and we've been delighted to kind of work with each and every one of these teams to kind of help them with this core values exercise. And I can tell you that every team comes up with a unique set of core values. The process is identical essentially, but every team is unique, every team is different, and it's really fascinating and wonderful to see kind of the unique sets of values that each team identifies through this process. So I hope that for each of these teams, it was a process that was worth the time and the investment that was put into it. So these are just some pictures of teams that are kind of working on this process with us. And again, you'll see lots of examples where teams are, group team members are kind of clustered around tables, kind of thinking about how their values should be arranged, or doing this kind of dot exercise to identify kinds of their top five values. But these are just some examples of the way in which this is done for these teams. So we've done some feedback on this with teams. So we've gotten 42 different responses, and just I think there's for the most part, teams are quite satisfied with the investment in this in terms of the workshop living up to their expectations or sustaining the interest and participation of their team. The importance of having an outside facilitator, whether it was a benefit, and whether they would recommend that other teams complete the core values exercise. So again, almost all of the responses that we're getting back agree or strongly agree with these particular statements. So in terms of like an overall rating, 95% of the responses again rated the overall kind of exercises as excellent or outstanding. And this is one example here of one of the teams that we worked with just this past season that came up with a set of really wonderful core values and really strong value statements. So let's talk a little bit about impact, I guess, and sort of why this is of importance for an FRC team. So so this is a slide from the Green Machine about this issue of impact. So for the Green Machine, really this has been an exercise where the core values have really helped with guiding decision making. It's really a way in which to kind of provide a concrete focus on what the team really values. And it was really important for 1816 that everyone was involved in the process, because it fully reflected the team and allowed them to really think about what they're doing and making sure that everything that they're doing fits their vision, their mission, and is done in a way that kind of honors the core values that they've identified. It guides kind of everyday behaviors that the team kind of works on, and this is at every single aspect of team function. So everything from outreach to the build season to what happens at competitions. It's a pathway to gracious professionalism as a student and beyond, and has served as a really important unifying force on the team and a way in which to kind of really energize the team. And I think for this team in the fall of 2017, this came at a really important time for the team. And I think, since the development of the core values, really this team has had some of its most successful seasons ever. We hope that some of that was due to the fact that they took the time to kind of really think about what was important to them, so that they could really focus on the things that were really key to their vision, mission, and values. There are a couple of things about this once you go through the exercise that I think are important to kind of remember. So one is that just be 10 times as clear about your values as you think you should be. So once you identify what they are, it's just really important to remind yourself and to remind the people that you interact with, your community, other teams, what those values are. And I don't think you can ever kind of overemphasize the values that you have and why you think they're important. It's often useful to kind of use some catchphrases. These are often very simple and action-oriented and forthright. Some teams have developed acronyms to kind of remind themselves of what their core values are. And those are often very useful to kind of remember and keep them in mind as you move forward with your activities. And then it's really important to kind of use kind of artifacts that actually remind yourself as you're working, either in the workshop or in your pits or in the community, kind of what your values are, so that you can really remind yourself about what really matters. And when we're talking about artifacts, we're really talking about symbols or other kinds of things that emphasize these core values. So let me give you examples of some of the things that teams have done with this. So one is, for example, pit banners, and that's what this team 5690 did. So that large banner is basically the banner that now hangs in the back of their pits at competition. So again, this is a very visible reminder to the team, as well as anybody who visits the team, kind of what they're all about. And so that's a very effective kind of artifact. You can have values posters in your workshop and other areas. So this is actually the Robettes set of values, 2177. And this is actually a poster that's hanging in their workshop. And they have a number of these kinds of posters that are all over their workshop, again, to just kind of remind the team about what their core values are. Obviously, you can do swag, team shirt, t-shirts, buttons. This is an example of a lanyard from another team, which really defines a list of values that are important to them. So, every team member is wearing this lanyard at a competition, and right on the back of the lanyard are all the different values that the team has. So that works effectively well. And you can also come up with things like awards to recognize team values, team members who kind of exemplify the team core values. I'm sure as a team you can think of lots of different ways in which you can be creative in terms of making sure that you're remembering what your core values are. So again, this is a quote from a book called The Culture Code by Daniel Coyle. And this is a book about successful organizations and what makes them successful. And again, the key thing is about you can never overemphasize the importance of your values. So when I visited the successful groups, I noticed that whenever they communicated anything about their purpose or their values, they were as subtle as a punch in the nose. So it's, again, very, very important to kind of let people know kind of what's important to you and what matters to you. All right, so a couple of things about sustaining core values before we finish up. So, there are some, going through the exercise, it's a little bit like, for an organization to maybe do like a strategic plan. So in many cases, unfortunately, organizations and companies will spend a lot of time working on a strategic plan, and then that plan gets put on the shelf and nobody ever looks at it again. And that's really not what you want as an FRC team when it comes to kind of developing these kinds of core values. So you have to think carefully about how you're going to use them. And so, for example, there are some questions here that I think teams need to think about. So for example, how will you hold each other to your team's core values? How will your team deal with instances when your core values are violated or disregarded? Teams often deal with this issue, sort of when behavior is not kind of what the team expects, and you feel that they're not consistent with your core values. How are you going to deal with that? How will your team kind of deal with that effectively? How will your team, on the flip side, is sort of you want to celebrate the wins, right? So how will you actually celebrate when you feel that core values are really effectively demonstrated by team members? And then this question of just sustainability, right? So the core values exercise involves the thinking of the team at the time that you do the workshop. And so that team is going to change. Team members are going to graduate, mentors are going to leave, new team members are going to come in, new mentors are going to come into your team. So how will you introduce the team culture with new team members and with new team mentors to your core values? So there are processes and ways by which teams are doing this now to make sure that the team core values are sustainable over time, right? So, these are some examples of what some teams here are doing. So for example, instilling the core values throughout the year through team meetings. I know 1816 has spent some time at different meetings throughout the competition season where they focus on specific core values and go through some exercises again to kind of remind the team about what is meant, for example, by the core value of commitment or respect or trust. the team holds an annual retreat. And again, this is another occasion in which the team can discuss core values and really think about them carefully. And again, at competition events, that's often a case where things get really intense. Some really key decisions need to be made really, really quickly. And again, these are the occasions when understanding, when every team member understands what the core values are, you can make those decisions and feel good about them. There are other teams that actually have, for example, at the start of a season, they'll sign a pledge or a commitment, and that pledge or a commitment will really focus on a reminder about what the core values of the team are. And so having that visible document that all team members kind of sign is a good way of kind of keeping core values alive. This isn't done with, I haven't seen this done with a team so far, but I know of, for example, a church that basically went through a core values process. They printed a large banner with all the core values on them, and they had every church member sign it. And then they put that in the lobby. So again, that's another way of kind of demonstrating that there's buy-in essentially to the values that have been developed. Again, if you have a team handbook, you can often kind of codify the core values in the handbook itself is another way to kind of do this. All right, so just as a final slide here, I think this is the final one. We have a number of different options that, if your team is interested in doing this work, that we could potentially help you. So, so one is in-person facilitation. So this is something that we have done for teams that are basically within driving distance of Minneapolis-St. Paul. So if anybody's listening from within that kind of circumference, we are happy to kind of facilitate this in person if you feel that that's something that would be useful for you. Now, of course, right now with the pandemic, in person is not really something that can be done. So, so we have developed, we have modified the core values process that I've described in this presentation so that it can be done virtually. So, so that means that we can potentially facilitate this for teams pretty much anywhere. So, so we're happy to do that as well. If this is something that you're potentially interested in, we're actually kind of interested and eager to see how well this will work in a virtual format. So that's another option. And then we also have a guide. So if you would like to do it on your own, we'd encourage you to do that, of course, but we can give you some resources. We can give you access to that survey. We can give you kind of a how-to guide that basically will take you through that process. And we're happy to kind of work with any team facilitator that you identify who might want to do this for your team. And I know a couple of local teams in the area have done this independently and have done a really, really amazing, great job in doing it that way. So these are options that are available for teams if you are interested in doing this. This is not the only way to kind of develop core values. I think there are lots of different approaches that you can take, but this is the one that has worked well for us. So so this is my contact information. Again, please reach out to me directly if you have any questions. On the Edina Robotics website, there is a page on the Edina Robotics 1816 web site under resources that has some more information about the core values process and kind of how we go about doing that. So so I think with that, I am going to stop and take some questions, I hope, and thank you for listening.
Thank you. That was a very good presentation. We have some questions from the live chat that I'm going to ask you.
Sure.
So the first one is, how often should a team reset or evolve their core values?
That's a really, really good question. And I think different teams are approaching this in different ways. So, we're kind of not far enough along in this process to know the specific answer to that question. So for example, our team developed these core values in 2017, and we have not yet kind of made a decision to go back and revisit them. I think some other teams that we've worked with are probably thinking about maybe at every 4 to 5 year cycle in terms of revisiting them. It's a really interesting question because I think in many cases, you would think that the core values would be fairly constant and essential, as kind of described at the beginning. And so maybe they really wouldn't need to be changed on a regular basis. But FRC teams, are a little bit different than a company or organization in the sense that there is a lot of turnover. And so it may actually be a worthwhile exercise to say, let's re-examine these. Let's make sure that these are the values that are still important and meaningful to us. And maybe we want to go through that process again with a completely new team. If you think about, most, I think in our team, probably 4 or 5 years is the most amount of time that any one team member would spend on the team. So maybe that's kind of when you might think about revisiting them. But we haven't done that yet. So I don't really know the answer to it. It's a really good question.
Thank you for that. Another question. How long does your value setting process usually take to complete?
For us, if you're talking about the entire process from starting to the actual point where you have like a document that you would present, for example, to the team or to a sponsor, for example, or in an outreach event, that's really variable. It goes anywhere from a couple of maybe a week or less to months. It really depends. The actual workshop that I described to you today really takes only about an hour and a half to 2 hours. So there's a little bit of advanced work in terms of everybody kind of completing the survey and doing all of that work. But once we get everybody together, either in person or virtually, that should generally take only about an hour and a half to 2 hours. The final piece, which is what you want to do with those values once you've identified them and how you want to define them, is the part that's really variable. With the 24, 25 teams that we've worked with, it's been everything from a couple of days where a mentor has told me, well, yeah, we got that figured out really quickly, to other teams that were like, it's taking us months to kind of figure that out. So I think that really depends on the team and kind of how they want to approach that.
Cool, thank you. Another question, not sure if this is the last one or not. What is the most popular core value that you've seen teams adopt?
That's a really good question, and I actually have that. Let's see if I can. Okay, here we go. All right. So these are the ones that have come up the most with 24 teams that we've worked with. So respect, hardworking, open-minded, fun, trust, teamwork, honesty, integrity have been the ones that have been most commonly identified by teams. I will tell you that the one core value that generates the most discussion among teams is the core value of fun. There's sort of a reluctance by some teams to identify fun as a core value. And it's a really interesting discussion that takes place when that happens, in the sense that there are some teams that are very clearly show that it's a key core value. Other teams where they're just really reluctant to identify it as a core value. And as you heard from Steve's presentation the last hour, right? If you're not having fun in first, right, why it's really important that you have fun, right? So for a lot of teams, that's obvious in the sense that it really is kind of a core value. But for other teams, it takes them a while to figure that out. And so they'll spend a lot of time thinking about different ways of kind of identifying fun. They might come up with a different name for it just to kind of figure that out. But so that's been a really interesting discussion that I've seen with teams. That particular value is one that a lot of teams pick up on right away, and many other teams just never identify it as a core value. And I think it's a really interesting discussion that takes place after that. So.
Yeah, it is really interesting, and fun is something that's very important. You can't have the team without being able to enjoy it. That just doesn't work.
Yeah.
I'm pretty sure that's all the questions we have for now, so thank you very much for your presentation.
Okay, thank you. Yep. Thanks for
Have a
tuning
good
in,
night.
everybody. Yep. Good night.
Welcome to 5 Minute Classroom. My name is Bill Church. Behind the camera is Pete Rogers.
Hello.
Pete, you've seen 3D printers, right?
Oh yeah.
And so we've had 3D printers at White Mountain Science at Whimsy for a while now. What we've been exploring more recently is what if we print our own Lego pieces? The project that prompted this was we needed to attach a marker to a driving robot base. Let me show you how we did it. So the tools we used Tinkercad. We used another website called Thingiverse, like a universe of things. And then we used the 3D printer to print out the final product. First, we went into Thingiverse and we didn't want to ourselves reinvent the geometry of the Lego holes. We anticipated that others had done that before. So we searched Lego beam. And sure enough, others had created some Lego beams. And let's try this one here. I don't actually need to print this beam itself. Instead, what I need to do is bring those holes into Tinkercad in order to make the marker holder itself, because that's the part I'm going to have to use Tinkercad for. So let me go into the files, and I'm going to just copy the address, because that's actually all I need. Now I switch over to Tinkercad. Could this be done in other CAD programs? Absolutely. So here we're just doing it in Tinkercad because that's what I am familiar with, and it's free. And I've got my blank canvas. Well, what I want to do is add my Lego as if I could take this and just put it right down on the blank canvas. Import from a website, and that was the website that I had from Thingiverse. There's my beam. Okay, so I've got that Lego beam in there, and what I need to do is figure out how can I create a shape to grab onto this marker that's attached to those Lego holes. Like my hands, if I grab on, what if I just sort of think of a U shape? I'll be honest, in the interest of time, I'm gonna skip some steps related to measuring this marker to make sure it fits into this particular holder. I just want to show our viewers this process of attaching anything to the Lego beam that serves your purpose. So I'm going to bring a cylinder out here, and then I'm going to bring a second cylinder out. I'm going to shrink this. The neat thing is in Tinkercad I can make one shape a hole to cut it out of a second shape. Let me group them together. And in the case here of my Lego holder, I do need it to kind of be able to sort of come out and as if it's to grab. But what I'm not showing you is whether this holds a wide marker or holds a skinny marker. I just want to show, in this case here, how I've attached to the Lego beam, and then how I've actually shortened the Lego beam. So if I bring that down there, that Lego holder is just on the edge of this beam, and when we combine the two shapes together, they'll be fused and printed as one. But I've got one more trick up my sleeve, because I don't need all the holes in this Lego beam. In fact, I just need a couple. So I'm going to cut those off. So I group that, bye-bye, and I'll zoom out here, and I want to cut those off, group them together, and I've cut it. Now again, interest of time, I'm not worried about smoothing out those edges or anything. So I will fuse them so that it's now one piece, and I've just invented a piece to hold a marker. So one last trick though. Okay, so I have the holes facing up. What if I want the holes facing the side? Let me ungroup. So if I wanted to flip these 90 degrees, like so, and I group them together. And again, we've just invented our own Lego piece to hold a marker. So we've previously printed the design that works with this marker. And if I clip that on there, we can see that fits. My pegs in and attach it to my Lego beam. So I now have a marker holder that I can attach to, say, a robot that drives around. If you want to see more about the robot base and the project where we're drawing on a surface while we're programming the robot, please click on the video that's linked below. Let's go to the whiteboard and point out a few more ideas you can try on your own. In this episode of 5-Minute Classroom, we showed you how to add Lego to another shape to make a pen holder. Where can you go with this? What can you teach with this? So for us at White Mountain Science and in the schools we support, we'll use this for lessons in basic computer-aided
So next up we have a few speakers talking about why to invest in STEM and FIRST Outreach from the FRC team 1816, The Green Machine. Hi guys, how you doing?
I'm good, how are you?
I'm good, thank you. Have you guys been watching any of the presentations so far?
A few.
Have you enjoyed
I
it?
really enjoyed the FTC presentation actually on machine learning earlier. That was really good.
Yeah, it was a very interesting presentation. Are you guys ready to get started?
All
Cool, take it away.
right. Hi, we are Team 1816, The Green Machine, and we are located in Edina, Minnesota, a suburb of Minneapolis, and this is the hows and whys of STEM and or FIRST Outreach. I'm Sam, a rising junior, an assistant captain, and the business lead.
I'm Sarah, I'm a rising senior, and I'm a build lead.
I'm Ian, I'm a rising junior, and I'm the other assistant captain for next year. Overall, we'll be discussing the why do STEM outreach, how to select outreach events that include your mission, vision, and core values, the purpose of outreach, who decides where we go to, when to do outreach, and what to bring. So the first thing we want to talk about is why teams should do STEM outreach. The main question I think and our team thinks is a great question to ask yourself before you even start doing STEM outreach is, would you do FIRST Outreach if FIRST did not connect it through the awards? Outreach matters both on a larger scale level and on a smaller scale local level because it helps teams develop critical thinking, problem solving, and presentation skills that they wouldn't really normally get in a robotics-based environment. So many people come into our shop and are expecting just a bunch of just robots, but that's not really all that FIRST teams do. And it's important that STEM outreach is a vehicle through which you demonstrate this and improve those skills. STEM outreach also allows teams to make a difference in their community, foster growth of robotics programs, and obtain actual legislative impact through STEM lobbying, through grassroots organizing, and through other activities that can boost community appreciation of STEM. Overall, it promotes robotics and STEM engagement on local, state, and national level. Team 1816's mission is to create bold and confident leaders who transform culture to promote, value, and celebrate STEM. This is important to us because it defines what we will gain as a Green Machine member, as well as how we will impact others while attending and completing outreach events.
Our vision is to bring FIRST to new audiences, to be a role model of gracious professionalism, and to use our experience to expand FIRST and make FIRST available to all. So we have something called core values, which are respect, trust, inclusivity, commitment, and joy of life. Respect refers to respecting others, your places of work. Trust refers to trusting your teammates and all the decisions they make. Inclusivity is making sure everyone is included. Commitment is to be committed to your team and all your team members. And joy of life is just to always have fun and love what you do on the team. And so while some teams may not directly write down their values, I'm sure that these apply to all teams and are important to them, are important within them. So developing core values is a meaningful way to develop insight into their teams and further their mission within FIRST.
So we were coming off a very rough season in 2016, and as a team, we used a team retreat in October 2017 to launch an in-depth discussions about our team culture, to determine the essence of the Green Machine, and to develop this into core values of the team. In the previous hour, Yoji presented about the core values process as a whole and its importance, but this is just a shortened version of the process, and we think it is necessary to cover it as it is an important part of our outreach events. So firstly, every member and mentor of the team brainstormed values that they believe represent the team and culture. Normally, you'll just take a long list of values and you just pick a few out, and each person picks a few and puts it in the group, a big pile. And secondly, the students will have the ability to discuss and vote for the select values that embody their team. So after putting them all into a group, then you just pick a few that shortens or makes a group smaller of all the values. And then thirdly, you pick the values, like the final ones, and you have a smaller group, which is what we did, that defines what they actually mean and write down what they mean to you and your team. And fourthly, we encourage you to abide by these values and identify different ways you can exercise them in your community. And although you may be on the team and you're going to outreach events, this does not mean that you can you only use the core values at your outreach events. This also means that you follow them while you're not with a team and while you're just doing your normal daily stuff so you represent your team well.
So a good portion of actually doing a STEM outreach event is knowing how to select outreach events that are both meaningful to your team and make a good use of your time. There's a lot of outreach events out there, and we'll touch on this more later in the presentation, but choosing the best outreach event for your team is a very important step because it basically, it's the main thing your team is going to be known for. Actions speak louder than words. I know it's a cliche statement, but with outreach, it really is true. Where you put your time and energy is going to speak loudly about your team. For us, it starts with our mission, our vision, and our core values. And we have rejected things because it hasn't fit in with some of those. A good example is an annual cleanup of a local park. We did that for several years, and eventually we actually stopped doing that and passed on the opportunity to do it in our team because it didn't fit in with our mission of making FIRST available for all, and it didn't necessarily fit into our core values either. And so you want to be very careful about where you put your time and making sure that it sticks in with your values as a team.
Another thing that is very significant when determining outreach events is a purpose. So a couple of main questions you want to ask yourself is first, what is the purpose? The purpose can vary from different things, like to spread STEM to kids who are unfamiliar with it or don't get access to it in school, or to show sponsors what you're doing with their money, and to show members of the community their finished robot and just show them an opportunity to see a robot up close. And also you have to look at who do you want to reach out to? So if you're wanting to reach out to kids, you can, that's like you'd like to do outreach that kind of helps to spread STEM and demonstrates it to these kids. Or if you're reaching out to companies, you might want to do a robot demo and reach out to, and so the purpose varies differently to who you want to reach out to. Next, what kind of impact you want to have? Again, it differs between what kind of outreach event you want to have. Like with outreach event showing STEM to little kids, you maybe would hope to inspire many to find and pursue their passion because they might not have access to STEM in school. Or within the companies, you want to show what you guys have done with their contributions. And this kind of ties into what kind of outreach event. So like with some activities that might might be pushed towards kids who don't have access to it in schools, a demo could just show general robotics and all this like our final build and what the sponsors' money have gone towards. And so kind of the purpose depends based on what kind of outreach event you choose to do.
All right. Who decides and where to start? What we have found that works well is that outreach events are decided by the team leads, the mentors, and democracy of the whole team. Personally, our team finds outreach events through support of local businesses, with connections with sponsors, and working with underrepresented populations, such as People Serving People, which is a transitional housing for families without homes. And we just always try to involve community with the program.
Next, you want to look at whether this event would be a good fit. So you would like to conduct a fit test, because not every opportunity that is offered, you will not say yes to every single opportunity. So first, you want to look at if this event will fit your team schedules. Often our robotics teams are very busy, so it might single out a outreach event just because you guys cannot make it. You want to look at if this will match your goals for an event. Is the outreach, who are you trying to appeal your event to? Are you trying to look towards kids, towards adults, towards companies? And so you can see where you want to go and see if this will match your goals. Next, what other outreach does this company / organization do? And so that relates to alignment with your goals of your team as well. So if the company does outreach in areas that you don't really support or doesn't align with your vision, then that could also be a great reason to say no, or a great reason to say yes as well. And also you have to consider what kind of activities would be needed at this event. If you're appealing to children, then they want activity and entertainment, like these STEM activities, or a close-up look at playing with your robot. And then adults, you kind of want to, it's best to bring brochures and information about your team. For example, I have our robotics, our green machine brochure with us. So you can tell this is when appealing to adults and businesses, that kind of helps. And then next, this kind of ties into what other outreach does the organization / company do. But would this fit your team's mission, vision, and core values? If the company or organization stands for something that you guys don't stand for in your mission or vision, then that's a great way to say no. And if it doesn't fit your vision, or if it does, that's also a great way to see if it would be a great fit.
All right, STEMtoberfest. So STEMtoberfest is in October, and it is time for outreach that focuses on bringing FIRST and STEM, particularly our introductory engineering and design and build skills to children who have limited access. These pictures specifically were 2 weeks of outreach for our team at a transitional housing place called People Serving People. That is for families who do not have homes. In the left picture, our teammate Kennedy is working with a kid playing Legos and games. On the right is actually me, and I'm playing Connect 4 with another kid who I was buddied up with. Along with playing games and playing Legos with the kids, we also helped them with any homework and learning that they had. Also, we did a modified Lego League for these kids to give them an opportunity to connect them to FIRST and to hopefully include them into the great world of robotics that there is. This fits with our mission and core values because we are making STEM available to all, as well as being inclusive to every kid who shows up and every kid who has a desire to be in robotics.
So another event that is a great opportunity for FIRST robotics teams are community gatherings. In our state, a great community gathering is the Minnesota State Fair. You might have something similar to this in your area. It's basically an event where a bunch of people get together, they have fried food, a lot of activities, events, and it's basically just a whole statewide kind of festival, right? What's interesting is that these activities, at least here, actually have a STEM area. So what we did last year was we actually participated in demoing our robot and a mini mock little game with the other robots, as well as showed off our robot and showed off what FIRST meant. These are really great opportunities to get back into your community and encourage more people to join FIRST and to support STEM. We often forget that STEM outreach, STEM lobbying doesn't just revolve around the people who are your representatives, who can write you a check. It's also the people who are directly in your community that are willing to support those representatives and those legislation, as well as just allow their kids to join the program. FIRST is a really tremendous opportunity for a lot of people. And oftentimes all that people want to do is get into it. And this is a great way to show what it's about, show parents what they can expect from it, as well as just get kids invested in the program and having a great experience like we've all had. So this is one of my favorite outreach events for that reason. And if you have similar events in your area, I would highly recommend trying to see if there's a place you can demo your robot. I know we even walk in the parade at the fair, so it's a really fun time. But it's also a great way to get back in your community and get more people interested in FIRST and STEM.
Sponsorship demos are also a great way to outreach to companies. So the first picture on the left is a picture of us, our Power Up robot, at a Seagate sponsorship, who is our Seagate demo, and they are one of our longtime sponsors. So sponsorship demos are a great way to show companies where their contributions are going, show them the finished project, a robot that has many skills and can interact with people. And so these demos don't always apply, or it can help, not only can it help build long-term relations, but it can also show if you're not yet acquainted with the companies, it can be a great way to acquaint and start building a relationship. And so the picture on the right is a picture at a Global Medtronic Women's Networking event. So this kind of relates back to the Good Fit slide. So because it was a women's networking event, we chose a team of all girls to come and show the robot and show our contributions that we had within the team. And so Medtronic has been a longtime sponsor, and we were able to show them where their money has been going and all the output that we have been able to do, and just have a general robot that can interact with the people.
So another event that's that we do that I might recommend to other teams to seek out is our area has a hospital that's in our state called the Children's Hospital. It's basically a hospital for children and teens. And so in this hospital, there's a studio called Star Studio, and it basically runs the TV show of the hospital. They have their own network, and it's just broadcasted internally, nothing outside the hospital, but it basically provides long-term care patients with something to watch, something to enjoy. And it's a really great thing for people who are in long-term care and usually don't experience the same things that they would normally experience because of that. So they often invite guests in. In this case, we were invited in. We did a bunch of STEM activities, and we also demoed our robot. And I think the best thing about this event in particular was that we got to see the impact of the robots and of STEM on these kids, because it was something they'd never seen before. And it seemed very surreal, but also just being able to put that big of a smile on a kid's face is amazing. And that's the big impact that our team loves this event, is because we're able to make a measurable impact in each of those kids' lives for that day. And even longer. I mean, remember one of our students actually built something on the show that was later used for therapy for a kid. So that was really amazing. And it's just things like that that let you, it's not all about the big picture. Sometimes you got to go back into the community and work with people on a smaller scale, because that makes a huge impact as well. First, one of our big mission values, our vision, is to make FIRST available for all. And even if we can't make it permanently available, we can at least bring it to that area and get them at least interested and expose them to it as much as possible. And I think that's what the best part of this event was that we were able to model inclusivity at that, and model do what our team says we're going to do, and basically follow our vision.
All right, open house. So every year we do an open house at our facilities and show around families, kids, and just adults who want to come. And we show them what we do as a robotics team and what FIRST is. And we hopefully get them into the program. So on the left side is our Murrah facility, which is a practice field we set up in an unused middle school. This was mainly organized by 2,500 Hero Robotics, but they were in coalition with 5 other teams, including us. And this day overall is just so much fun because we get to just show kids a robot and show us scrimmaging and just showing showing the kids the game that we do and how much fun it is and how much on a bigger scale than like FTC or FLL. And on the right is actually our own facility in our school, and we call it the lower shop because we have 2 shops. It's the same thing. We invite people in, we just have a great day and tell people what FIRST is, tell people about our team. And actually on the right-hand side of the picture, the female on the right side, her name is Melissa Franzen, and she's a state senator, and we love hanging out with her because she just represents our team so well. And the left guy, his name is, he is our Seagate sponsor, and he is very important to our team because Seagate is one of our longtime sponsors. Overall, both of these days are just amazing, and they really use our mission well because they connect to creating bold leaders who talk to people and tell the people about our team, and also making STEM available to all. So showing the kids that, and hopefully making them or wanting them to join in. And then it just models inclusivity as well, because we want to include everybody. We want everybody to join robotics who wants to.
Sam, can we actually go back to that slide again? I just want to add something to that.
Yeah.
Another huge thing here as well that I think the message that you should get out of this is that your space, your shop is something unique, and the areas you work are something unique as well. If you bring a little kid in there and show them your robot, show them how the robot moves, show them what it can do, that will do so much more than telling them, hey, I'm on a robotics team. Because they'll get to see that measurable impact, and their parents will be like, whoa, these kids are doing something. I thought a bunch of teens were just crazy, man. Like, we're doing something amazing, and I think that when you bring kids in, it's basically shows people that that the impact that it can have. So SwampFest, this is an outreach event unlike, I would say, any other. It's definitely unique. It's basically an event that our team does in coalition with 5172 and 7 other teams, where basically we go up to Greenbush, which is this area about 15 minutes away from Canada, still in Minnesota though, and we basically spend time and camp out there and basically make a decision, work with our teams to improve our team, all of our teams as a whole. I know in the past our team is not a great robot team. We're okay at outreach, right? But we're not a team that's known for robots. But 5172, on the other hand, is really great at robots. So when we go down there, we gain a lot and we learn about robots. And our teams, we talk about outreach. We talk about I know last year we talked about implicit bias and how we could solve that and work towards solving that and removing that and challenging that. But I think that there's a lot of stuff that gets gained from just teams meeting up. And so while this might not seem like an outreach event, this is a great way to hone your team's individual skills and basically work towards improving your own advocacy and outreach skills. Outreach isn't just a one-time fits all situation. You have to continually work towards improving your skills by giving presentations like this and also by just talking to people. And so when other teams and us are able to see what each other are doing, we're able to improve. And so I would definitely recommend that if you're not meeting up with other teams, that you try to do that and see what they're doing and talk to them. Because FIRST isn't just about competition, it's about collaboration and cooperation. So by working towards that with other teams, we can do that. Plus this event, it's really fun. You get to ride ATVs and stuff. So you can always incorporate some fun activities in there. And it's just a great time.
Another fun little thing, they like to ask questions that say like pancakes or waffles or what's a sandwich, or like is a hot dog a sandwich? And it's just really fun day and a fun time.
Okay, so this is me again. So another thing we do is the Rolling Acres Summer Camp. This is a camp for children with autism. And this is another event where we're able to bring FIRST to people who don't normally have a chance to access it. These are kids who generally higher in the autism spectrum. And oftentimes robots that are noisy and loud are difficult for people like that. Or with autism. So because it causes sensory issues. So what was really great about this opportunity was that we were able to bring robots into that space to show them, to see the smile on their faces when they were able to see how the robot worked and how it was able to function. And I really think that this is a great outreach event. If you have any places like this, camps, things like that in your area, it's a great opportunity to go out in your community and make an impact. A lot of what we talk about is making a measurable impact. And I think that these smaller outreach events definitely fit that bill. This is a really amazing outreach event, and I would highly recommend it to anyone who gets the opportunity to do something like this.
What's really significant in outreach events is preparing for them. So first, if you're bringing a robot, you want to have a robot setup guide. This is like how to turn on and off the robot or how to disable and enable it. You should have 1 or 2 people leading the events with understandings of other roles, so they can help if something goes wrong, or they can direct everyone around. So you'd also want to have a 1-page cheat sheet and or checklist. This is to make sure you have brought everything you need, and then you also cover all topics that you want to in all events at the demo or outreach events. You also want to have marketing materials, like I already showed you guys this, but again, here is the trifold. So this is very effective in helping to spread more information about your team and maybe little statistics and just what you guys have been doing over different periods. Like, for example, what we have been doing over the time of with COVID and how we adjusted to it. What is also very important is mentor coordination and logistics. So they can help plan the event, coordinate it, and kind of pick out times and everything like that. Transportation and carpools are also very significant because you need to be able to get to there and your robot and activities also. So, and finally, you want to have a basic what is FIRST elevator speech. This can be like, FIRST is the organization that runs our robotics competitions and establishes the different challenges and different levels of robotics. FIRST runs robot competitions from grade school or from elementary school to high school. And the robots can range from sizes of these big FRC robots to little FRC, FTC, and FLL robots that are easier for the younger kids to build.
All right, thank you very much for this opportunity for us to talk. And now we have some time for questions.
Okay, so I have a few questions from the chat that have come through. So first question is, does your outreach lead to higher recruitment numbers?
Yes, I'd like to say yes. It gives us the opportunity to spread it more, and we do have this thing we like to call like an FTC loop, I guess, where we bring FTC members to some of our outreach, and it gets them interested in FRC as well. And so it just brings like more people into robotics and more people to our team. And so, yes, we all would like to say that it does bring more people to our team and more people to robotics and FIRST in general.
And I'd like to add to that, we have something called a club fair at our school. And so I'm not sure if we did this year, but last year we had a robotics stand, and we can talk to many kids through the high school and kind of introduce them to FTC too, or FRC and all the robotics levels. So I would definitely say that our outreach helps our levels of amount of team members.
And it's not just about our team either, I would say. A lot of what we're trying to do is just increase the presence of FIRST and STEM activities, even beyond robotics. If we can get kids interested in STEM and FIRST, that's a major plus for us. And I think that whether it directly or which it does, but also even if it indirectly affects us or some other team, that's a great thing as well.
Yeah, cool, thank you. Another question, do you have an example of when your outreach may have gone wrong, and what did you do to fix this?
Ian, do you know any? I think most of the time we just plan it out so well, and it's like mentors are helping with us, and like everybody's just so ready, and we have transportation aligned. We use Slack to communicate, that most of the time it doesn't fail, which sounds kind of hard to believe, but.
And also, that's part of kind of preparing for your event, where you have you want to have like 1 or 2 people leading the event with understanding of each other's roles. And so with those 2 people, or with like the main people leading it, they can always help if something goes wrong and make sure kind of bring order back.
Events don't, I will say, there have been a few times events have gone out of our control and that they've turned out unexpectedly. I don't see outreach events as going wrong that often because the outcome is just making our presence of FIRST available and increasing the presence of STEM, right? So we've had events. An example of this is last time we had a Murrah open house. Not that many people showed up that we were expecting, but at the same time, we got to make a greater impact on the people who did show up and work more closely with those people. So I wouldn't say that they go wrong a lot. I would just say sometimes they don't turn out how we think they're going to turn out. I think that's true with any event that a team goes to, or just in life in general.
Yeah, I agree. That's a really good answer. Thank you. Another question. How have you modified your outreach programs to account for COVID-19?
So currently we just did like live talkings and presentations like this. We're planning on going to, so like we talked about earlier with the let me just go back to the slide quick. The Children's Hospital. We're still talking with this guy and hopefully trying to get this organized again to do it this year. But with COVID, we're just figuring it out, trying to make sure like we can even get in the hospital and like if it's safe. But right now, I guess we're just doing presentations and like sharing what our team does and spreading how, like just helping other people if they need it.
Mm-hmm. And so, yeah, so our last presentation, it was on, it was with 2468 Appreciate. And so we kind of presented a presentation a lot like this, as Sam said. And also because a lot of things have been closed down, we were kind of thinking of how we could maybe adjust outreach to be virtual. And it's kind of a process, as, I mean, everyone's still a bit new to this.
Yeah, of course, yeah. It is difficult to do, but it's just really helpful to be able to complete outreach during this time and can connect people with STEM across the world. I'm pretty sure that's all the questions we've had so far. Is there anything else you guys wanted to talk about?
We covered everything that we have so far.
Okay. Yeah, so thank you guys for doing your presentation. It was very interesting. And it was really cool to learn about how you have done your outreach and how you've become as successful as you are.
Thank you so much for giving us the space to talk about this. It's been really fun, and we hope you guys, honestly, we hope you guys are able to really, I would like it if every FIRST team was a chairman's team, and STEM outreach is a major part of that. And I just think that I hope you guys learned something, and I hope we weren't a waste of your time.
And good luck with the next presentations as well.
Thank you.
All right.
In a classroom, my name is Bill Church, your host. Behind the camera is Pete Rogers.
Hello.
Pete, in our previous videos, we put some holes in cardboard. All right, so we did the holes in the cardboard for our big labels. We did the holes in the plywood for our coding station. In this video, we're gonna put holes in 3D printed objects, and we'll show you how through Tinkercad. So we have a Tinkercad window open. We recommend using Tinkercad for this activity. It's free, it's online, and it has a feature where you can turn anything into a hole, and you'll see that we need that feature. So I'm going to import the Lego hole pattern in from a file we found on Thingiverse, and that link is shown in the description below, or is available in the description below. Let me import that in, and it'll take a moment because it's actually quite a large file. There we go. So I've got the beam imported, and I want to put that hole pattern as if I just stuck this Lego into the computer screen. Now I want that hole pattern into any shape I can dream up. So first let's bring a box over this, and let me make that into a hole. And I'm going to take this here, and I did memorize 2 key dimensions. So the height of the Lego beam is 7.5, and the width of the Lego beam is 7.8 millimeters. And let me just get that nice and centered here. Center, good, select them all. Now I'm going to join them together, and I'm almost there. So let's zoom in on this. When I first wanted to try this idea, I thought that this is all I was going to have to do. It's going to be awesome. And interestingly, we're not quite there. So let's do that whole operation just one more time. If I click on that, I make that a hole. Now I've got something that I can use, and this time, heck, let's be a little more creative, Pete. Let's bring out a cylinder. What's wrong with cylinders? Nothing at all. So grab that, and there, my magic number that I memorized from before was 7.5. I think so. Look at it. All right, now I'm going to combine both of those together and make group them. And here we've got a cool little shape. It almost looks like the Death Star from Star Wars. We actually didn't print that out because we didn't need that in a project. What we did need in a project that Pete, you and I came up with, which was pretty fun, was what if we could add our iPhone to a Lego motor and make a slow panning time-lapse setup. Fun idea, and I think we pulled it off. It was pretty quick. So we took the iPhone camera holder that we got from Thingiverse. We added the holes just like we did to this cylinder Death Star thing. And we now have the Lego pegs, so I can now add my iPhone camera right into the Lego beam and put that into this setup here. And with my nice gear, small to big, I get a nice slow turning. And check out this video we made earlier of our slow turn time-lapse panning extravaganza. In this episode of 5-Minute Classroom, we explored some next level Lego plus 3D printing where we embedded holes, a hole pattern, into the bottom of a shape. That is some next level CAD. And with an example like this, you can take your CAD lessons and go in many different directions. This was also an opportunity to explore real world design challenges. We challenged ourselves to make the iPhone holder and create the slow pan time-lapse camera setup. You could do many other projects where the students, driven by their personal interests, so student personal interest, can seek out and search many other different types of objects to be 3D printed that they want to adapt to their Lego system to take even further. Thanks for watching 5-Minute Classroom. Look forward to seeing you next time. Welcome to 5 Minute Classroom. I'm Bill Church, your host. Behind the camera is Pete Rogers.
Hello.
All right, Pete. What color do you like that goes with yellow?
Gotta pick blue.
All right, so pick blue. The project we're gonna do today, Pete, is a spin art project with a Lego motor, the construction paper, your color blue, and cardboard. The stuff we're gonna need for this project, so the paper, the cardboard, a Lego axle, gear, some black pegs here, and then, although not essential, but always fun to use, the brass fasteners. Well, we have the Lego gear already attached to the cardboard. If you need a little more detail on how we did that, go check out our video about attaching Lego to cardboard. Okay, so we've got our canvas. Let me put my axle here, and I'm gonna put it into the motor here. We're gonna use our trick of one motor connected to another motor to do that, but I've got to attach my beautiful piece of yellow construction paper, and that's where the brass fasteners come in. You could use tape, you could use glue, other things, but we're gonna use the brass fasteners because it's fun. And we're gonna poke this through. Boy, this is the toughest cardboard I've ever used, Pete. Okay, one there, and they just look cool, so that's always fun. We've got our canvas here. Are you ready to do some art?
I'm ready.
Okay, Pete, I need your help.
Now I get to effortlessly
Zoom in.
slide into camera.
All right, excellent. Go ahead and turn that motor. This motor is the generator for this motor. Really cool. Now let's use that for our spin art extravaganza.
All right.
Okay, you ready? Go
Ready.
ahead. Go ahead. And voila. Super cool spiral.
Super cool spiral.
But we've got other colors here. What's our next color, Pete?
Red.
Okay, take out some red. Should we add a splash of red?
A drip.
A drip of red. Okay, ready?
Yes.
Go ahead. 1 drip, 2 drips, 3 drips, 4 drips, 5 drips, 6 drips, 7 drips. Okay, we got some drips of red. What's our next color?
Green.
Okay. So, Pete, I did the spiral by coming in. I did the drips by poking up and down. What should I do next?
Let's do squiggly lines.
All right. So, squiggly lines. Right, go ahead.
There you go.
So we got some squiggles out there. Squiggle, 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 squiggle. And, oh, voila, that is beautiful.
It is a true work of art.
Okay.
Yes!
Yes. Good. So we've got the spin art here. There's more we can do with this idea. Let's go to the whiteboard and talk through a few other next steps. In this episode of 5 Minute Classroom, we did a super cool spin art project. Where can we go next with this? Because we're connected to the Lego brick, the Lego brains, we can immediately turn this into a coding project and challenge our students to write the program to move the motor at different speeds or with different patterns and see what the resulting effect is in your artwork. Making this deck spin faster, also really fun and cool to do. So how we do that with gears is a neat challenge for our students. We ask them, can you gear this up to move at a faster speed? And again, what's the resulting artwork that we can create with that? Finally, this is a neat science platform. If you made this deck out of a sturdier material, and if you reference the video we created on how to add Lego to a thin wooden plywood, perhaps that's the ticket. But now we've got a rotating science platform for exploring the science of rotation. Best thing at the end is that the students can take away their own artwork and bring it home for their refrigerator. Thanks for watching 5 Minute Classroom. Look forward to seeing you next time.
What you see before you are the mountains of West Virginia. Beautiful and truly astounding when seen from here. But what would you see if you looked closer? This is Morgantown, in north central West Virginia, the home of Mountaineer Area Robotics. Each year on the WVU campus, Mars designs and constructs a robot named Marvin. But building a robot is only a single step towards our goal, to foster change in our home, West Virginia. This mission, to inspire students in rural areas to pursue their creative and intellectual passions through programs like FIRST Robotics, seemed impossible just 10 years ago, but now we have a solution. We call this solution the Mars Plan. The first step in this plan is engaging communities around us through visibility. Using this engagement as a springboard, we inspire the creation of robotics programs utilizing experience and financial support gained by Mars over the past decade. We then focus on team sustainability by working closely with coaches and students, mentoring and supporting area teams. In addition to our assistance prior to competition, we ensure events are well run by volunteering as referees, event coordinators, and judges. This support keeps teams coming back, and in the past 10 years, we have more than quadrupled the number of FLL teams within West Virginia. This inherent sustainability and coordination inspires students to continue to participate in higher-level robotics programs. To support this transfer of students, we are now expanding West Virginia's FTC, VEX Robotics, and FRC programs through efforts such as running the FTC State Championship and our FRC off-season event, West Virginia Robotics Extreme, the world's only 26-hour robotics endurance event. Mars expects to see tremendous growth within these programs in the coming years, mirroring our efforts with FLL, which we continue to expand. Mars is now working with the West Virginia School for the Deaf and Blind, West Virginia institutional programs, and within county school curriculum to grow the reach of the statewide robotics program to as many students as possible. Outside of our state, Mars also runs programs such as the Mars Tucker Team Help Desk, a program that allows other FRC teams to receive assistance in mechanical, electrical, and software areas, inside and outside of competitive spaces. Mars is now expanding this program to a national level, training other teams to run their own help desks across the country. For 10 years, Mars has strived to become a driving force for STEM education in West Virginia. The Mars Plan is working, the state of West Virginia is changing, and we will never let it stop. We are part of a revolution. We are Mars.
So when I was a kid, when I was like 9 before we really started, I was selected mute, which is like, I was really, really shy. I didn't really want to talk to people. gave me a lot of anxiety. Whereas through the first program, I've had the opportunity to talk to judges and talk to adults. It's something I really like to do. We're up in Homebush for the first robotics competition for the South Pacific Regional.
In FIRST Robotics, you are given a set challenge at the beginning of a 6-week build season, and you build your robot for 6 weeks when you bag it up and send it away, and then you go and compete with multiple other teams from all over the world trying to get a spot in Houston.
We are Complete Chaos Inc. and we're from Helensburgh, which is about an hour and a half south of Sydney. Helensburgh is like an old school mining town, and it's really into like sports and like the coal mines and stuff. And for us, like as Complete Chaos, it's a really cool thing that we have like this opportunity to share robotics and this inspiration and passion for robotics with all these young kids from a typically mining town. Our club, Complete Chaos, formed in 2011 as like a hobby club. The kids grew older and stuff. We added on first Lego League, and that was a really cool challenge for us. We really enjoyed it. I was 9 years old when we started that, so little kid. And we went all over. We went to Spain and America for that. It was really fun. And then obviously as the students from that group grew older, we also added on top FRC, which is the higher level robots that we're doing here at this competition today. So when you walk down onto the stage and you're getting ready to play, it's crazy. Like there's so much excitement, there's so much going on. The people cheering, and then there's like people dancing, and there's horns and chants. And when you actually get onto the field and you've got everything set up and you're just waiting, it's really crazy. Like you feel so anxious, but like also really excited. It's a really cool feeling. It's like a sports game. You know, you've planned it out, you're ready. Like it's really exciting because anything could happen during those matches. So you got every single match, like no matter how good you think you are or how, you know, ready you feel, you've got that like tension, that excitement, because you never know what's going to happen.
6, 5, 7, 9, oh yeah!
So we're currently in the qualification stages, and eventually we'll go into alliance selections. So we need to be ranked 8th to get in to be an alliance captain, but we can be any rank to be picked.
Pretty much what we want you to do is just get rid of the one that you get from starting, and then go defend, and then get back to that 30 seconds climb.
Yeah. They're not going to climb. You have to climb. Unlucky. Oh well, what can we do? We must have got heaps of fouls.
So we haven't made the top 8 in this competition due to some uncontrollable factors. So now we're trying to shop around for teams that'll take us in for the playoffs. We're just wondering if there's something you want us to do for the next match as well.
Because last game you guys lost a lot of points.
Yeah, the other team.
Yeah, because I think there are two teams over there, right?
Oh no, the other team, their radio fell out, and so they were out of their frame perimeter. That's what the referee told us. So basically the way it works is the teams 1 to 8 can pick their 2 teams that they want to play with. And so we're talking to all the top teams to try and make sure that we get picked. So that's talking about what do they want to see from us, what do they want us to try and do to make sure that we are the best robot that we can be for them. So we'll try and make sure that no one else gets in our way this time, and we'll defend for half the match.
Yeah, and I also say that you guys do the hatch and the balls.
Yeah, so we can do hatches, balls, we can do everything but climb kind of thing. So we'll make sure to play heaps of defense for you, and hopefully it pays off.
Okay, awesome. We'll definitely have a look, and good luck.
For sure, thank you.
I think like being in like first has done some really awesome things. There's so many. So we started with, it gives you more context for what you're doing in school. So like when you're sitting in a class and you're learning maths and you're like, oh, this is so boring. Whereas like when you actually have something to apply it to, something that's cool and something that you really enjoy, it makes you actually want to learn more, and it makes you more engaged in your classwork. So I think that's been something really cool for our students, is it gives you like, you know, a goal and something to actually put into practice. And then also it's learning real like tech stuff. It's, you know, we're working with engineers and we're working with like real people who are in the industry, and we're learning so much from them every day.
Best robot in Australia, there it is. Wow.
So like for us, we were so inspired by all of the people who we would meet at the competitions. And now we go back and we volunteer at multiple competitions, and like we do everything. So we're refereeing, we're judging, we're emceeing, we're, you know, leading all the dances and playing with all the little kids and getting them inspired about the like FIRST and robotics and all of this stuff. It's really, really cool.
So irrelevant of whether we win or lose, it's still been a great season. We've learned so much, we've met so many people, and the FIRST robotics experience is just totally worth it, no matter whether you make it to Houston or not.
Team 7433. There's a lot of cells on the spreadsheet.
There are a lot of cells.
What are they telling you?
They're telling me that we're going to be complete chaos.
Happily and graciously accept.
You attack the right side, we'll attack the left side, and we'll swap.
Yep.
And this is all 3D printed?
This 3D printed, this is not a high stress area, so the high stress areas like spacers, I don't see why not.
We're doing a hatch, Iona's doing a hatch, and they're doing a ball.
65, 79. Ball, 33.
Yep, we're good. All right, let's go. We got this.
Won one game, the red side has won one game, and so now we're going to see who goes on to the finals.
And what would it mean to you if you guys won this one?
It means we're going to the finals, which would be insane. Like it's really, really tense, scary.
You just keep going balls, Jaya, keep going balls, you've got it all day long. 449, you're coming for 5, 449. That's the way. Got it, you got it. Another ball, one more. 30 seconds, guys, 30 seconds. Well done, well done. Okay. Yes! 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 You're the legend. Yes! Nice work. Nice work, Ollie. Thank you. Beautiful defense. Oh, man. That 38-81 killed it. So we've been playing really well these last few matches. We're going into the finals really positive. We've got a really strong strategy, amazing defense bot, and two that are really good at scoring points. We're just going to hold on, see what we can do. Finals, here we go. I know, it's crazy. Good luck, good luck, good luck, good luck, good luck, good luck, good luck. Love it, okay. So we're going hatches, they're going balls, and they are going defense. Let's go. You guys have got this. Let's do it. 6, 3, and 6? Yep. That's the way, Jaya, that's the way. Go balls in there. Go balls. That's it, Jaya, well done. Come here, and we're going front cargo ship.
63, 68, Hongzhou in red, one quality. We've got 27 to go.
That's it, defense. Come back. Go, now. Ball. You're winning, you're doing good. Drop it, no. Oh my God. It's going to be close no matter what happens. So they got 9 more points at the end of the game.
It's all good, bring it in.
What can you do?
Hey, it's all good. Sorry about it, bring it in.
Okay. We had a really strong alliance. We just couldn't pull it together at the end. So we had a good strategy. We did everything we could, but right at the end, one of our robots tipped over, and you can never predict what's going to happen. It doesn't look like we're going to be making it to the US this year. We've had a really good season. We did all that we possibly could, but in the end, it just didn't quite work out. If we don't get a qualifying award or a wild card, that'll be the end of our season.
We lost the finals and we're super gutted because, so much goes into the strategy and, working with your alliance, and there's always random factors that will come in, like the other team's defense and, a robot broke down, the client didn't work. So, we played the game as well as we could have and we're super proud of how we did, but yeah, pretty gutted about the finals.
This team has designed their machine to play and win the game, even if half of it were to be blown off. Guided by a $10 cat toy laser, we are proud to announce the winner of the Excellent in Engineering Award to team number 6579!
We can't believe it, we've just won the wild card and we're going through to the US. All of our hard work has finally paid off over the 6-week build season and the last week competition. We're finally going to Houston and we're going to compete with teams from all over the world now.
I'm so stoked. I'm really, really excited to go to Houston with our whole team and participate there in front of
It is my pleasure to introduce our next speaker who will be talking to us about why to invest in STEM and FIRST Outreach. So please join me in welcoming, wait, sorry. Oh my god, I said that wrong.
That's
I'm so sorry.
okay.
I'm so sorry.
That's okay. I can talk about STEM outreach too if we need to.
I'll try again. It is my pleasure to introduce our next speaker who will be talking about effective FIRST strategies. So please join me in welcoming Karthik from FRC Team 1114 Symbiotics.
Thank you. Hey, everyone. Thanks for having me here. I'm so excited to be part of 24 Hours of STEM. Thanks to all the teams who put this together. Really pumped to be here. It's a little bit late for me. It's midnight. It's a Saturday morning here. So we're doing like the after dark edition. This is the short version of effective FIRST strategies. This is a presentation I've given a lot. I've given it at First Championship. It started off at the University of Waterloo. It's been everywhere. It's been going for 15 years. It turned into internationally recognized TED Talk. And so we're gonna get the short version of it. We're gonna go through it. So let's just jump right in as this is like the most nerve-wracking part, sharing your screen. Let's see if this works. Yes, maybe. Hopefully you're seeing my screen right now. Welcome, Effective FIRST Strategies.
It's working.
It's working. That's what I like to hear. Thank you. Thanks so much. All right. So I've kind of talked a little bit about what this presentation is, and let's talk a little bit. This is the boring part. That's me. That's not really like super relevant. Sure. I've been doing FIRST for a long time, and in that time, give me 1 second here. Sorry, I'm just fiddling with my slides here. And try that again. There we go. Sorry about that, everyone. Just a little bit of a technical glitch. I've been doing FIRST for a long time. I was the lead mentor from Team 1114 from back when I was in university at the University of Waterloo in 2004, all the way till 2016. Now I'm just kind of an advisor, a backseat driver more so than anything. We've had a lot of success in our time, partially because of the strategies that I'll be talking about in brief today. And we've also had a lot of success off the field winning the Chairman's Award. We won 51 blue banners, and we're going to catch up to the Cheesy Poops one day. Probably not, actually, because they just keep gaining on us every year. Other cool things I've done, I've given a TED Talk that I've talked about here. It's this whole presentation turned into that TED Talk, which was really, really cool, because this was all designed for FIRST. And it kind of shows that the lessons that we learn in FIRST and in FRC are so applicable in so many other ways. And the fact that that TED Talk became so recognized was just like, I was really just talking about FIRST. So that's kind of cool. And I've done a lot of hosting. I've done TV for ESPN and CBS, hosting robotics specials back with Vex. And I used to work for Vex. I used to be in charge of designing all their games. So all the VRC and Vex IQ games had my stamp on it. And that's kind of a result of how much I love strategy when it comes to robotics competitions, because as a competitor, I was so interested in breaking games down. And then as a game designer, you're doing the opposite. You're designing a game with lots of avenues to be broken down. So that's kind of interesting. Before we dive really into this, to everyone who's watching out there on YouTube, if you have any questions, drop them into chat. It doesn't matter what the questions are about. The questions could be about this presentation. The questions could be about FRC in general. The questions could be about old 1114 robots. The questions could be about the NBA season restarting. If you want to talk about the coronavirus, we can do that. If we want to talk about the current state of politics, we can do that. We can do anything, you know, if you want to talk about fashion. These are all things I'm really interested in. So, you know, there's going to be a lot of time for questions, and hopefully, you know, this will be like it is a championship where there's just like too many questions, I can't even handle them. So we'll see where we go, but it's time to get to the good stuff. This presentation is all going to be centered on a bunch of quotes. And the reason I centered it around these quotes, because I think they're really important. I think we can learn a lot from them, especially in an FRC context. But beyond that, I mean, like, realistically, this presentation is being watched by a lot of young people who are making really important decisions right now in what to do with their lives and where they want to go to school and what they want to do when they're in school, or how they want to finish off high school. And this all applies. This all is a part of it. So enthusiasm is one of the most powerful engines of success. When you do a thing, do it with all your might. Put your whole soul into it. Stamp it with your own personality. Be active, be energetic, be enthusiastic and faithful, and you will accomplish your object. Nothing great was ever achieved without enthusiasm. I start almost every presentation I give with this. I do a lot of public speaking and motivational speaking, and I do a lot of corporate engagements trying to, you know, pump up sales teams and that stuff. I always start with this quote. Why is this quote so important? I don't know why I'm asking questions. I can't see you. You know, I can't interact with you right now. I don't even see the chat. But anyways, why is this so important? It's because what we do in life, we're so much better at it if we love it and if we are enthusiastic and we're energetic about what we're doing. And when you think about that in the first context, people often ask, why is this team always so good? What's their secret sauce? What's their secret sauce? Like, what's their energy? Like, why are they so good? And there's a lot of factors. And like, you know, some of them are like, yeah, they got, you know, I'll be blunt, I'll be honest, like they have a lot of money or they have some really great mentors. Like that's some of it. But the biggest answer I have for you for why the best teams are consistently the best is it's their team culture. And what about their team culture? Well, there's a lot of things, but one thing is they love they love building a robot. And because of that, they put so much focus into it, because when you truly love something, you'll put more time into it. So when you think about school and what we do in school, you know, you ever notice that you kind of do better in the classes that you like? And some people think it's like you like them because you do well. And that is some of it. But the flip side is you do well because you like them, because you're willing to put in the extra time, because studying doesn't actually feel like study. It doesn't feel like a chore because you're enjoying what you're doing. And why does this matter for our lives? Well, I'm telling you right now, there are a lot of paths you can take when you finish high school. And there's a lot of paths you can take when you finish university. And there's a lot of people directing you in various directions. And so often the comment is, it's like, you need to study something where you know you'll get a job, or you need to study something, you need to go into engineering because you'll make lots of money. And that's a cool, noble idea. But here's the deal. The engineers who make lots of money, like a lot of money, like they're the ones who love engineering and love what they're doing. If you don't love what you're doing, let's take an example. Let's take like two people, you know, someone who just like absolutely loves, you know, mechanical engineering, and someone who went into mechanical engineering because their parents told them they should, or like, you know, it was the right thing to do. And so the person who loves mechanical engineering, when they're in university, they're going to spend their spare time and they're going to join like the mini Baja team in school, or they're going to join other like various clubs. They're going to be tinkering on their own design projects on the side. They're caddying up swerve drives. They're doing all sorts of stuff. The person who doesn't love mechanical engineering is just going to go through the motions, you know. And they're going to go to class. And like, I'm not saying they're going to slack off or anything. They're going to go to class, they're going to study, and they're going to work hard to get their grades because it's what they're supposed to do. But they're not going to work beyond that. And so then when, you know, the recruiter comes to campus and when they're doing interviews for jobs, the person who just kind of like is about mechanical engineering, they're going to be like, so like, what else? Like, tell me why you think you'd be a good fit at this company. And they're going to give like very generic answers. Well, the person who's really into it and really loves it is going to be talking about, oh, well, you know, I saw some technology that you were working on, and I was working on something really similar in my backyard, and blah. And so it builds that link. When you get to the job world, when you get to the work world, the person who loves their job, loves mechanical engineering, is passionate about it, is enthusiastic about it, at 5 o'clock, they might stay and work a little bit longer. Or on the weekend, they might start reading up on extra things. Well, the person who's just like, it's just a job, guess what? They're 5 o'clock on Friday, they're gone. They're going to go do their own thing. They're going to go pursue their own passions. They might go play the guitar, or they might go, you know, and take a progressive hip hop dance class. That's what they're doing with their spare time, which is cool too. They're pursuing their passion. Except the person who's turned their passion into their career is going to get further ahead. And when they're evaluating promotions or who's going to get raises, it's going to be the one who's more passionate about. So like, this is like really important advice for all of you people out there right now. Follow your passion. Don't be a slave to, oh, I just want to go where the money is. Because the money, you know where the money is? The money is where your passion is. Now you might be saying, I have no idea what I'm passionate about, Karthik. And that's totally okay. Most people don't know what they're passionate about. Why I really recommend trying lots of different things. When you're on a first team, don't just stick to one area. There's so much about this program. Do different things. When you get to university, you might want to mentor a first team, or you might want to try another program out there. There's like all sorts of things to do. But I really recommend trying a bunch of different things to figure out where your passions are. Read different books, follow different authors, follow different people on Twitter, follow different people on Instagram, learn, see what's out there. Go to the library, do stuff, you know, meet people, talk, chat it all up. But this quote is what leads to success. And you really can't forget it. And be very, very wary of people who are trying to push you down a road, because remember, it's your life, you're living it. And our weeks, there's only 168 hours, and you're going to work for like 40, 44 of those hours. That is way too much time to do something you're not passionate about. So, you know, I'm just saying, this is important stuff. When it comes to FRC, you know, the teams that do well are the ones that build this sort of passion. And it's about creating a culture where first is fun, and we're building a robot. It's an exciting thing, and you're looking forward to doing it. And so that's going to tie into a lot of this stuff. But I'm going to jump to the next slide, see where we're at. All right, this is an important one for FRC. Like this one, it's really interesting because when I gave the TED Talk, this was like a very big piece, and lots of people were interested in it. And this was solely based on my time in FRC. And the quote is from the former chairman of FIRST, John Abele. He was also the founder of Boston Scientific, and he runs the Cambridge Institute, which is north of Toronto, which is this great place where you learn all sorts of cool stuff. But it's for businesses to come and network and do interesting things. But he was giving a talk one time to a bunch of corporate executives. No first people. I happened to be there with 1114 because we were running a demonstration there. But this was a talk to a bunch of corporate executives who were there for corporate training. There are two ways to compete in this world. You can drag your opponent down, or you can rise above them. Which is better for society in the long run? I'm pausing right now because I may sneeze at any second, and that's going to be really uncomfortable for everyone here. So like that's why I got this weird look on my face, and it's going to come out, and it's going to distract me until I actually sneeze. You know, it's weird. This quote, what does this mean? I mean, it should be pretty clear, like what the surface meaning is. When you're competing, you know, like if you're running a race, you can run a race where you try and outrun your opponent. Or as you catch up to them, you can grab them by the shirt and grab her, pull her down, and try and beat her. Like that's like the basic way of doing it. Like people think that's a little bit crass, but you know, what's better for our society in the long run? But like, here's the deal. Let's be honest right now. World's kind of a mess. I say this in all these presentations, but it's 2020 and like, you know, it's bad. And like, let's think of one thing that's really, really important right now. We need a vaccine for the coronavirus. We need one. Our society is puttered to a basic stop right now, and we are not going to be able to fully restart until we have a vaccine for the coronavirus, period. So whoever develops the vaccine for the coronavirus, they're going to make a lot of money. You know, that's huge. You're going to need possibly, 8 billion or 16 billion doses of this thing. That's just insanity. However, if all the companies who are working on developing a vaccine are all fighting each other, that's counterproductive for our society. We need this vaccine as soon as possible. We need these companies to be sharing information, public trials, put everything out there so people can learn from each other and figure things out and improve what they're working on. We need multiple people coordinating. Imagine if there was like 15 companies who were all working on the same path to try and find this vaccine. Well, that's no good. We need people, we need different paths. We need coordination. We need communication. We need people to try and rise above each other. Yes, you know, it's still a competition. Obviously, each company is going to want to come up with it. That's fine. You can compete, but you have to compete the right way by trying to rise above. This is what I like to term as ethical competition. Ethical competition is the process of competing where you look around and you see what your opponents are doing, you learn from them, you are inspired by them, and you try and outdo them. Traditional competition, and this is, you know, competition has become a dirty word in a lot of places. People are trying to remove it in schools. People are trying to remove it from robotics competitions, you know, and like people say, oh, competition's bad, competition's bad, competition's bad. I'm here to tell you competition is not bad. The old model of competition has problems, but ethical competition is actually really good and something we all need to do because life is a competition. You are all competing right now to try and get into the top universities. The job market, oh my goodness, the job market's a mess. But if you want to work at these big companies, if you want to work at Google, or if you want to work at the coolest startup that's got all the best tech stuff, that's the competition. And when you get out into the real world and you're working, you're constantly good. Your company's going to be competing for funding. You're going to be competing for sales. Like that's competition. But I'm here to tell you that the old model of competition doesn't have to be the way. Look at all the things that the world's facing. Climate change. How are we going to solve things like that? We're not doing it the old way. Like when we have these companies, you know, these smartphone companies all fighting each other, all snipping and lawsuit here, lawsuit there, hiding stuff, stealing stuff, like corporate espionage. That's useless to us. That's not the way it's going to be. Like ethical competition matters. And this applies in our individual lives too. And I always talk about this example, but like, you know, I was in high school once, a long time ago, but whatever. Remember when you're in school and remember like there was like that one girl who had the highest marks in school, just the highest marks. And like, how did people treat her? For the most part, like it's always like, it's like, oh, well, I bet the only reason she has high marks is because she has no friends and she doesn't study. It's like, she doesn't even have a boyfriend. Like she's a loser. Or like, you know, like that guy who's like the quarterback of the football team, you know, it's like, oh, well, yeah, he's the quarterback of the football team. He's probably on steroids, you know, or like the only reason people like him is because like he's big. He's probably a moron. Maybe he's not a moron. Well, I don't know. Like, what do you know about these people? But it's so easy when we hear about other people's successes to try and find reasons to drag them down. We make excuses. We try and justify. It's like, oh, the only reason they're successful is I could have done that, but you know, like I could have done that if I had, you know, like, oh, they must be cheating or whatever. And like the thing is, that's a useless attitude because number one, you're probably wrong. You're making assumptions about someone you don't even know. That's just mean. That's not what we need to be doing. You should never be making assumptions about people. Give people the benefit of the doubt until they don't, at least until a point where they don't earn that anymore. But also, even if it is true, what does it do for you? Nothing. Don't make excuses for yourself. The best thing to do is to go up to this girl and just be like, hey, like you are killing it. You're awesome. Like you're getting like a 99 in calculus. Can you, like, what are your secrets? Like, what are you doing? You know, and like, can you help me out a little bit? And you're going to find out that people are willing to help you out, and people are willing to share, and people are willing to learn because they want to be, it's, what do you think the 24 hours of STEM is? This is people presenting their knowledge and their experience so others can learn from it. And this stuff matters. Why does this apply to FRC? I hope you figured it out by this, but because this happens all the time in FRC. You go to a competition and there is just a team who is just killing it. Let's call them the Beezy Boofs, okay? The Beezy Boofs, and people be like, oh, well, the only reason they're doing so well, their mentors built the robot. They have so much money, that's why. And it's like, okay, is that true? I mean, maybe, maybe not. But what do you get out of being a jerk? Nothing. First of all, go talk to them. And first, just if you're wondering why a team is good, go talk to them, because guess what? They'll tell you. Oh, teams love to talk about themselves. It's good though. You want to learn from people. Go learn, but also don't drag them down. It's useless to anyone. All the best teams in first at one point were not the best teams in first. And all the mentors who are, who were on top teams, so many of them used to be on bad teams. When I started in first, I was on a team and we were terrible our first year. And I went to championship, and I remember it was 1998, and half my teammates, we got down there. This was our first ever event. This was at Epcot Center. They saw Chief Delphi and Beatty and Wildstein, 47, 71, 111, who were the 254 of that era. And half of them were just like, oh, well, look at them. They just only have mentors working on the robot. That's gross. If we had mentors doing that, we'd destroy them. Well, the other half of the team was just like, man, they're so cool. How do we learn? And that's what I did. I just went and talked to people to learn. And I just remember at that point being like, one day I want to be on a team that's that good. I want people to look at our team as that model and want to come learn from us. And that's the model I took to 1114. And that was our whole thing, where we decided, we picked two teams in specific. We picked Team 67, the hot team, because they were a fellow GM team who helped start 1114 indirectly. And we picked Team 254, the Cheesy Poops, because in our the first year I was with 1114, they just had just this amazing whole platform going on. And we were like, these are the teams that we want to emulate, and we want to figure out how to be as good as them, and we want to figure out how to beat them. It's not about just looking up to them from afar. We wanted to beat them, but it wasn't about dragging them down. It wasn't about oh man, they're doing things the wrong way. It's they must be doing something right, and I want to learn from that. And so I just urge all of you to compete ethically in whatever you're doing. And this is important because I think a lot of people get this in first. And I think a lot of first team, we see every year, there's new powerhouses popping up out of nowhere. And they're not popping up out of nowhere because most of them have alumni from other teams who've been around and been through the program a lot, or they've learned and they've looked and they've learned. And so we're seeing good stuff in first. As much as our community can be toxic and negative at times, especially on certain websites or whatever, for the most part, we got a pretty enriched community. And you go into the business world and it's I mean, I've spoken to people who've flat out said that the ideals of gracious professionalism are incompatible with capitalist markets. I've been told specifically, me, that I'm too soft. I was never going to be a winner professionally because I believed in gracious professionalism, competing ethically, because I wasn't willing to lie and cheat and do the dirty things that some companies do. And I took the criticism, and there was a phase in my life where I kind of was like, okay, I guess I have to be more cutthroat. I have to be more cunning, but, and I just kind of thought back to conversations I had with Woody and all this stuff. It's no, that's not who I'm going to be. And I'll tell you this, you can be very successful without exposing these values, and you can build corporate cultures, because I've seen corporations that have cultures that really push ethical competition, especially with young startups now. It's just so amazing to see these young people who are doing things the right way, and they're forging partnerships with other companies, and they're building the right way, and they're succeeding. It can be done. Now, is it going to be easy? No. Are you going to run into obstacles? Absolutely. I mean, look at the world of politics. You know, there's a lot of dirty stuff that goes out there, but it doesn't have to be that way. You can be ethical. And like to me, I think there's been a severe deficit in leadership education for decades, centuries, where leadership's been based on this cutthroat idea of like you have to be tough, you have to be strong, and yeah, it's about, you know, killing all the other competitors so there's no one around, you know, and like destroying companies before they become too big. It's like if you're established in a field and like a little startup pops up, it's like, okay, let's go kill them, let's undercut them. And it doesn't have to be that way. Can you be successful being unethical and not following this? Absolutely, in the short term. But the long term isn't about how much money you're making. The long term is our society, which is a mess right now. And the long term is like, what's the weather going to look like? I shouldn't say weather. What's the climate going to look like in 50 years? And how are we going to be able to deal with the next pandemic? And we're not doing it as individuals trying to, you know, to upsell PPE, you know, like trying to, you know, to stockpile toilet paper and selling it on the black market. No, that's not the way. And the way like that so many firsters have been donating their time, open sourcing designs. I know one group of alumni up in Ontario, led by Jonathan Norris from Team 610, came up with a COVID intubation box and like open source the design out there. He worked with another first alum, Jigar Solansky from Team 188, to help come up with a design and create this stuff. That's how you solve problems. I'm just talking here. It's so weird doing this presentation without an audience because I don't know, people might have just been like, oh man, this is, what is this dude talking about? I'm just gonna go play Fortnite or something, you know, or I'm gonna go watch marble racing on YouTube. That's instead, if you're doing that now, that's cool. I might just be talking to myself, but I don't know. I'm really passionate about this. I really believe in this. And I really do think that we talk a lot about changing the world in FIRST. Believing in this and actually being ethical competitors and teaching others about the importance of ethical competition, we can actually change the world and we can make big things happen. And that's what I want to see. And that's what, you know, Gen Z, you're rock stars. You're doing so much good stuff. And take this information with you and go forward. You're the first generation that really has, lots of studies have shown, well, the millennials got to this and that you're building on it, about where ethics matter more than money. And this is what this is about, you know, so take this forward and do cool stuff. Okay, next slide. You know, another quote. I'm sure some of you out there are just like, when is he going to start talking about building robots? Spoiler alert, that's not what I do. But I do talk about strategy, and we are going to get into like the most important parts of strategic design, but you can't get there without this quote. We are going to relentlessly chase perfection, knowing full well we will not catch it, because nothing is perfect. But we are going to relentlessly chase it, because in the process, we will catch excellence. I am not remotely interested in just being good. What does this mean? Here's the thing about perfection. It doesn't exist. I mean, in reality, well, it depends on how you define reality. It doesn't exist in the physical world. On paper, sure. Circle, it's perfect. Mathematics, perfect. Mathematics is derived from a series of axioms which were carefully chosen, and everything is built from it. And you can have perfection. You can have a perfect square. You know, there's perfect numbers. There's like the golden ratio. All sorts of beautiful, perfect concepts that don't fully exist in the real world. Things that are really close, like the golden ratio is replicated in so many different ways. Snails, reproductive cycles of bunnies, all sorts of things. Bunnies are great, by the way. Love bunnies. But the point is, perfection is not a thing. And if you constantly chase perfection and only hope are only going to be satisfied with perfection, that's dangerous. And perfectionism, I can get into that in a second. It's dangerous. However, if you chase perfection with the understanding that you are not going to catch it, along the way, you're going to become excellent. And it's just kind of like, you know, like if there's someone out there, like let's say you've decided that the unicorn is perfect. To me, unicorns are perfect. Like, oh my goodness, it's a horse, but it's like it's freaking pretty. It's got sparkles. It's got a horn. Like, this is great stuff, you know? I hate to break it to you. You can go around the whole freaking world. You're not going to find a unicorn. But while you're trying to find that unicorn, you will see so much cool stuff. And that's what this is about. This is why we set big goals. This is why we dream big, because by dreaming big, you may not hit that dream, but along the way, you'll find excellence. And I'm not about just doing things halfway. I'm not interested in just being good. I strive for perfection because I believe that's where you'll find excellence. And that's what I think that all FRC teams should do. Now, be careful. Like you need to be reasonable here. Like you need to understand that you're not going to chase perfection. You're not going to catch it. You still want to chase perfection. You want to chase. Your goal is always to be the best at what you're doing, but you have to understand where your limits are and all that sort of stuff. But then just go for it, and then you'll find greatness along the way. I mean, and this was the story about 11-14. Like when we started, we knew we are always going to chase perfection, but we didn't know how. Did we even dream that one day, we'd be in the first Hall of Fame and 51 blue banners and all this nonsense? No, but like you just have to keep going, and this is what happens when like you're building your robot. Like people often ask, you always get questions like, so like, is your robot done? And then some people are like, yeah, it's done. Yeah, it's done. Like, yeah, we got a competition in a day. Like, of course it's done. I don't think that's ever the right answer, especially now that there's no bag. That's a whole other. Because as the moment you say your robot is done and you're not going to try and improve it because it's good enough, that's when you're going to get passed. Because other teams are chasing perfection. And so you just got to keep trying to reach perfection, but you're not going to get to perfection. No one's ever built a perfect first FRC robot. You can look at the best robots of all time. And even 254 in 2018, where they won every match, that robot wasn't perfect. They'll be the first ones to admit it. Ooh, but it was excellent because they just kept on going. The things that impress me the most in FRC is like, especially you see teams who come out in week 1 or week 2 and they just kick some butt. They are just like so good in week 1 or week 2, and everyone's just like, whoa, that robot is ridiculous. But those same teams, they go back to their shop afterwards and, before they've worked on the practice robots. Now they think, no bag, you can do what you want. They just kept working because they knew that just winning an early event wasn't enough for them. They wanted to get better, and they knew they had to get better. And this is like a life lesson, where you may be content at some point where it's like, okay, like I've got to a good place, but if you aren't developing new skills, the world's a scary place. And hey, I'm there. I'm like not young anymore. And now I kind of look, it's like, man, I used to be like super impressive. I'm not actually as impressive anymore. Like people that they're just like a lot of digital natives who just like are just more comfortable in a code-based world than I am. And, like I was someone who was like very at the forefront of like data analysis stuff. It's like, okay, I got some catching up to do. It was just because I rested on my laurels. And, I should have constantly been chasing perfection, but I stopped. And you can't do that, unless you're okay with the after effects of it. That's a whole philosophical thing. Maybe someone wants to ask a question about that later. But chase perfection, catch excellence. And this is the motto, whether it's the spoken motto, but this is the way that the top FRC teams operate. So again, you want to ask, like, how do I become one of the best teams in the world? Well, you need to be passionate. You need to have a culture of passion and energy. You need to compete ethically and learn from others and try and emulate the best. And you need to chase perfection, but you have to understand you're not catching it, but excellence along the way. Okay, those are my quotes. Well, maybe there's one more at the end, but let's dive in. So I give this presentation. It's called Effective First Strategy. This is like the short version that I'm giving you right now. I have 2 golden rules in that presentation. And I always say that if you're only going to take anything from this presentation, like from the long version, hit the quotes before, but 2 golden rules. So let's go over them right now. Golden rule number 1, always build within your team's limits. You might be looking at me right now and being like, dude, you just talked to us about chasing perfection, but now you're talking about limits, okay? It's like, yes. Chasing perfection means constantly trying to improve. and trying to reach your version of perfection, what you are going to define as perfection. However, we all have limits to what we can do. So you need to evaluate your limits and abilities and figure out where they are. Your limits are defined by people power, budget, and experience. We're talking FRC specific. These are the things that define what you can do. And so you have to figure out what those are. That's hard because it requires some really honest conversations. And sometimes it's tough ones because sometimes you have to say like, hey, like we are not that experienced. We aren't ready for this. Like we need to dial back our limits. It's like we can't afford, we can only afford to spend, $15,000 on our season this year because of coronavirus, and we've lost a bunch of sponsors. So like we need to have some limits in there. And if you don't set limits for yourself, you're going to try and do too much and you're not going to be able to do a good job. So it's about building within your limits. But then how do you figure out how to build within your limits? Like what do you do? Like how do you allot that? So the golden rule number 2 is if your team has 30 units of robot functions and a unit can be valued a maximum of 10 out of 10 or like 0 out of 10, it's better to do 3 things at 10 out of 10 instead of 5 at 6 out of 10. The jack of all trades is the master of none. This is a universal rule, but we're talking about it in the context of FIRST. And basically what this means is you don't need to do everything. Please don't try and do everything. You can't. And you have alliance partners, you have, just focus on a few things and do them really, really well. And if you are like if you have like a huge amount of resources that we've been defined and your limits are like way out there, then maybe you can try and do everything in the game, and maybe you can go for everything, and maybe you can do a swerve drive and a turret and like an over the bumper intake and a color wheel spinner, which will never get used until maybe next year because who knows, the game will change. But these you can't. But if you don't have all those resources, you need to pick and choose. And like the best teams in the world do this. Like look at 2056 this year. Everyone considers them one of the best teams in the world, as they should, but they're not. Their resources aren't limitless. They have defined limits, and they are so good at knowing where those limits are. And this year they built a tall robot. And a lot of people will probably like, I can't build a tall robot. You can't win without a tall robot. Well, like arguably the second best team in the world over the past 5 years built a tall robot. And trust me, like I've seen the video. They were probably, I think they were maybe the best robot in the world this year. But just saying. And 2019 championship was won by Team 973. Couldn't score high on the rocket. 973 has been great at defining their limits and just saying, no, we're going to skip the top of the rocket because we think we can be the best overall spreading the field score if we don't do that. And guess what? They were the number 1 seeded championships in their division, picked 13-23, and then went all the way to win the world championship with a robot that couldn't score high on the rocket. You know how many teams last year were terrible at scoring high on the rocket? They were just all over the place. Those robots that would get to the rock and go, ooh, 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 ooh. It's just a train wreck. But imagine if they had built simpler, and imagine if they gotten rid of one stage of their elevator, and then maybe they could have been really fast at low and middle and had a few extra pounds and maybe could have put on like a suction climb, or just could have been better driven, could have been done earlier, could have had more time practicing, could have been done earlier, could have been doing a 2-disc auto, like could have been doing all sorts of stuff. But there's just this tendency that we have to do everything. And like I used to give this I give this presentation a lot. I used to get really frustrated because I'd be like, why aren't teams listening? And I get it. This is contrary to what we see in our school system. Because you rarely get an assignment in school where it's like, hey, like get your math exam, there's 10 questions on it. You can't just be like, oh, well, I know I can ace questions 1 through 7, and so I'm just going to focus on those and just ignore questions 8, 9, and 10, because our system doesn't allow for that. You get top out at 70%. Congratulations, you're average. So like it doesn't work that way. But FRC is different. But guess what? And I hate to break this to everyone. The real world does not resemble most classrooms. There's some cutting edge teachers out there who are really doing cool stuff that are trying to make classrooms more like the real world. But like the things that we learned, like that skill set, it's not there. But in the real world, you need to be able to figure out what to do and focus on just a few things. This isn't just FRC advice. When you think about this, especially high school students, there's a tendency to want to try and do everything when you're in school. And you want to obviously get awesome grades. You want to do well in school. You want to keep track of your health. You want to have a lot of friends. You want to do FRC, like you want to do FRC like every day of the week. But you also like might want to play a sport, and you want to be in band because you think you have to have all these extracurriculars. And guess what? At some point, you're going to run yourself ragged. You can't do everything. Just pick a few things and focus on that. And I didn't talk about making priority lists in this presentation. That's a whole other world within effective first strategies. But like in life, your priority list, in my opinion, should be number one. Like in FRC, your priority lists are almost always drivetrain and then game piece acquisition. And in life, it should be taking care of your health. As a high school student, like taking care of your health, your family is, and then your grades. Those are the top three, and those it should be universal. But from there, you've got some room. You got some extra bandwidth, hopefully, beyond those three. Not everyone does. Everyone comes from different circumstances. Not everyone can focus on that. Heck, for some people, unfortunately, the circumstances they are and the way our society is, they don't have the bandwidth for all of them. They can barely keep themselves healthy because they face so many different systematic barriers. We're learning about, like, life is an adventure, and we need to be more empathetic for those people. So don't think I'm saying that I think that everyone should just be able to do those and do other stuff. There's a reason a lot of people don't do extracurriculars like first. They would love to, and it would be great for them if they could, but their resources are tied up in making sure that they can stay healthy and making sure that their family stays healthy and making sure they can just barely get through school. That's an aside. I think you can feel what I'm getting at, but you cannot do every single extracurricular out there, and you got to pick and choose what you want to do. And here's another message for all of you. Like if you're doing FRC and you're starting to feel that FRC is like, or FTC, I haven't talked a lot about FTC, and I should, because I know there's a lot of FTC people in the audience. I love FTC. I got into it this year, and I'm so down. I'm so down with that world. I need to learn more though. If your team is taking so much out of you that your grades are starting to wear, or your relationship with your family is starting to wear, or your health is starting to wear, then you're doing too much, spending too much time on FRC. You need to dial it back. And that's okay. And any good mentor will say that's totally cool. You know what, Sally? It's cool. It's chill. You can dial it back. Like, and we, you still might have a chance to be on the drive team and be a captain, but like we got to figure something out that works for you. If they say no, my way or the highway, you have to put in this much work. Be careful, because they're not looking out for you. Because as mentors, our priority when it comes to the team is your health, your well-being, your grades. And so keep that one in mind. But hey, jack of all trades, master of none. So don't try and do everything. Don't burn yourself out. Don't burn your team out. It's okay to do less. You can still win world championships and do amazing things. Or like, you can set a goal. Like, not everyone needs to be the Cheesy Poofs or 2056, but model yourself after the things they do right, which is like a lot of stuff, but don't necessarily assume that you're going to try and build the same level of resources that they have. It's like, me on a basketball court. Guess what? I'm short. So I'm not gonna go try and dunk, because like that's a limit I'm not gonna be able to do that. But I developed a decent outside shot over my time. Maybe not anymore. And like I can jump for a short dude. I can jump. And so like you just gotta play to your own strengths and your own limits. All right. One more quote, and then we can get into questions. From the great one, the greatest of all time, Michael Jeffrey Jordan. Limits, like fears, are often just an illusion. And now you're going to look at me like I'm crazy. You should look at me like I'm crazy, because I just started telling you about like figuring out what your limits are. So what did MJ mean when he said limits like fears are often just an illusion? Remember, I said you need to set your own limits. You need to figure out what your limits are. But that's something that you have to figure out. Don't let other people tell you what your own limits are. Because guess what? There's a lot of people in this society, they love putting people in boxes. Just love doing it because it makes their life easier. They just kind of see what they expect from a person and they say, well, that's what you're going to be. That's who you are. Those limits, like fears, are often just an illusion. Now, sometimes they're not. Sometimes someone has gauged you out and figured out where you are and who you are or whatever. But set your own limits. Figure out where they are on your own because you know yourself better than anyone. I'm not saying don't listen to anyone. Get advice. That's what mentors are for. That's what friends are for. That's what teachers are for. But don't buy into the limits that other people put out there for you. Because you know what? When I was, 10 years old, all I wanted to do was be like a sports commentator and like one day like be like John Madden or like, be like Bob Costas and like host like the Olympics or whatever. And, or like be on ESPN would have been like a dream. And when I was young, people told me, you're never going to be on TV like that, Like, don't be crazy. Like, how many brown sports commentators are there out there? Kind of sucked hearing that. I kind of bought into it, and like I didn't actually pursue broadcasting. I did the thing, I became a math major, whatever. Still ended up on ESPN. A lot of hard work, a lot of luck, a lot of good fortune being in the right place at the right time, but a lot of hard work. And hey, it was a limit. But like fear, it was an illusion. So that's Effective First Strategies, the short version. You want to see the long version? It's on YouTube in a bunch of different places. Check it out. You want to see the long version? Champs in 2021, if that's a thing, and Canadians can cross the border, I'll be there. I will be giving that presentation. I'm planning on doing it in both cities. Well, it'll be good, or we can just talk right now. But thank you for tuning in. And now, if there are questions, I'm going to try answering them. And my friend Ella is back. Hey, how are you?
Hi, I'm good, thank you. Yeah,
Did you enjoy the presentation?
Yeah, I just wanted to say that it was a really good presentation. It was very insightful, and I definitely learned a lot of advice that is applicable to both any FIRST program and also real life. So thank you very much.
No problem. And if we have questions from the chat, I'm happy to answer anything we got until time runs out so we can get to the next presentation.
Yep. So first question, what do you think is a good approach into the next season now that we know the game?
Well, I think the first thing is like, a lot's going to depend on if you played this season or if you didn't play. If you played, I think it's really important to do like a strategic debrief and really look into what went right, what went wrong, and what you want to improve. I think there's going to be, you can't have this conversation without talking about the virus. And so we talked about limits in this presentation and like, what defines our limits. A hard limit next year is going to be the virus for every team. And it's going to be different depending on where you are and what things are going on. What it's going to be in Australia, where you guys are doing, all of you in Australia are doing so amazing. I'm just so proud of all of you. I wish we could be more like Australia here in Canada, where you've got control over this. Or, there's some states, if you're a team in Brazil, or if you're a team in Florida right now, it's like, it's looking scary. And what's going to be available that's like a limit that you have to consider. And constantly be reevaluating because the world, no one knows what the world's going to look like in August, let alone March. So all that aside, factor in that limit just like you would factor in your budget, factor in your people power, factor in your experience. You've got a wonderful opportunity to look at teams that did really well this year and to try and figure stuff out that they did and email them, ask them, like, how did you do this? How did you make this work? How did you get this indexer to work so well? And try and emulate stuff that they were doing, but be careful because there's a tendency, robots always look simpler than they are. And you can go watch what 148 did this year at their first event, 118, where they were just so good. And it would be really easy to be like, oh, we got so much time. We've got all the time in the world. Like, we can definitely copy that robot. And it's like, that stuff's hard. And the key to any robot this year, like, I mean, anyone could have just bought a shooter from Great. Like the shooters, there was no like, I shouldn't say there was no, but like there's not too much secret sauce to a shooter. However, it's the tweaking and adjusting and figuring all that stuff out. So you want to make sure you do get all that stuff right. So going into next season, I think it's like, learn from what's out there, but don't bite. The golden rules really do apply right now. Don't bite off more than you can chew. Don't try and do too much. And then also, I mean, going back to the virus, like, don't push it. Like, your health is just the most important thing here. And, you know, like, follow the public health guidelines in your area. And like, if you're not sure, be a little bit stricter. This is the one where better safe than sorry, you know. And we have an amazing community here in First, and the last thing I would ever want to hear about is like an outbreak starting because of a First team that was spending, you know, that wasn't socially distancing properly. It wasn't wearing masks and wasn't, you know, washing their tools and disinfecting and stuff. So like, just be safe.
Yeah, it's very important during this time, and it is difficult to know what is going to happen. So thank you for that insight.
No problem.
Another question.
Sure.
How do you believe that you can do the max amount of preparation preseason?
Well, I mean, there's different ways to prepare in the preseason. So again, I always talk about self-evaluation, and that's like, you can't solve a problem until you know what problem you're trying to solve. And so when it comes to preparation, you need to know what you're preparing for. It's like, it's more than just saying, oh, I'm preparing for the season. It's about like, what deficiencies are you trying to address? Where do you want to improve, and what do you want to do? So you have to figure out what that is and set a goal. And like, I mean, I just come back to effective first strategies for everything, because you can't try and do too much in the preseason. You have to pick one or two things that you really want to improve on. And so like, you say like, okay, last year I was happy with the robot that we designed, but when we built it, it just wasn't right. It just didn't come together. It's like, I think we need to like work on our manufacturing techniques and work on our assembly techniques. It's like, okay, so then identify that target, and then say, all right, let's pick an old game, and like, let's, find somewhere where like the CAD's already out there. It's, and let's just work on machining. Let's try and make some precision parts and try and, follow a well-defined goal. But it's not going to be uniform. Like, your team is unique, and you also got to pick something really specific. So I say the best way to prepare in the off season is to figure out what you want to improve on, and then build targets based on that.
Another question.
Sure.
Do you have any advice for encouraging students to adapt to a mindset for engaging and interacting with other teams?
Well, I mean, when you talk about psychological theory, like they like to break us down into two different groups: introverts and extroverts. And for an extrovert, extroverts thrive on contact with people, and they naturally want to just talk to other people. They want to meet new people. It's exciting. It's energetic. I'm a natural extrovert. I love chatting with people. Some people are introverts, and that doesn't mean that they don't like people. That's a misnomer. No, introverts, they sometimes it's a little bit more difficult for them to reach out, and they like, alone time and their own breathing space and being able to adapt to things like that. But it doesn't mean they don't value emotional connections and intellectual connections. So I do think that you got to be careful about trying to force a student who's really uncomfortable, into like, hey, go talk to teams or whatever. Because again, if you're not passionate about it, it's not going to work. But I think it's about reminding teams how much can be learned from other teams, and just working with individuals to kind of find what their comfort zone is. And remember, like, one thing that, forget about just introverts or extroverts. People just kind of appreciate sometimes, when you're feeling shy about a situation, when someone approaches you, and remind people that like, hey, that team probably has students who are too nervous to talk to other teams as well. So maybe just, try and reach out, and maybe, because like, it's very easy to always, when you're looking for someone to talk to on a team, you go to their pits, and it's just easy to latch on to, like the girl who's like clearly the captain and just like is very like, hey, how's it going, everybody? Like, welcome to our team. And that's cool too, but like, maybe sometimes reach out to someone who's a little bit shyer and see what they're saying. And if other teams do that, it just kind of builds that bond. But also, I think it's important for our teams to make our teams as welcoming as possible to other teams. And just remember that, when you're in the pits, to be like, hey, like, to all your team, it's like, other teams are going to be coming around. And like, if a team is just kind of like, they're nervously standing outside of our pit and it looks like they want to ask a question, just be like, hey, what's up? Is there something I can help you with? That makes it so much easier, So that's my little piece of advice there.
Yeah, communication is just so important in First. And
oh yeah.
a lot of people can probably relate to those experiences, so thank you. This is not a first related question, but someone asked it anyway.
Sure.
Do you think that corporations and researchers can put aside their competitive mindsets and instead strive to work together for the good of our world?
I mean, yes, there are some corporations which are doing that. Like, if we're going to ask that in general, I think we have a long way to go. I think we have a long, long way to go. Like, I'm not here to paint a rosy world and say everything's perfect, everything's all flowery. No, we have a lot of companies who their sole goal is profit, and they are scrupulous about that, and they don't care about other externalities. It's about how much money they can make, and if they're going to trash the environment in the process, then so be it. And if they're going to put a bunch of other companies out of business, then so be it. However, I've seen things that encourage me. I've seen the emphasis on ethics and having meaning from your work and caring about the greater good. The millennials and Gen Z possess. I think I've seen changes in how we look at things politically. I think that the past month of protests in the United States has shown that we're ready for a little bit of a shift. And I think that people are open to considering not what just matters to themselves, but what matters to others. So do I think corporations are ready right now? No, but I think it's getting better. And I think there's definitely a path. And I've been really impressed at the pharmaceutical companies, how they've been working together on their journey towards a coronavirus vaccine. Now, I get that it took a global pandemic and 500,000, 400,000 people to die globally for this to happen. And obviously, a lot of people's goals in this are financial, not necessarily like I want to make the most amount of money, but I want to make sure the country's economies and whatever. And so like that's weird, but like we'll tell when it comes to distribution of the vaccine, because it's not just about producing all these units. What's our plan to get these vaccines to, like, okay, so say it gets developed by an American company. What's our plan to get it to Canada and to Australia, to New Zealand? But more so than that, what's our plan to get the vaccine to Uganda and to Sudan and to Thailand? These countries need the vaccine too. And who's paying and what's the plan? And that's going to really be a test for our corporations and our nations to all. Are we going to come together, or is it just going to be a mad grab where everyone's just going to try and get their own? And I hope we do the right thing. And I understand that we all want to protect the people who are closest to us. But with this vaccine, we need with the coronavirus, we need a degree of cooperation for this to work. Because guess what? If everything's great here in Canada and we've stemmed it, and 90% of Canadians are vaccinated, but only 30% of Americans are vaccinated, we're in trouble in Canada. Because that, everything's interconnected in this world. So I'd like to think that corporations are getting better, and I'd like to think that 20 years from now we have corporations run with the mindset that people are learning in FIRST now, and people are learning by seeing what's going on with these protests and stuff, that maybe we'll be in a better place. But it's going to take time.
Yeah, hopefully people will come to terms with how the world actually is and won't just focus on themselves.
Right.
We have time for one final question in this session.
Sure.
How do you suggest approaching recruitment of new students during the pandemic?
This is a tough one. So I might have an interesting opinion compared to some people, but I think that we might want to take a step back this year from hardcore recruitment. I think we have to understand that this next year is going to be hard for a lot of people. I've lost track of the unemployment stats in the United States, but it's like 20 million people. And that's hard as a kid if your parent or parents have both lost their jobs, and it's hard. You may not be able to do as many extracurriculars. You may not be able to do any extracurriculars or whatever. And recruiting it's just recruiting for first teams is hard as is, and when everything's great. And so during the pandemic, I just want to advise teams, like, don't push it. And your team might do a little bit better if it's a little bit smaller next year, because sponsorship dollars might not be there and the such. However, FIRST is a great program, and we want people to have this experience, you know, and we don't want, it's not like I don't want teams to say our doors are closed, you know, but I think it's going to depend on what the restrictions are in each area and what it's like, you know, because I think there's a good possibility that some teams are going to be able to operate, but they're going to be limited to, like, you can't have more than 10 people in the shop at a time. And so at that point, you might be better off with a smaller team. I'm not saying, I don't want anyone kicking people off their team. Like, that's terrible. Imagine how terrible that'd be. It's like, I got kicked off the team because of the coronavirus. Like, that's, you know, not good. But it might be a year where you hold on recruiting a little bit. I don't know. That might not be the answer our friend in chat was looking for, but just let's take it easy. Our health is what matters right now. Gotta flatten this curve. We gotta stop this out.
That's all we have time for, so thank you so much for your time today.
Well,
Your presentation was excellent.
Thank you very much. Thanks for having me. Thanks for everyone who's been involved with this. Team 3132 is the host team here, but I know there's a whole bunch of other teams who've been involved, and thanks to FIRST for supporting this, and thank you for being a great co-host. This was a lot of fun.
Thank you.
All right, I can't wait for me to be your co-host, like when you're giving a presentation. I get to ask you the questions.
Thank you. Goodbye.
All right. See you, everyone.
Hey! Hey! Hi! So for the final presentation in this session, FLL Team Apollo will be talking about FLL EV3 robots that kiss. Hi guys, how you doing?
Good.
You guys ready to present?
Yeah, we're ready to go.
Yep. Take it away.
Awesome. So hi, we're Team Apollo. I'm Amelia, a team coordinator.
I'm Jacob, our robot analysis.
And I'm Addison, the team PR. And I'm here to talk to you about robots that like to kiss. Not like that. Anyways, so Team Apollo is a homeschooling team from the Central Coast, New South Wales, Australia. Our team currently has 9 members, ranging from ages 10 all the way up to 15. Team Apollo has been through 5 FLL seasons, and during these seasons, we've earned many achievements, such as being invited to 3 different international events and winning many awards, such as Robot Design, Research Presentation, and Core Values Awards, as well as the Champions Award.
One of the many things our team is known for is our simplistic robot designs that still manage to score pretty high on the board. We think that this is because our team likes to kiss.
No, not like that. KISS stands for Keep It Simple, Stupid, and is one of the many strategies our team follows throughout the design process thinking model while designing our robots. The design process: identify the problem, research the problem, identify solutions, prototype and test solutions, and if needed,
it's always needed,
start again. So most teams start by building a basic drive base, such as the EV3 Educator Bot or the Rayleigh Rover, or even just like a basic box robot. And then they design around that base, adding on their attachments and sensors like as they go. But our team likes to start the design process right from the beginning by identifying the challenges that our robot must overcome on that season's challenge board.
Once we have identified the robot's needs, our robot sub-team, led by the robot analysis, starts to design a robot strategy, considering things like the size of the drive base in comparison to the board and the size and type of wheels needed to navigate the board.
Then we start brainstorming. After researching different robot models, we take the best parts of each robot and compile them into our own robot designs, usually creating 2 or 3 different ones. Once we have the blueprints, we start building and testing our designs, making sure they actually do what we want them to.
The best design, or best parts of each design, are used in our final competition robot.
Now, let's talk attachments. Attachments are anything that get added to your robot that is not part of the main drive base and are designed to assist in accomplishing a mission or a specific action. So attachments can be passive, meaning non-motorized, and these use simple machines such as levers, inclines, and wheel and axles. Attachments can also be motorized, meaning like powered by a motor. Everyone knows that.
Passive attachments are good for more simple tasks such as pushing, retrieving, knocking things over, and they tend to be more reliable while also requiring less coding.
However, motorized attachments allow for more complex tasks, such as lifting, twisting, and grabbing. This, in turn, requires more complex coding and can be less reliable.
But attachments take time to put on and take off, and in the heat of a match, you don't want to waste any of your precious 2.5 minutes.
Which is why we use universal mounting plates, such as these.
So this universal mounting plate is for passive attachments. So it uses these two axles here, and you can slip attachments on and off, just like this.
This universal mounting plate is for motorized attachments, and it attaches to this gearbox on the medium motor, which is fitted with the other half of the mounting plate.
So it clips on just like this. Awesome. So this allows for a secure connection while maintaining the quick and easy changeover to keep everything in that 2.5 minutes.
Now, we're going to show you how to make both of these universal mounting plates.
All right, so let me swap the camera view. Awesome. So to make a passive mounting plate, you're going to need 2 11 beams, 4 long blue pegs, 2 L beams, and 2 4-stud nails. And you're going to grab your first 11 beam and put the short ends of the blue pegs in just like this. Awesome. Then you're going to grab your L beams and attach those to the blue pegs. Just like this. Then you're going to grab your other 11 beam and put your nails in on either end and attach your other part just like this. So as I mentioned before, these 2 axles are where we add on our attachments, as demonstrated over here, with our hugger attachment here. So it allows it to slip on and off while keeping that time nice and short. Awesome. Now we're going to show you how to make a motorized mounting plate.
Okay, so to make a motorized mounting plate, you will need a small black gear, a picture frame, 1 small yellow stopper, 1 grey stopper, 1 axle connector. As you can see, the axles go on the sides, 1 7 axle, and 1 5 axle. Now to make this, first you will need to grab your picture frame, and you will need to also grab your 5 axle. What you will do is you will put your 5 axle through the middle hole of your picture frame, and then put on the axle connector. So it should, in the end, look a bit like this. Okay, so next we're going to place it down here, and we are going to grab our 7 axle, put it just through there, and then grab our small black gear. As you can see, there's a little axle hole in there, and then you will put the axle through that axle hole, and it should look like this. Okay, now you want to push your axle through the black gear just a tiny bit. So now it should look like this. Then put on your small yellow stopper, making it look like this. Push the black gear back and the small yellow stopper, making it look like this. And put your grey stopper on the end there. So excuse me while I just do that. Sometimes Lego bits fall off and they can just, not work. Yeah, not work. So I'm going to put this yellow stopper back on.
finished product looks like this.
Okay, so the finished product will look like this.
Now to make the other half of that motorized mounting plate, we're going to need 2 more picture frames, 4 red pegs, stopper pegs, a short blue axle peg, a long blue peg, 2 of these axle half peg things, axle plugs I believe we call them, a red axle, and another small black gear. So we're going to get our 4 red pegs and stick them in a picture frame just like this. It'll look like that. Then we're going to get our medium motor, put it in the middle, and push those red pegs all the way through. Awesome. Then we're going to grab our long blue peg and put it in the corner, as well as our 2 axles, sticking the peg side into the picture frame like this. Our next picture frame slides on the top of those, and our short blue axle peg goes in the other corner.
Making sure the peg side is plugged in.
Our red axle goes in the middle of the medium motor, and our black gear goes on top of that.
To attach your motorized attachment to the mounting plate, use the axles on either side and clip the mounting plate onto the gearbox like this.
Awesome.
A lot of rookie teams start out with Dead Reckoning, which is where you use basic programming to drive your robot around without input from the robot surroundings. This is the simplest approach and works to some degree.
However, this method of programming isn't always reliable, and the slightest change in the robot's environment can throw off the entire mission run.
To fix this problem, we use the EV3 sensors, such as color sensors,
to follow and square up on lines around the board,
and gyro sensors,
to know which way we're actually facing.
Using sensors requires more complexity in coding. So often, in the place of sensors, we use a mix of Dead Reckoning and the surroundings provided. Our robots are always fitted with bull bars on the front and the back to allow for squaring up around the field.
So when using color sensors, our team typically uses 2 for more accurate line following and squaring up on lines around the field. This does require more complexity, which is one of the things that we try to avoid. However, also it adds more reliability to our robot. So tossing up between that complexity and reliability is something that we've struggled with, but we believe that this is the best way. So the sensors that we use each season actually depends on the challenge board. Just to give you some examples, the first season we used touch sensors behind our bull bars, and we relied on both of those touch sensors being pressed to know that our robot was squared up. In later seasons, we found that we could actually just run our robots into the wall just to line them up without using touch sensors, therefore taking away some of that complexity. Another example is last season, the board was dark purple, and robots aren't very good at seeing color. It thought dark purple was black, meaning that we couldn't use color sensors. Instead of this, we turned to the gyro sensor for location and turning to know where it is on the board.
As you probably already know, a new robot model has been released recently. Drum roll, please. Spike Prime. Spike Prime is simpler than an EV3 robot, but the next step up from a redo model, and is targeted toward primary school kids. The parts included are easily attachable, and the kit contains new parts such as wire clips and biscuits.
Of which the pink biscuits are clearly superior.
The Spike Prime also has free tutorials, both building and coding, and contain key elements like basic engineering principles with the new Spike Prime parts, how to troubleshoot and problem solve, and how to use the new sensors, which are all critical competition skills.
So the programming language for Spike Prime is also a lot more intuitive and simpler than LEGO Mindstorms, and it closely resembles Scratch, so it's a lot easier for kids to understand. Alternatively, you can choose to create your project using Python as your coding language.
Now, let's keep talking about coding. We mainly use LEGO Mindstorm's EV3 software as the standard, as this is the standard and most widely taught coding language for an EV3 robot. We like Mindstorm software because the basic code needed to drive a robot is easy to understand, and it provides flexibility so you can tailor your code to your needs.
But not everything is perfect. Mindstorm is sometimes unpredictable. Did you know that you can make your robot do donuts with a drive straight program?
So some may argue that making donuts with a drive straight program would be a hardware problem rather than a software problem. But we can assure you that we have tried changing bricks, changing motors, rewiring, crossing wires, downloading by both Bluetooth and cable, changing the program, rewriting the program, and when all else fails, using the age-old IT solution for everything. Turning it off, counting to 10, and turning it back on again. Yet, our robot still does donuts. So it's quite possibly the robot gods screwing with us, because this always seems to happen days before a competition.
Anyway, back to the programming. We have also started exploring EV3 MicroPython, the Python equivalent of LEGO Mindstorms. This, for some strange reason, seems to be more reliable than Mindstorms.
I'm telling you, it's the robot gods.
And codes in text rather than block coding. One downfall is that the navigation on the EV3 brick is complicated and can take time out of your robot match that could be otherwise used for running missions.
That leaves us with SpecPrime coding language. SpecPrime, as mentioned before, is a scratch-like coding language, using simple code blocks to solve challenges. SpecPrime code blocks are kid-friendly, using both pictures and words to show the block's purpose.
So now that we've covered the basics of robots that kiss,
keep it simple, stupid!
So we've covered the design process thinking model, building drive bases, simple attachments, which sensors to use and how to use them, and a bunch of different coding languages.
If there are any questions, now is the time to ask.
Hi guys, thank you for your presentation. It was very cool. I really like the way you presented everything. It was very entertaining. We have a few questions to ask you guys. So, do you guys have a favorite robot that you've built?
Ooh, I think this one's actually probably one of our nicest ones. It's got, bull bars. It's got our light sensors in the middle. It did have a medium motor in the middle. However, that's been repurposed. But it does everything that we need it to do while staying small and compact.
Exactly.
Cool. Do you guys, similar question, do you guys have a favorite attachment that you built?
I think
I do like the hugger.
Yeah. Although I personally like the thrower, because in last season we incorporated our research project into our robot game by throwing a team member minifigure over the crazy crossing,
which scored us 20 points and was fun.
Yeah.
Cool. Do you guys have a favorite FLL game that you've participated in?
Ooh. I don't know. They're all really good. Oh, actually, I do really like the Animal Allies. That was a really cool challenge.
Yes, that was amazing.
Yeah, putting wheels on pigs, throwing animals across the board. Yeah, it was really cool.
Yeah.
Yeah, what made you enjoy that game specifically?
We liked
the thought that went into it. Yeah.
So our research project for that season, we thought was really cool. It was all about talking to animals, Dr. Dolittle style. And then our robot that year was also really cool.
What do you guys enjoy the most about First LEGO League?
I feel like
it's the friends that we make.
Yeah.
And the connections.
Yeah. It teaches you those life skills that you need. It teaches you research skills, problem solving. And it also gives you so many opportunities to, go overseas, meet new people, explore, different cultures.
Yeah. Connect, and it can also help you with contacts to get a job.
If you guys had to pick either the project core values or the robot games to work on solely, which one would you pick?
Core values.
Core values, 100%.
Definitely.
What makes you enjoy core values the most?
It's those life skills that you need. You use them in every aspect of life.
You also get to play games for core values.
True.
Yeah.
Do you guys have any advice to give to any beginner FLL teams?
Well, robots don't like humans, and if your robot is not behaving, the best way to make it cooperate is to threaten it with a sledgehammer.
Another piece of advice I give to FLL teams starting out is that you will see amazing robots out there, big robots that cover the entire board, taller than people, but these are really advanced. We aren't even up to that yet. Simple robots. Simple robots do everything you need them to do. Our first year's robot had an attachment. All it did was go up and down and catch things. And that actually won us the maximum amount of points that day. And we won the Robot Performance Award. So simple is better, guys.
Yeah, that's really interesting. Thank you. How do you guys approach designing and building a new robot for each challenge or season?
Well, we look at the challenge board and just see what it needs us to use. So as you can see, the seasons board, you may not be able to see it, but here's a black line, and there's a number of those across this board. And we thought that light sensors would be useful for it.
So identifying the different challenges our robot has to overcome. Does it need big wheels? Does it need light sensors? Does it need to be able to jump for whatever reason? So we identify those challenges, and then we go through the design process, brainstorming different designs, prototyping those designs, testing them to see if they work, and if they don't, starting again.
Yeah.
Do you guys typically do any preparation before the season starts?
We do like some robo camps because we're a homeschooling team. We offer to the homeschooling community 2-day robo camps.
Yeah.
And we just come and do basic robots, crazy wheels challenges, making animals, theme parks.
Yeah.
Yeah. And just doing some of that basic coding experience.
Yeah, that'd be really useful for them. Do you each have like a favorite first LEGO League memory?
I really love the year that we went to Denmark. So probably one of the best parts of that, we met a team from London. They didn't know what the chicken dance was. And so we did the chicken dance at the competition and taught all the teams the chicken dance. Because apparently that's an Australian thing.
Is it really? I thought it was... Damn, okay.
We thought it was worldwide too, but apparently not.
Do you guys have a favorite mission from the game this year?
The game this year, Yeah, the bridge was pretty cool. That was a challenge, trying to figure out how to get our robot up the bridge, what wheels it needed. Did it need more wheels? What angle did we drive up at? Did it go slow or fast? So that was a challenging one. That was interesting. Yeah.
I also like the swing as well because, well,
it links in with our research project. So we looked a lot about disability accessibility, and that swing mission linked into our research
everyday
project.
lives as well.
Did you have a favorite mission from past games, or like your all-time favorite mission?
Definitely the Crater Crossing, because we threw people minifigures over the top.
Yes.
I see why that would be entertaining.
Yeah.
How does your team effectively manage your time?
So in my role as the team coordinator, I create a weekly schedule each week for our meetings. It incorporates our robots, our research, and our core values by playing games at the start and the end. And this comes off our season's timeline that we create at the start of the season to say, these are the milestones that we want to hit by each week. Where should we be up to?
Yeah.
Does that work well for you guys?
This is the best method we've found so far.
So you would recommend it for other teams to have a similar approach?
Yes. Definitely. Make a timeline at the start of the season and also weekly schedules.
Nice. How do you guys typically resolve like conflicts on your team?
So our team is we like voting. We make sure we hear each side, and then
if it's more to do with the robot side, then the robot analysis, me, would get more of a say. But if it was more to the research side, one of our lead researchers would have more of a say.
And we just take it to a simple vote. It doesn't have to be an official, all right, who wants this solution, who wants this one. It can just be a, hey guys, what should we do? Cool, great.
Yeah, that's a pretty effective way of doing it, and it works for you?
Yes.
Yes.
Do you guys have a favorite part of the competition?
Core values, meeting people, having fun, dancing.
Dancing is amazing.
Dancing is a very good part.
Yes.
What is your most recent research project about?
Well, this is research project was all about kids with disabilities and how they're not able to do stuff that kids who don't have disabilities are able to.
Yeah, so we were looking at accessibility, looking at playgrounds particularly. So a lot of playgrounds don't have accessible equipment, and not just for people in wheelchairs, but for people with sensory issues, for visually impaired people. And so, yeah.
And if they do have that equipment, then it's off in a different area.
So we looked at creating a playground that was accessible for all. So as well as adding in a VR component to, give it a bit of a twist. For people with sensory issues, they could experience the playground through VR rather than having to face all those sensory challenges.
Yeah.
That's really cool. Yeah, that's really cool. Yeah. What made you guys interested in pursuing that research project?
So in our team, a lot of us experience disabilities either firsthand or secondhand. And yeah, it's something that's presented to us in our everyday lives. And so we wanted to help others that were like us.
Yeah.
How do you guys make your presentations creative? I mean, the presentation you did before was really creative.
We don't like PowerPoints as a rule. We're a homeschooling team, we're a fun team, and PowerPoints are boring. Let's face it, everybody knows that PowerPoints are boring. So we like to do a bit of a skit, put some jokes in, make it fun,
Acro. Chocolate cake.
Yeah, we do acro. We've got tumbling, cartwheels, people being
Chocolate
thrown.
cake.
Chocolate cake turns up in all of our presentations. But yeah, just make it fun, make it exciting, and make it engaging so that people remember it.
Yeah.
Yeah, I think that's really good advice. I want to see one of those presentations now with the chocolate cake. That'd be. How do you use the chocolate cake in your? How do you use it in your presentations?
Sometimes we hand chocolate cake over to the judges. Sometimes it'll be where's my chocolate cake? Just a line casually thrown in there.
Yeah.
We did hand chocolate cake to judges one year.
Some sort of bribery.
Yeah.
We're not bribery.
Yeah, bribery. Please help us.
Does your team have any primary goals for the next few years?
I feel like getting more kids into it. So right now we're a team of 9, and that's pretty good, right? But we want to get our next generation through. We want to get the younger kids that are, 8, 9, 10 starting FLL so that they can, carry on our legacy.
Do you guys see yourself moving into other FIRST programs in the future? And do you look forward to doing so?
So I've joined FRC team Thunder Down Under. It's really cool. Helps us continue, robotics, STEM, all those things that I enjoy. I'm pretty sure these guys, Jacob's been asking when he can join FRC.
I'm actually an ambassador for another STEM project. It's called Tech Girls Are Superheroes, which is trying to get more girls into STEM-based projects like this.
Yeah.
Has there been like a best research project that you've seen?
Oh, that we've seen. I can't.
Our one, obviously.
No, I've seen some pretty cool ones. Now, we don't get to, go in and see the presentation, but there's all the information that people have in their pits. I've seen lots of very interesting costumes.
Yeah.
We've had, trash cans. We've had big chutes, curtains with, flying colors everywhere.
There was a lobster once.
Yeah, there was a lobster once. That was an interesting project. But yes, the more fun they are, the better.
Apparently you've participated in a remote FLL event in the past couple of weeks, so what was that like?
So that was really cool, actually. We were able to do it over Zoom. All the interviews were pushed into one 30-minute interview, which was a bit of a change, but yeah, we took it into stride. But it was really cool getting to meet from teams all over Australia from the comfort of our own home, being able to use our robot, our board, and just getting to relax, you know?
Yeah.
It was a fun competition.
Would you like to do something like that again, or would you just prefer to go back to normal competitions?
I reckon a mix of both.
A mix of both would be good. Doing it over Zoom or over, the internet provides more opportunities for other teams and more competitions to happen. However, there's a lot of hype. You miss the hype over the internet. There's, at a normal competition, there's a lot of dancing, chanting, singing, people meeting each other, which we missed a little bit of over the internet.
Yeah.
Yeah. Mix of both would be good.
What first attracted you to First Lego League?
So we've always been interested in STEM. The science, and our coach actually was like, hey, there's this competition, and opened it up to the homeschool community and said, who would like to come and do a STEM robotics competition?
We all put our hands up, and we're here today.
Here we are. But yeah, we've participated in a lot of STEM competitions before this, and we thought this one was really cool.
How has your life changed since joining FLL?
I've become a more confident speaker and a better team leader as well. There's all these aspects, all the soft skills that you need for life, the teamwork, the research skills.
I've learned how to make a book.
Yep. Compiling research documents. Problem solving, troubleshooting, all those skills that you need for life. FLL has definitely changed our lives.
Yeah, they're just such vital skills. That's such an important program to teach kids, so it's really cool, Are you guys interested in any STEM careers?
Yes, definitely.
Definitely.
Yeah, I've swapped between a few ideas, going from a biomedical engineer, a software engineer, medical sciences somewhere. I'm not quite sure, but it'll definitely be in STEM.
I've had lots of ideas and put a lot of them into one lifetime.
So yeah,
Any
I think
specifics?
Becoming an Olympic swimmer and becoming the first president of Australia.
Very ambitious.
Just a little bit longer for that one. Jacob actually wants to be a game designer.
Yeah, that would be one of my favorite jobs. Yeah, I like the idea of being able to make something that makes people go, "Wow!"
Yeah, it changes lives.
Yeah.
Has FLL helped inspire this, or were you interested in these kind of things before?
I know for me personally, I was definitely interested in STEM, but FLL has opened up my options. It's let me meet people, network. It's just opened up so many opportunities for me personally.
I would say the same.
Yeah?
Yeah.
How many years have you guys been participating in it for?
So me and Amelia have been here from the very start, so 5 seasons, I believe.
And I was here for 3 years, but I was also the first one in the junior FLO team.
Yeah, so I've been involved for a while.
Yeah. Have you learnt any lessons from being able to be involved in FLO? I mean, you kind of touched on it earlier, but...
Time management. Time management is a big thing. Otherwise, you end up in the 3 days before the competition making all your books, making all your posters, making the robot work again because it stopped working for some reason.
Rebuilding the robot.
Multiple times. Definitely time management. Yep.
Yeah.
Another thing.
Getting the team to actually be a team.
Yep. So teamwork, staying focused, making sure that project management, making sure we're all working towards the same goal.
Yeah.
Which are all very important aspects of a team, and you can't really work well on a team if you don't have those, so.
Yeah.
So apparently you guys had the opportunity to go to Silicon Valley and meet with some companies there. How was that?
that was awesome.
Amazing.
We got to, pitch our ideas to different executives at Google, Nvidia, Facebook,
eBay.
eBay.
Gumtree.
Yeah. And we were just able to get a feel for what a job in STEM would be like. So we got a tour of the workplaces. It was amazing to see. Gummy bears.
Yeah,
Addison
really
likes
cool.
it. Addison likes that there's always food in all these places. They always have a kitchen stocked with gummy bears.
I like the nooks and crannies that they have at Google. They're like little small spaces that you can just hide in.
All the study holes.
Yeah.
What kind
There
of
are-
things were you talking to them about? Oh, sorry, you go.
Sorry?
Oh, you go.
Oh, I also like that there are soundproof cubicles, and I thought,
yeah.
that's your new office.
They should have them more around. Like, I don't understand why people don't implement them more often.
Yeah, they should.
Yeah.
Definitely.
What kind of things were you pitching to these companies?
So this particular time we were pitching an app that we had created. It's actually a solution from one of our previous years. It's called Talk to the Hand, My Bucket's Full, and it's about helping kids with sensory processing disorder and other difficulties to regulate themselves throughout the day. So it's got, activities such as sensory wake up, sensory pit stop, just getting your body active and moving.
Drawing, bubble wrap.
Yep, all those calming activities. And we were able to share this with all these companies and receive feedback on our solution and, all the research that had gone into it. Yeah.
Yeah, it sounds like a really cool app. Has anything come out of it?
So it's actually up on our website right now. We're going to do
Yeah.
a soft promo. Littlebutterflies.technology. If you want to buy our app. But yeah, that's going up. That's live. We actually sold it to the head person at Gumtree. He's the general manager there.
Yeah.
And his son has sensory processing disorder. And when we pitched our app to him, he said, "This is actually a really cool app. Can I buy it?" And so yeah, it's impacting lives.
That's so cool, yeah. Congrats, guys.
Thanks.
Amelia, since you do FRC, how would you compare FLL and FRC?
I love that they're both STEM competitions, and I love that they've both got the robotics aspects of it, but they both still keep that core values. I feel like FRC is kind of like the older sibling.
Yeah.
So, FLL is kind of, the younger siblings. We're playing with Lego robots, but FRC is, okay, it's getting real now. It's, it's the step up. Yeah.
How has your team run since social distancing and COVID-19 has begun? How have you been approaching things differently?
We have been putting all our stuff online. We have a team app that we use, so we can put up documents, share, videos, video call.
Yeah.
Also, since technically it's a school get together, we can meet up, and so that's been good. But yeah, we do a lot of stuff online now.
How has that impacted the way you've been able to communicate and get stuff done?
We've always done a part of it online, so we've just put more of it online, I guess. So, normally we meet once a week, right?
Yeah.
But this has had to happen online, and so we haven't been able to meet as often, about once a month or so, which has been challenging. But yeah. Yeah,
So
I
you
think
kind of
it's,
prepared a bit beforehand.
yeah.
What's it like having different Team Apollos across all of the different FLL programs?
So obviously we've got Team Apollo. We've got our Team Apollo juniors that do junior FLL.
Yeah.
It's really cool. We get to be
And Team Apollo Discovery as well.
Yep. And it's really cool. We get to mentor these young kids, get them excited for STEM, tell them how cool FLL is, how cool FRC is, get them going through that program and just inspiring that love of STEM so that we can get the next generation into STEM.
How have the experiences of mentoring them and inspiring them impacted you guys personally?
We learn a lot from the kids, actually. So like kids are very creative.
Yeah.
I've had some of the kids from the junior team come up and go, oh, why don't you build it like that? And I've gone, oh, I didn't think of that, you know. Learning, just they're fun. The fun aspect is really cool. We get together, we play games all together.
Yeah.
That's very fun, playing tackle games with little children. But yes, we get together, we have fun. It's great.
Once you guys finish being an FLL student, would you be interested in being a mentor?
Definitely,
Yeah.
yes. I would 100% continue to mentor Team Apollo as well as the junior team. Just, yeah, keep that love of STEM going, like I said.
Yeah.
Yeah, it's a really cool thing being able to do that. Do you see any real-world application of Lego robots?
Yeah, it teaches not only that, it teaches us basic engineering skills, which, you know, goes into biomedical. One of the careers I was interested in was biomedical. All those things about prosthetics.
Yeah.
Lego robots teaches you the basic engineering things that you can apply to real world.
I've seen a guy who built a Lego arm for this kid who had his right arm missing. And it was made out of 2 EV3 bricks, one NXT, and just a bunch of motors and sensors. It was amazing.
So yeah, definitely real world applications there.
Yeah, it's really cool as to what you can do with it.
Yeah.
What do you guys think is the defining factor for team success?
Good core values.
Yeah.
Definitely would be number one on the list. Good core values, time management, teamwork, project management.
Yeah.
Yeah, definitely.
Definitely making sure everybody knows what's happening. Like, you know, some teams have these people that work on the research project and these people that work on the robots, and they never meet each other.
We like to combine the two, so like everybody in our team does a research project, and everybody in our team helps build attachments while still having that sub team.
So everybody has basic knowledge about what it is that we're actually doing. Everybody knows what we're working towards.
Yeah, and that's just really important. You can't really run a team properly if no one knows what's going on. It just doesn't work.
Exactly. Yeah.
This is not as relevant, but do you guys get provided snacks during your competition? And is there a go-to snack that you always get, or is your favorite?
Mentos.
Definitely.
Always lollies. We have lollies in our table. You know, we share them out. We say, please take a lolly in the spirit of gracious professionalism. Woo!
Yeah, you gotta have sugar to keep you going through competitions.
Yeah.
What's the biggest thing you guys have learned in this year's FLL season?
This year's FLL season, I feel like we had a lot of rookie members this year. We had 6 rookie members out of our 9.
Yeah.
And being able to improve my leadership skills and being able to mentor these rookie members so that they can gain all the knowledge that I've also gained and we've gained throughout the seasons.
Yeah.
Do you guys have any team bonding activities? And what are they?
Yes, definitely. In the core values book that I make, I have like a whole almost 2-page list.
So we play a lot of games as a team. It gets that teamwork going, as well as, you know, strategy.
Keeps us de-stressed.
Yeah, we have team sleepovers throughout the season. So if we go, hey, we actually really need to get this specific project done, we'll go, okay, we'll have a team sleepover. You know, we work all day. At night, we eat pizza, watch movies, and then the next day we keep working. Yeah, team bonding. Yeah.
Yeah, that sound like really cool team bonding activities. I'm a bit jealous of your team bonding activities. How would you like to see FLL evolve over the next couple of years?
I feel, I don't know. It's pretty great, actually, it is. I honestly couldn't tell you something to add. What is there anything that they would?
More of it.
Yeah, more.
Yeah.
More competitions. More practice competitions, ones that, you know, aren't high stakes. You know, there's regionals, there's nationals and internationals, but just having fun, friendly competitions would be
Yeah.
great.
What would you say to people that are potentially interested in FLL but don't know if they want to do it or not?
100% do it. Even if you're not robot minded, you know, there's kids in our team. We had a kid on our team a couple of years back that the only thing he knew about the robot was the emergency stop button. That was his only job, to know the emergency stop button. But he was great at being a motivator, at team games, keeping everybody hyped. So you don't have to be interested in robots. You don't have to be interested in research. There are a wide variety of roles in FLL.
Yeah.
And you can fit into it. There are multiple roles. You can definitely fit into the FLL program somewhere.
Coming into FLL initially, did you guys have like a role that you wanted to fill specifically?
Well, at the start of each season, we kind of have a think about what role we would like to pursue, and we put it down on a piece of paper. And we then like hand it to our coach, and she says, hey, this person will look really good in that role. They have a lot of strengths there.
We like to, at the start of the season though, the first couple of weeks are getting everybody to try everything. So we'll have 1 week which is robots. Everybody codes a robot to drive, go in a square, follow a line, and then the next week we have a research challenge. We'll give them a problem to solve, and they go, okay, we will go and do research and come back with a presentation. Making sure that everybody has a try of the roles that they want to do.
What's your favorite role that you've had within the team so far?
Well, technically, every single year I've been in Team Apollo, I've been the PR, mostly because I'm really good at talking.
We know, Addison. We know.
But I think I would also like to be a strategic analysis or the motivator.
That's definitely a good role. I have been, for the past 4 seasons, I have been our team coordinator, you know, project manager, making sure everybody's on task. Yeah, I really like this role. However, as Addison also said, the motivator role sounds super fun. Keeping people hyped, bringing prize boxes, snacks every week.
I really like my role at the moment. It's the robot analysis, as you would have heard before. And the person who is robot analysis looks at the board with the strategic analysis or builds something with the building and construction. And overall just
is in charge of the robot.
Yeah.
The robot's his child.
Yeah.
Child.
Well, what are the roles that you have in the team? I've heard you talk about a few of them. I just want to know what they are and how they work.
So our team's roles, we have the team coordinator, which is like the head, the manager. Then we've got our 2 sub-teams, our robot sub-team and our research sub-team.
So the robot sub-team has the strategic analysis, the building and construction, and the robot analysis. Robot analysis also kind of doubles up as lead programmer.
And the research side has the lead researcher, the motivator, and the PR.
Yeah. So making sure that those tasks are spread out evenly across our team.
So it's just one person for each role, right?
Sometimes we double up. Sometimes there are 2 people want 2 different roles, and so we say, okay, well, you're half researcher and half motivator. Or you'll have a secondary role. So, for instance, we've had some kids that were strategic analysis, but their secondary role was programmer. They wanted to learn how to program.
We also have 2 lead researchers this season.
Because that was their interest.
Yeah, it's cool.
And like,
so you guys are quite inspirational within the FLL community. So who would you consider to be your biggest inspirations?
Oh man,
I don't know.
The coach?
Yeah, I would definitely say our coach, actually. I mean, just
she's inspired us to do it all.
Yeah, we've met up with other teams as well. Sussex Smashers are pretty cool.
Yeah.
We like those guys. We were next to them at an international competition, and we hung flags across each other's pit areas, and we combined games. as two of the Australian teams that were competing there. And it was really fun.
Yeah.
So yeah, shout out to you guys.
What makes your coach so inspirational?
Well, our coach is also our mother.
Yeah.
But yeah, she inspires us. She may not know. One of our old core values was coaches and mentors don't know everything, but she's willing to learn. She's willing to help, or she's willing to help us learn, even if, our coach is not very robot minded, but she's willing to go, okay, well, here are robot ideas. Here are websites that you can look at. Off you go.
Yeah.
So she helps facilitate our learning, and she's just inspiring.
So you mentioned core values. Does your team have any current core values?
Well, there are the 6 set FLR ones.
Yeah.
Discovery, impact, integration. We like inclusion, fun. We like to follow all of these. Fun. Our team is very, we dance, we sing, lollies everywhere. Inclusion. We're a homeschooling team. We put it out to everyone. Say, hey, who would like to join? Everyone's welcome. We
like to help others discover their calling.
Yeah, we like to learn. We like to take challenges and say, how can we fix this?
Challenge accepted.
Challenge accepted. Yeah.
What would you guys like to see in future FLL games?
Maybe bigger team sizes, because that would
be
open it up to more people.
Another thing I want to see on the board is a really tall mission. I'm talking a huge mission.
Yeah.
Also, I really want to knock down a massive tower.
Yes.
We had a small tower in one of the other in
Trash Track.
I think it was Trash Track.
Season.
Yeah. But yeah, I want to see a really big tower that we get to knock over. That'd be fun.
Are there any specific topics that you would like to be able to research in a future challenge?
Maybe something. This is just me personally, but something medical, I guess. That's a very broad range, but looking more at medical sciences, that's kind of where I want to go in the future.
I think more about kids.
Yeah, kids?
Yeah.
That'd be a fun season.
Yeah. Smokes over a kid.
Don't knock over kids, people. But yeah, I think, for me, definitely something of medical variety.
Do you guys have a favorite experience that you've had while traveling around the world for FLL?
The chicken dance, obviously. Meeting new teams. I think one of my favorite moments was, it was an Australian international.
Yeah.
And there was a team dancing in the middle of the pit areas. And I believe it was a Brazilian team, and it was one of their home country dances. And nobody knew all the other teams. We didn't know the song. We didn't know the dance moves, but everybody joined in. It was about celebrating, diversity. Yeah, that was definitely one of my favorite moments.
How have those types of teams inspired you?
Being able to go, all the way overseas, taking everything with you, going to another country and competing is definitely, and it's a really cool experience.
Yeah.
Teams that go to internationals they're really cool. They inspire us because, hey, if they can do it, we can too. Yeah.
So that's all we have time for today, guys. So thank you so much for doing your presentation and speaking with me. It's been really insightful to hear about your experiences in FLL. So I hope you guys had a good time.
Thank you.
Thank you.
Bye.
Bye.
Hi, my name is Sarah Heimlich, and I've been involved with the First Family of Programs since I was 10 years old. This program has literally changed my life. I started off as a very shy and quiet 10-year-old who would literally hide behind her mom at the grocery store. I didn't really have any ambitions in life and I had no passion. Today, I'm a fourth-year engineering student who's interned at Google, and I'm a member of the Australian Regional Planning Committee for FIRST. So I've told you a little bit about how I got involved, but let's go find out what drives some of the other students. Come on.
Well, about 6 years ago, some Americans came to my high school and did a presentation about this robotics team they were starting, and since I was into science and math, I decided that would be a good thing to go along to, and I'm still here 6 years later.
I always saw my dad working on like the car and like a computer and stuff, and I was interested in trying to help him, but I didn't know how. So when I realized our school had a robotics team, I was like, oh, I should try this.
So why robots?
Because why not?
It's a life-changing experience, and I like working with the kids and getting them to see what engineering can do for the world.
I've never actually thought about this until my school offered it to me, and they said, you know, we have a robotics program. And I said, what's that? And then they said, oh, you get to build a robot. And I was like, a robot?
They're cool ass, like the robots with us.
Every single time I see a robot move, I just get so happy.
All I knew about engineering was that it was boring. I didn't exactly know what it was, but I knew it was boring. And now, after 4 years of being on this robotics team, I'm looking at pursuing a degree in biomedical engineering, majoring in software engineering.
I love working with these young engineers. It's really inspiring.
Because robots are cool. What kind of robots are you going to be building for us in 10 years?
I look forward to being able to interface the human body with engineering and robotic technology, so like nanobots to go into a bloodstream or something like that.
Hopefully there's some kind of cleaner robots, because no one likes cleaning. People usually go, you know, I'm in a basketball team where I do dancing or something, but it's not every day they get to go, you know, I'm part of a robotics team.
They're going to advance the way we live. They're going to change the world, and it's going to be these people who change the world.
Like before I wasn't really interested, but now I'm like, engineering can be like my future now.
My family has been doing it since I was a baby, and I really like the idea of getting to do all this cool stuff that normal people don't really get to do.
I really want to see some really great advancements in the medicine area and medical engineering, because I believe that medical engineering has the capacity to really change some lives.
Hopefully flying ones. I really want a flying one. One that flies.
Something really awesome, hopefully.
I just hope it's a robot that will help someone.
Something that can fly. Ideas for the future haven't even been thought of yet, so hopefully I get to help in planning them.
So it has come to the end of our hosting time slot. I hope you have enjoyed the past 6 hours and the insightful presentation that took place. We will now be handing over to Raid 0 or 4253 in Taiwan, so make sure you stick around for more amazing STEM and FIRST content. To access this, please go back to the YouTube channel and click on the new live stream. Just to repeat that, go back to our YouTube channel and click on the new live stream that's available so you can keep watching more STEM content. Bye guys!